Gemini Control here again. Earlier in the flight, you'll recall at the start of the second revolution, we had a reference to several objects that the crew spotted. This was in the area of Antigua. Due to a mechanical breakdown, we did not have that portion of the tape available for you. This was a line breakdown between Building 30 and our news center in Building 6. Since then, we have dubbed a tape off the master tape here in the control center, and we are now prepared to play it for you. It contains references to sighting not only some particles, but as well as an unidentified object, plus the booster. Here's that tape. We'll play it for you now.
Gemini 7 here, Houston 98.
Loud and clear. 7, go ahead.
Bogey at 10 o'clock high.
This is Houston. Say again, 7.
I said we have a bogey at 10 o'clock high.
Roger. Gemini 7, is that the booster or is that an actual sighting?
What?
Say again, 7.
Okay, we have several, looks like the 3 up here, actual sighting.
You have any more information, estimated distance or size?
And we also have the booster in sight.
Understand you also have the booster in sight, Roger.
And we have very, very many, looks like hundreds of little particles going by to the left out about 3 to 4 miles.
Understand you have many small particles going by on the left. At what distance?
4 miles. Large, looks like perhaps a vehicle that's disintegrated.
Roger, understand they're about 3 to 4 miles away.
They're past now, they're going to pull her orbit.
Roger, and understand they were about 3 to 4 miles away.
Try the pier line, or further.
Roger. Gemini 7, Houston. Were these particles in addition to the booster and the bogey at 10 o'clock high? Roger.
7, this is, Houston, this is 7.
Go ahead.
I have the booster on my side as a brilliant body of the sun against a black background and with billions of particles around it.
Roger, what direction is it from you?
It's about at my 2 o'clock position.
Does that mean it's ahead of you?
It's affirmative. Ahead of us at 2 o'clock, slowly tumbling.
Roger.
OS 91. Fox 91. Oh, Fox 1, 9-1 second.
Gemini Control here again. The reference in that conversation to the third unidentified object, of course, the third object was bogey. There were several references to the bogey. This is the unidentified object in addition to particles which appear to be headed in a polar orbit, you heard Frank Borman say, plus Jim Lovell discussing the booster. It was Borman who reported sighting the bogey. This is Gemini Control Houston at 4 hours, 24 minutes into the flight.
Hotel Alpha Alpha, call Bahrain East 132.12.
132.12, Hotel Alpha Alpha.
And I'm beginning to get the brilliant blue of sun rising in the east. Bright blue band underneath all this haze layer. I can see the haze layer and the bright band of light demarcation coming underneath it. Quite distinctive. There's a faint hint to it. Here's where there are clouds, apparently. Roger, Hawaii, phase 7, reading you loud and clear. Roger, Hawaii, phase 7, reading you loud and clear. Roger, understand. Roger, I'm just small end forward, 180 degree yaw, approaching sunrise, over. Roger. These small luminescent particles drift away from you, small end forward. In this light, they appear brilliant white without paint all in them. They appear to move on out, curve around back towards the flight path. Can't hear, I don't think.
Roger, you haven't seen the beacon at this time.
Negative, I still haven't seen the beacon.
Sure.
There was considerable noise, though, as if something were departing.
Again, 7.
There was considerable noise of the little doors. Sounded like the little doors blowing open, so I assume the beacon has departed.
Roger, understand. TM looks real good on the ground.
Roger.
Okay, you confirm TV control switch to off.
Roger, TV control is off.
We had a slight decrease in the 2 links on DC current. Would you give us a readout?
Roger, DC current. Roger, main bus is 24. Isolated 28.5.
Roger. Hey, good. Gordo, this is Wally. Did you have anything to eat?
Negative, not yet. I'm planning to shortly here, though.
Right, for your information, systems last computations on fuel at Hawaii gave you 88 auto, 98 manual, which is somewhat better than you're indicating on board.
Roger, on board I'm indicating 96 and 102. Oh boy, what a beautiful shot of Florida.
Roger, looks good from here once in a while too.
Roger, the whole strait is clear. I can see I'm just about off. There's been a beautiful view coming over Florida. Now on 180 yaw, I got here on manual proportional control. I'm at last daylight going into dark. I've been looking for the flashing beacons. 50518 now. 28, I'm sorry, not 18. This light in sight, it is below me. It's quite a brownish, reddish brown, and considerable altitude above the ground. Every time I fire a pitch down thruster, I get a shower of these little fireflies. It is flashing now, it is the light. It's quite bright, quite discernible. 1, 2, 3, 4, 5, 6, 7, right. Appears to be about 10 to 12 miles away. I'm keeping it directly in the window. At the order of a second magnitude star now.
There's some pretty stars in sight. And also have the little white objects that seem to come from the capsule itself and drift off. And if they are a yaw check, it's fantastic. I suspect that the star I see is Arcturus. Would be very interesting. It is neither. It is one of the white objects. So I have two stars that are staying quite still. The white object actually looked like it came toward me, but it wasn't. You can actually see the particle there flying off, and as John described it as a lathe shaving. It's a very good description of it. My rates are now just about 0 in all three axes. I still have light in the periscope, of course. I'm looking straight up, and yet at this point, just to prove that my altitude is, if I get in the couch here, I really can't pick it too well. Yeah, I'm just about inverted at this point. And that my nose is above the horizon. As a result, I notice that these particles keep tending aft of me, relative to me, at any time. Periscope is blacking out rather rapidly at sunset. It's almost blacked out completely at this point and is really not usable. Getting a real burst of light in the window, and I really don't know what it is. At this point, I should be coming up on a sunset. 5 hours and 15 minutes. Periscope is dark. I must be just getting a last look at the horizon, yet I'm not down on it.
I have some more of the white particles in view below the capsule. They appear to be traveling exactly my speed. There is one drifting off. It's going faster than I am, as a matter of fact.
Roger, understand.
I haven't seen the great numbers of these particles, but I've seen a few of them. Their motion is random. They look exactly like snowflakes to me.
Roger, have you tried return?
Negative. Let me get within scanner limits first.
Say again.
I must adjust my attitude to within scanner limits first.
Roger.
There were some more of those little particles. They definitely look like snowflakes this time.
Roger, I understand your particles look like definite snowflakes.
However,
You shot?
Roger.
There's the minor question. Well, there's an object on the line in the water. It's about 160 degrees. The NSA people suspect it's the sky marker that didn't activate. I'd say it's about 3/4 to a mile out from the capital after the lift out. We can take a check on it.
A few very bright particles or fragments or something that go drifting by as we maneuver.
Roger, understand.
Yeah, there's a whole bunch of big ones on my window down there. Just bright. Looks like the 4th of July out Ron's window. Yeah, now you can see some of them in shape. They're very jagged, angular fragments that are tumbling.
Roger, they look like fluid of some sort?
Not to me. They look like pieces of something.
Roger.
They're very bright.
Jack, we'd like Omni Charlie.
Bob, for the most part, these fragments are not, are tumbling at a very slow rate. I've tried a couple pictures of them at different settings. You may get an idea of what at least the patterns look like.
Roger, I got you. We're all ears on these fragments. Do you think you can figure out what they might be?
Well, you know, I don't know. There are a number of possibilities. If you had some kind of a... I got the impression maybe they were curved a little bit, as if they might be off the side of the S4B. That's a wild guess.
Okay, RCS logic is...
ice jump, possibly. Maybe there's paint coming off of it.
Right, I noticed on one trip up the elevator last week, one of the flags, I thought it was in the S2, but it might be on the S4, looked like it was peeling. Maybe that's what you got. And the S4B maneuver is complete.
1 minute. Okay, we'll set the o'clock. Okay, and with the maneuver complete, the fragment field is essentially static, except for very slight tumbling within the fragment.
Roger, copy that.
Every once in a while, a fragment of considerably higher velocity than the others goes across my window, but that's very rare.
Roger.
Okay, that's that field of view I saw on my window deck. You see it now? Yeah. And Bob, at least there's no apparent relative motion between fragments.
I do understand.
I'll take 2 pictures about a minute apart if I can, and it'll be frame 70.
Okay, frame 70.
And Bob, Gino, my impression is that they are flat, flake-like particles, some maybe 6 inches across, and although there's no relative motion between the two, most of them seem to be twinkling, and I think for the most part they're all moving away from us.
Listen, we read this paragraph in here about these, quotes, coronal discharges that you guys were seeing, and that completely stops us. Tell us how this came about, and who talked to you about it, and what you saw.
We reported it on, or somebody reported on one of the earlier flights that some guy up, I got the letter, his paperwork somewhere, they shipped it down to me at the Cape about 2 things where the VHF radio noises, which could be discharges from someplace in space, and the other one were, I thought it was on Neil's flight, these guys reported seeing flashes in a spacecraft at night with their eyes closed. Or no, they noticed them when they were awake at night and the spacecraft was dark, and they thought they were in a spacecraft. But whoever this guy was said, no, that's a perfectly known phenomenon. You can get discharge across your eye from gamma rays or something. So he had a bunch of things. Would we close our eyes and face the moon, when we were orbiting it, because it would be more, we'd get less discharges facing the moon than away from it. Well, you don't have to be anywhere near the moon or anywhere. The first night out, bing, bing. And if you keep your eyes closed and you're awake down there and it's dark and you think about it, when it happens, you can figure out, you can sit down and it's one eye. It's not a discharge that you see in both eyes. You really see it with one eye or the other eye, and you can see what kind it is. We had 2 kinds. I guess the particle either strikes the eyeball perpendicular or it discharges parallel. And we get either a flash like that or we get a streak. And I don't know what that I noticed. I either got a flash or a streak. And I, for some reason, got it more with my left eye than my right eye, but I could tell which eye it was when I was concentrating on it. I'm trying to tell you the reason he did it because where he slept was always on the left side of the spacecraft. That stuff kept whistling across there, and I saw all the right ones in my eye.
Yeah.
I perfectly symmetrical. I split out of
They should have protected you, Dick. They should have picked them all up.
I may surprise you didn't hear about this because we were asked to specifically experiment with this kind of thing. There's 2 pages in the flight plan, a lot of it. We didn't bother because we were seeing every now and then. There's a paper that says now, the exact thing, the 2 phenomena that came out of 11. Buzz and Neil talked about this.
I remember their conversation about it.
Sure. They thought it was something, penetrating the spacecraft. What Pete described is the exact phenomenon that all 3 of us saw. You see a light, just a flash out there, or sometimes it'd be a streak. And I saw them in both eyes, either eye, and I can't remember if there was one that was more predominant than the other. But I agree with Pete, it's a phenomenon that you're
not seeing with both sides. It's not something external to you. It's something that's
inside.
discharging, coming across with that one arm. Apparently they know that. Apparently it's a completely known phenomenon.
Well, we've been looking for cosmic rays, cosmic ray strikes, and heavy particles, heavy nuclei that go through. We started at Clearback and Mercury, taking photographs of the retina to see if you could see streaks across the retina and stuff. We never could find any in there, and so we stopped that up early in by the end of the.
Your eye is what the fastest healer on your body, and if it's doing anything, you're never going to see it. By the time you get a guy back, the only way you're ever going to see it is if you photograph it right after a particle went by.
Well, probably what it's doing anyway is probably hitting just a single cell, and yeah, that's all it'd have to do. Particularly make this flash, you hit a single cell.
I saw one night, looking at the MDT, a handrail up above, and one right along, I don't know where it went. It appeared, right straight along that handrail for about that distance. And I just got to be looking at that, and you could almost see him at will. That's right. You just lie there. You close your eyes. What if they don't want to see one? You open one eye, and you have to already see it. You didn't believe it at first. We thought it was really nice. And I know that hey, I've been sitting spring-loaded from that. What we heard. I had seen him and got playing in the beach, and they said the middle of the mission, you wake up at night and say, well, I think I ought to see something. You can close your eyes on the face, you count about 1 minute.
Let me ask you one more question about heart. Here.
Were these random distribution of these or did they seem to be fairly horizontal?
Okay, were these things random, or did they all seem to be in one direction? Like, were they always horizontal, or were they at random? They could be at any kind of angle.
But the streets I saw were mine. One I saw were horizontal. I was going to say that's interesting. Mine, it seemed to me I had the impression that they were always roughly in the same place, and mine were horizontal. The horizontal streets were always, if I knew where I was looking, it always seemed like the horizontal street was a little bit above the center. And it always seemed to me it went from right to left, no matter which eye it was in. The discharges were more towards the center, and it would be just like a pinpoint of light went and closed again.
Like somebody was flashing a light at you.
That's right. Generally not too big a light at you. It wouldn't fill your eye. Very small dot. Just a.
Is that about the same for both of you? Is that the same reaction you had, Dick and Al, the way Pete described it?
Mine were right about 30 degrees horizontal, but they were coming. I didn't notice them from the right or left.
That's pretty interesting.
Yeah. But about the same, they seem to appear about the same place. No?
The horizontal ones that I saw were generally above eye level.
Same way, yeah.
Was generally high. Now I don't know, I can't exclude any other. I can't remember. I just don't remember any of them being down on the lower part of the vision. Well, I you see, Dick's telling you about seeing him with his eyes open and other things that each center's eye on the lights on the instrument panel. Well, I used to notice them the most when I was down there in that sleeping bag. It was pitch black down there in the hole. It wouldn't make any difference whether my eyes were open or closed. But I could lay there I used to kill time that way, say for a half an hour, and either open them or close them and wait, and sure enough, after a while, you'd get one. And then I'd sit there for a while and say, okay, was it the left eye or the right eye? It'd take you a while to sort it out. But you usually figure out which eye it was in. Now you know what you do when you're supposed to be sleeping.
Yeah. There was a comment that...
And now at 1 hour at this time, I now have 1 hour and 21 minutes, and I am observing John's fireflies drifting away from me. I can observe them appear to be departing from the spacecraft and drifting out to the rear. I can see some of them a considerable distance out to the rear. Sun is coming up behind me. I'm beginning to get the glow on the clouds. Fireflies appear to be white, very whitish, with almost a green like real fireflies. Clouds on the earth below are changing color, are getting quite light. I am now on the day side. The sun is not yet quite up, and I am observing stars. The earth is light below me. The sun is still behind me. The sky looks dark above me, and I can see stars very distinctly.
That's not the flavor. Gordo, you expressed interest at one time in unidentified flying objects, the feeling that there might be something to all these stories. Do you still feel that way?
Well, I feel that there have been a large number of fairly well qualified, or exceptionally well qualified, I should say, people who have seen objects that have not had any really logical explanation other than this. I think that maybe in fact each and every one of them does have an explanation. But I think that there are so many possibilities, so many thousands of possibilities of other planets out somewhere in the universe that would have a livable atmosphere, that I would hate to rule out the possibility that maybe there are people or some type of human life on some of these. And if this is the case, then it's not too unfeasible to think that perhaps some of these objects might have been something of this type.
You don't think that the comparatively short step out into space that the Mercury flight will take you on is far enough out to make any observations in this area?
No, I think we're still at a fairly low order of getting out into space when you speak of space and being millions of miles involved. We're only getting out 100 miles or so.
What about the so-called Glenn effect, Gordo? The snowflakes, the fireflies. Now both Schirra and Carpenter seem to feel that it's frost of some nature off of the capsule, but apparently Glenn still sort of casts doubt on that theory.
Again, the areas in black are the total area covered, which we obtained from the mission, and the areas in red are the pieces which we missed due to the deletion of the plane change and the day early return. This little piece down here was an oblique pass which we had planned with the pan camera. Would have taken place on Rev 72 in order to get photographs of Descendi, which is an area of particular interest to the geologists. So you can see that we did lose some data. On the other hand, we did pick up some data that we would not have gotten, and I think overall the effectiveness of the coverage was about 90% of what we had hoped for pre-mission. I really want to express the thanks of the photo team to the flight planners here and also to Ken for his operation of the cameras during the mission. I know that it was very confusing to be continually changing the flight plan, and Ken probably wondered what the hell we were doing with all these on-offs and so on. But really I think we did a very effective job of recovering almost all of the data that we had planned for the mission. May I have the next slide, please? This is a diagram showing what the Apollo 15 coverage was like This is the planned coverage for the 16 mission, and in the dotted line is the planned coverage for the 17 mission. The only reason I show this is to indicate that the areas where we did lose data, unfortunately, are in the areas that were not covered by 15 and will not be covered by 17, so that the losses, although small, were real. The next slide. Ken, during the film recovery EVA, you reported that the stellar camera glare shield was hung up on the handrail. I'm not 100% clear as to exactly what that situation was. This is the stellar camera glare shield, and this is a little cover that comes down and covers that when the mapping camera is retracted. Maybe you've discussed this with the other people here at the center, but for my own information, I would like to know whether this is the cover that was hung up or this is the cover.
Both of them. The shield at the forward end, that one.
This one?
No, the first one you looked at, yeah. That was sticking up.
That was sticking up,
Yeah, but the tip out here was mashed against the handrail.
Mashed against the handrail out along here.
Yeah, the rail isn't in this picture.
The rail is not
installed.
It would have been along here.
That's right, and this lip was up against it and bent back out of the way.
I see. Well,
it was not in a full extend position. It looked like it was a partial extension.
Could you tell whether this was bent, whether this rail was bent, this extend rail?
No, but I think we have a photo that probably tell you that. I don't remember. The end of the shield was bent. Now, whether that
here.
rail, no.
Here.
Yeah, in the next section of the accordion, that one.
Was bent.
Yeah. Now, whether that rail itself was bent, I didn't notice.
The implication, of course, is that if this had happened early in the mission and this shield were bent down, we might get excessive light into the stellar camera, and our background density would be low, or would be higher than we expected. We might not see as many stars. The other indication of malfunction that we had, of course, was in the exposure control on the pan camera, and that would indicate that the pictures away from the terminator may be overexposed. That situation is also being looked at, and again, we're going to talk about it this afternoon before we actually process the film. May I have the next slide? This is the information which I have with regard to the laser altimeter operation. The first row across here is what the nominal mission would have been, and the second row is the actual results from the Apollo 16. We had planned a total of 20 hours and a few minutes of operating time. We got 14 hours and a half, so that we are down about 25% in the total operating time. This is the total revolutions in longitude that we had planned, 10.3, and we got 7.5, so again we're down about 25% in that regard. A total number of firings, 3283 and 2106, is the actual number that was recorded. So we are down nearly 30% in the total number of firings. Also, the number of valid elevation readings that we got was appreciably less than the total number of firings. So that the actual mission in terms of altimeter observations gave us a little bit less than half of what we had actually planned. That's really not as serious a shortfall as it sounds just from the numbers, because the readings were quite well distributed throughout the mission. The general operation that we saw on the altimeter, the first several revs were completely nominal. All of the elevation readings were valid. Then it began to fall off about 75%, 65%, and down to about 60%, except on the last data pass on Rev 62, where it was only about 10% effective. Generally, what we seem to observe is that there would be one good shot, then one bad shot, then one good, one bad, and then maybe several good ones in a row. We can talk about the reason for that, but that's more appropriately covered in the systems review tomorrow. The effect that it will have on the data is simply to give us a larger spacing between data points. So far as its effect on the reduction of the photography is concerned, that's absolutely inconsequential. So far as its effect on the correlation between the tracking and gravity data and the profiles, it's a little bit more of concern. They do have a little bit more smoothing to do between the data points that they got, but essentially I don't think that it really hurts us so far as the scientific return from the mission is concerned. I would like to say just a word or so about the utilization of the photography. It has been proceeding much more slowly than I had anticipated in reducing the pictures from Apollo 15. However, the work which is being done by the ACIC in St. Louis is indicating that the photographic reduction will provide positional coordinates of features on the lunar surface with the accuracy of 10 to 12 meters in position and in elevation. And that seems to coincide very well with what we had predicted pre-mission. So we are quite confident that we're getting very good information from the pictures in that regard. The tracking data generally is consistent within an orbital path, but we do find discrepancies of up to a kilometer between adjacent photographic passes, so that the reduction of the photographs is giving us a much better tie between orbital passes than we get from the tracking data itself. Consequently, we do expect eventually to come up with an internally consistent coordinate system, reference system, figure of the moon, with an accuracy on the order of 12 to 15 meters. That's highly gratifying to me. So far as the pan camera utilization is concerned, there have been some map compilations done. The indicated precision of those is on the order of 3 meters, which again is about what we had expected. But that is a precision and not an accuracy number because of the geometric problems with the pan camera photography. However, so far as the resolution of the pan camera is concerned, that has held up to just about what we had expected, from 1.5 to 3 meters at the sub-vehicle point and decreasing off to about 5 to 6 meters at the limits of the film. So far as our indications at the moment are that the results from 16 are quite satisfactory. We do have these problems that we have to resolve in the processing of the film, and once that is done, we will be able to say exactly what we did obtain. But again, I want to express the photo team's thanks to you, particularly Ken, for the time and attention that you gave to the camera operation and the results that we have obtained.
Thanks, Fred. Any questions before?
Do you have a plot of the altimetry? You know, last time someone had drawn up a rough hand sketch of the altimetry. You know, did anyone do that this time? The
profiles?
Yes, sir.
No, I don't, Ken. I think maybe Sjogren has one of those, and I don't. Is he here, Bill?
Yeah, Bill.
Yeah. Do you have a plot? Yeah, I thought you had one.
Okay.
He'll show that.
Okay, and these particles that you found in the mapping camera, is that handfuls or a couple of shavings or?
I don't know how extensive they were. They were enough to concern the people in the processing lab. All I know, that's about all that I know about it. We're supposed to have a review of that this afternoon. It could have very serious implications, obviously. One thing that I seem to recall from during the mission is that we had apparently more film left for post-TEI photography than we had anticipated. And what that could mean, of course, is that the camera was not passing film when we thought it was, and things were being chewed up pretty badly inside. So we're going to have to look that over very carefully before we go ahead with the processing of the film. We expect the camera contractor to look at the shavings and tell us where he thinks they came from, and that may give us a better clue as to what they actually are.
Do you have a processing schedule yet? I guess it's all in advance to figure out what to do next.
Everything is in a hold until this afternoon, after our meeting this afternoon.
Assuming you determine to go ahead and develop it, what will it take you, 3 or 4 days to process?
Yeah. I think the anticipated schedule was to have the original film processed within this week and all of the duplicate copies within 4 weeks out and distributed.
Perhaps you stated it. What is the accuracy of the altimeter?
The least count of the altimeter is 1 meter. The accuracy is dependent pretty much upon the slope in the area which is illuminated and a little bit on the albedo in the area which is illuminated. In general, I think it's fair to say that the reading that we get from the altimeter will be correct to within 3 to 5 meters.
Have you figured out what to do with the pan camera for processing? Have you got a correction for the
overexposure? I don't know what has been figured out. We had a group working on it last week, and they're going to give us a report right after this meeting. We'll decide what to do.
Yeah, I could comment on Federal Lab has made a recommendation for broadband processing, and they think that there will be some slight loss near the terminator if they would do that. In other words, that they can handle the overexposure, but at some penalty where we have minimum light. And the question is whether there's anything else you can say about that penalty, like cutting it up into pieces, which is not much.
The situation is really that near the terminator, the pictures are underexposed anyhow because we can't open the slit wide enough and so on. So the camera was wide open at the terminator, but it was open wider than it should have been when we were away from the terminator, so that the terminator pictures are a little bit underexposed. Then they become properly exposed, and after that, they will be overexposed. So what we would really like, of course, is a variable processing through each photo pass, but that's probably not a feasible thing to even contemplate.
Thanks, Fred. Next subject will be the particles and fields of the subsatellite, and I think Jim McCoy is going to cover that. Is he here?
Yeah.
Oh, there he is. We got a mic right over there.
Do we have anything at all?
Yeah, they'll project it up there in the back booth if you want to.
Okay.
Dick, where's Baldwin? Could you get this projected up there?
I guess put the mic on. Okay, can you hear me okay? Okay, yes, quickly, the subsatellite was deployed successfully. Our spin rate was nominal, about 5 1/8 second spin period. We want 5 plus or minus a couple. The attitude was good. According to preliminary indication from the sun sensor, we're have a couple of degrees tip off from the ecliptic, which is well within the limits we needed. The operation of all of the electrostatic analyzers and both solid-state telescopes is good. We don't seem to have the noise problem that we had on Apollo 15 and a couple of the analyzers. And we've, of course, gotten rid of our accumulator counting error that was characteristic of 15. It's given us some problems in our data analysis now from that satellite. The quick look results on our first magneto-tail pass indicated again the presence of these unexpected, rather high fluxes of low-energy protons. which have also been seen now with a new IMP Series I satellite, Experiment 2. And on this magnetotail pass, we appear to have the remnants of a small solar event in the form of some high-energy solar cosmic ray electrons and protons around, which should prove interesting for our shadow interpretation, particularly on electric fields in the magnetotail. Beyond that, if they have those slides there, I'd like to briefly describe some of the results we got from Apollo 15, which would hope to be similar to this one. Our primary experiment was to examine particle shadow configurations in the magnetotail. That'd be while we're passing through this region back here where we are in the Earth's magnetic field, and use that to examine the question of openness and access through the magnetotail to the magnetic field lines and ultimately to the Van Allen belts, where theory generally holds that the Van Allen radiation must somehow come in and then be trapped and accelerated. The degree of connection back here with the interplanetary field has been in quite a bit of question. And briefly stated, the Apollo 15 results indicate pretty clearly that at least most of the time at the latitudes where we passed through the tail, of course we only have a couple of passes, that these field lines are in fact open out here, connect directly into the interplanetary field, and have direct access of solar cosmic ray particles. We have also observed the existence of a plasma sheet which is known to form in closer to the Earth to extend out to the moon's distance. And on at least a couple of occasions we have observed cross-tail electric fields, which are important to theoretical models accounting for aurora and for acceleration of particles into the radiation belts. An unexpected observation, which we found interesting, was 30 keV or thereabouts protons in very large numbers, which we observe quite frequently back in the magnetotail and also have observed outside the magnetotail in very similar fluxes. Our first feeling was that these must also be some component of the solar cosmic ray proton spectrum. They're, of course, very low energy, would be stopped by even the thinnest piece of material. But the numbers of them and the consistency of their flux densities make them very attractive as probably being quite indicative of the source that they come from and the mechanism bringing them. Further examination, however, of the locations where we see them and of the almost constant intensities that we see almost force us to the conclusions that they must somehow be protons from the outer Van Allen belt region here, which are somehow coming loose from the Earth's field and moving outward and then getting onto the interplanetary fields and then moving out to where we see them in perhaps an inverse process of the postulated process where we bring solar cosmic ray particles in from the sun to populate the Van Allen belts initially. We're anxiously awaiting getting our data, and now our computer programs at Berkeley in shape where we can examine this in detail. We've unfortunately been delayed in that. If I have the next slide, I'll show you one orbit of data from the telescopes when these very steady fluxes of protons were present. And during this period, and actually for a period of a couple of orbits earlier, these fluxes were almost constant. There is some changing here. There is a very, very slight shadowing of protons, not very much at all. This is motion electron phenomena. But then these particles essentially turn off as though somebody closed a valve. And this is characteristic of the way they behave. When they appear, they're suddenly there, and when they disappear, they're gone just as fast. And we're very hopeful that we'll be able to make some sense out of what turns these things on and off and determine where they're coming from and what the mechanism is, presumably now in the magnetosphere. Okay, I think I'll just throw it open to any questions now.
Okay.
What is the lifetime estimate of the 16?
Wish you hadn't brought that up.
It's going to be very
speaker
short.
will get that for us. We had been very hopeful of getting another dozen or a couple of dozen magnetotail passes out of this satellite since it works so beautifully. And
I think we're going to cover that. Yeah.
Chris said it was going to stay up there forever, so it better.
Well, if it doesn't crash, we hope it will.
The world's going to come to an end pretty shortly, I'm afraid.
We'll see.
Any questions about particles and fields? Okay, let's continue on with subsatellite and get on the map.
Oh, we didn't say anything about it. I assume that our satellite is sending out good data.
Is batteries are charging okay and everything? It's not running into the problem that the 15 guys had, or was that normal for the?
It seems to be a little bit better battery charge.
Yeah, the machine is working.
Okay, and all the detectors are operating.
Yeah. As far as we know, yeah. It's just that it's got a short lifetime. Okay, let's see. I think Larry Sharp is going to take Coleman's place, right? Okay. Magnetometer.
The objectives of the magnetometer experiment are essentially threefold. First is to measure and map the remnant magnetism on the lunar surface. Second is to map the electrical conductivity of the lunar interior. And finally, study the various aspects of the moon's interaction with fields and particles in its environment. The wide scope of these objectives is made possible by the geometry of the moon's orbit as it passes through three fundamentally different regions of space. For example, to get the spatial variations of remnant magnetism on the lunar surface, one must be in the geomagnetic tail, where the temporal variations are almost absent in the magnetic field. Very steady situation. The initial orbit of the subsatellite was somewhat lower than Apollo 15, and the inclination about 11 degrees instead of 28. And I'd like to show you the predictions of the orbit.
Right over there.
On the backside.
Backside of it.
Okay, we've plotted days past deployment versus the parallel altitude. Okay, we started out here in pretty good shape, about 97 kilometers, or 97 by 123, I guess. And the prediction was a very rapid drop down to 30-some. Then back up in good shape. No real trouble until, here's the ground line, until about 200 days when the probability was 50-50 of a crash. Here are the error bars here. You could say the probability was maybe 1 chance in 10 of a crash here and maybe 1 chance in 5. We've updated this plot. And the odds have changed considerably. This was the prediction. Notice the time scale has been expanded greatly. These are hours now instead of days. Here was the initial prediction at 37 kilometers, and here are the actual data points. This one was taken this morning, around in here, and if you can extrapolate by eye, it looks like we have about 4 days left. I guess Bill Sogren's taking 50-50 odds that it will crash if anyone's in the betting mood. It's possible that we'll skim the surface and come back out. But even if we make it through this one, that next dip is going to probably finish us off, which is most unfortunate.
Curiosity, might be out of your field, but how come our prediction didn't match the actuality?
Right,
I mean, we.
You gonna come up?
We have a gravity experiment. We don't know the gravity field that well, and that's the business of this sub-satellite initially to determine the gravity field.
You're going to throw that though, I think.
Right.
Okay.
And we've been screaming like heck about these pads that I know Bill Wallenhoff here at MSC has tried to drive that point home so many times, and I think we're really seeing it come. Man.
Just goes to show you can't redo 6 months of planning in 2 days.
Well, in any event, we have 1 month's worth of good data, which we'll add to our Apollo 15 results. And to get some idea of what we're doing with this data, I'd like to show the first slide, which represents an average of 17 different orbits taken when the moon was in the Earth's magnetotail. And we've plotted the moon's longitude along the horizontal and the magnetic field in gammas along the vertical. These numbers are representative of the Earth's tail field, and of course if you subtract out an average value, this residual would represent the lunar surface field. And of course the big result is this really huge magnetic dip going over the Van de Graaff crater, or a region right near the Van de Graaff crater. Also, the other initial result we got out of 15 data was that most of the dips in the magnetic field seem to be clearly associated with craters lying within a few degrees of the ground track defined by the orbit of the subsatellite. We've numbered the 7 most obvious local minima and named five of them with associated craters. Initial results from Apollo 16 show the same type of structure, although we don't see anything as big as Van de Graaff. We do go over Korolev again. That's where the orbits intersect when we're in the tail. And we see a few other Hertzsprung and Pavlov type bumps. One is with a little tiny crater called Stein, and one near Mendeleev. Now, if you repeat this procedure several times with different lunations, so you cover different tracks over the moon, and this allows a contour map to be made. So if I could have the next slide. This shows the ground track from where we found the anomaly. Here's one over Hertzsprung, Korolev. Here's Van de Graaff. You can see we went right close to the northern border. Pavlov, and one over Milne. So it was a pretty good one-to-one correspondence with large craters. The initial 11 orbit, of course, is much near the equator. The inclination goes up to plus or minus 11. So we saw one over Korolev, and Stein crater is located right about here. It's not too big. Okay, the next map shows a compilation of a lot of these linear profiles, next slide, into a contour map. It's a little hard to read the contours. You can see this big black blotch here is a result of contours stacked on top of each other near this Van de Graaff anomaly. You can see the numbers are hard to make out. You can see the structure over Korolev, a hint of some structure over Hertzsprung, and the Southern Sea over here is actually an enhancement, sticking out of the moon, so to speak. You can see Milne shows a definite structure. Now, the Apollo 16 results should enable us to expand this map. We'll get better resolution throughout this area and be able to extend it along in here. We'll probably still have a gap down in this region.
Murray, can you give some idea of the gradient you're measuring there?
Oh, yes. Okay. The numbers presented on the chart, if you can see them, are measured in tenths of gamma at an altitude of 100 kilometers. So, for example, a good representative value is about 30, and the 0 we've arbitrarily chosen at the bottom of the Van de Graaff dip, since this is the lowest value of magnetism we observe. We just called it 0 and scaled everything relative to it. So, if you're at 100 kilometers, you'll see a 3 gamma dip going over Van de Graaff on the average. Well, we were fortunate also the near side of the moon.
Does the gravity profile have any? Can you correlate?
I've looked at the gravity profile, and it doesn't seem to correlate at all.
We don't.
Actually, the laser data correlates better with. You don't. There's no gravity on the backside. Okay, but on the front side.
Understand.
It correlates pretty well with the laser data, which shows a great big hole here in the backside of the moon around Van de Graaff, and that's where we get our big hole. But I can't see any scientific justification for connecting the two results.
I will add, they remind you the gamma ray.
Yes, that's true.
Secondary peak is also at Van de Graaff. I don't know what it means.
Could be an alien star base or something. I don't know. Anyway, the next slide shows the front side of the moon, and it's upside down. The thing to contrast is the much smoother nature of the. Could we do a 180 on the slide, please? Can you hear me?
Could we turn the slide around, please?
Oh, he's on a coffee break. Okay, right. Anyway, the front side of the moon is much, much smoother than the back side. The variations are, on an order of a factor of 10 smoother. We don't see very much structure at all. It's very hard to even draw contours.
Can you sort out the differences in that and the effects of running through the Earth's magnetic field effects? Since the front side is always close to the Earth, can you sort out? Are we really measuring magnetic variations on the backside caused by being on the backside, not due to our measuring environment?
All right, the Earth's tail field is very, very constant when you're in the good section, when you're away from the neutral sheet, and that's where all this data is taken. Well, I guess we never got the front slide complete. Okay, this is a blow-up of the Van de Graaff region in an attempt to pinpoint the exact source of this large anomaly. We kind of suspected it was over the crater itself, since we had always put forth a theory that what we were actually observing in these dips was some sort of a meteorite impact that caused a rather uniformly magnetized crust to suddenly have holes in it, and we're seeing the equivalent dipole of what was left over, and this kind of shoots holes in the theory. We see this is the BX component, which is the radial component, and a plus number indicates a value sticking into the moon. So we see this rather large hole here magnetically in between two craters, and if you look at various models of double dipoles and stuff, it just doesn't quite fit. The other components, B sub y and B sub z, show that it can't be one of these angling dipoles from the crater. And presently we're now conducting the same sort of studies over the rest of the anomalies to see if it checks out. I've just yesterday completed the one over Korolev, and that one is right in the middle of the crater, which is promising for this shock demagnetization theory.
How much validity do we have in the ground track data relative to the far side?
How much validity? How much validity do we have in the ephemeris? I understand there's no chance that we could be off by.
Never. Anything like that. It might be off a kilometer or two, like I said. But now you're talking about 5 readings there. That's 150 kilometers.
So it doesn't seem much chance. We'll get maybe one more as the sub-satellite comes crashing down on the moon. The last 10 kilometers should give us a good swath of data, which will give us another high-resolution plot like this. But other than that, we're kind of out of luck. Okay, I think I'll...
Okay, thank you. Question?
Okay.
There's the front side of the moon. Okay, and our coverage from Apollo 11 will extend. Yeah, I believe this is the equator across here. Oh, I'm sorry. Okay, this is 0 degrees. Okay, and we go from 0 to 90 east to 90 west. It's the terminator. This is the Southern Sea region, which is about the only distinctive feature on the front side per se, and even that's on the terminator. And again, these are relatively high values of magnetic field sticking out of the moon. So you might say that the Southern Sea is a highly magnetized region. Notice the 16 site is out of our coverage, as were all the Apollo landing sites.
You have about a 3 gamma delta on the back side. What do you see on the front side as far as delta?
Well, most of these values are about 30, 28, 27, which means they're all 3 gamma higher than that 0 at Van de Graaff. So I would say the maximum plus or minus is about a half a gamma on the whole front side.
Why do your anomalies elongate parallel to the track?
This is a function of not having quite enough data. Instead of making physical-looking contours, we drew actual contours with the data. And obviously, if there's a little bit of offset from one orbit to the next, it's going to result in elongated contours. If we fixed this up and made some intelligent-looking guesses, they would be much more circular.
Do you have a data on the Apollo 12 and the 15 and the 16 surface data?
Yes, with 12, 14, 15, yes.
Yeah, well, how do you correlate with the information on the surface?
Well, you see, the surface data deals with much smaller scale size phenomena. And so there's really no one-to-one correlation. I suppose that the
Apollo 12 site is supposed to was 30-some gamma, supposed to be large scale, several kilometers.
Well, if we could be sure that over a region of 100 kilometers that the average field was 38 gamma, which no one would bet on, then we could make some interesting predictions about other places on the moon. But I suspect if you went down to Apollo 12 and went 100 meters away, you'd find a much different value of the magnetic field. We noticed the case. Look at Apollo 14. They went 1 kilometer and they went from 43 gamma to 103 gamma. So who's to say what's a representative value for the magnetic field in a given area?
How about 15?
Apollo 15, they saw a steady field of 6 plus or minus 4 gamma, which is essentially 0. But there again, behind the next boulder, probably could be 100 gamma, for all you know. And the results on 16, I thought, were tremendous. The tremendous gradients they got between one place and another. At 313 gamma field really surprised me as far as getting a value that large. Yes?
Have you seen any distinctive features about the correlate which might make you think that it was, say, a hot spot that had been discernible near the surface and the less soil covering, which would change the surface temperature at that point, which would then change the magnetic field?
No, I'm not a geologist type.
Well, I already know about 17.
That would change it.
It would seem to me that the younger a crater was, the more chance it would have to produce a good, clean-cut signature on the magnetic field data. For example, Van de Graaff itself looked like a fairly young crater because there's very few secondary craters in the bottom of it, so it looks fairly young, whereas things like Hertzsprung seem to be fairly old. They're well blotched with secondary craters.
What is the distance from the center of Van de Graaff to the center of the anomaly?
It's 80 kilometers from the northern rim. So from the center of Van de Graaff, it's about 130, 140 kilometers.
Any other questions? Okay, thank you, Larry. And, yeah, got a question? No. Last subject will be the transponder. Bill Sogren.
This is a gravity experiment, and we monitor the gravity by just monitoring the velocity of the spacecraft, or the LEM, or the subsatellite. Of course, on this particular mission, we lost our LEM data on impact because it started tumbling, and so that data was lost. We do, however, have the CSM in the low altitude orbit, which is very interesting data. Here's the orbital track, and hopefully I can get this aligned. About like that. This profile just below it is the gravity anomaly that was detected. This line right here represents zero gravity center isostatic equilibrium, and anything below it, of course, that'd be negative gravity deviations. Here we are at Ptolemais going essentially over the center with the track, and we can see the large negative anomaly again, almost 100 milligals. Here we see some Highland material where we have a positive. Then we drop down into a relative low in between these two old craters, Hipparchus and Albategnius, and then a high in here. At this point, there's the Descartes, the landing site, and we're actually at about a 50 milligal negative anomaly in that region. There's some nice correlations here with the laser altimetry measurements. I'll show them in the next profile. But this is continuous. I've just taken one small section here. We have this thing from limb to limb, so about 110 longitude plus to 110 minus. And essentially 3 revs, from rev 3 through rev 11. That's 8 revs. 8 revs of data that were pretty good. And then they started their station keeping, and our data kind of got garbaged up a lot with all the maneuvering that was going on. Let me point out one kind of interesting thing here. Notice that Ptolemais here has an anomaly much lower than Nubium, although Nubium, which is this region right in here, this Maranubium right in here, is still at about minus 50 milligals. Here's an altimeter profile, and going right to the Nubium Ptolemais region again, we see that Nubium elevation here is by the way, the scale here is 2 kilometers per heavy line. So we've dropped down here almost 2 kilometers from the floor of Ptolemais to the floor of Nubium. Yet the gravity anomaly is just the opposite. That Ptolemais is some 50 milligals lower than the Nubium region. And another interesting point is, Fred, on these ACIC maps, Nubium is shown a kilometer higher than Ptolemais. And here we are 2 kilometers lower, so we're talking about a 3 kilometer discrepancy in just that little area right there. So I think some of these guys were talking about the right thing when they said we really didn't know the altitudes too well.
I think that shows up quite dramatically when you look at the low sun angle view as you approach the terminator, that things that were in Nubium didn't show up until significantly after we anticipated. We missed our times on those things a great deal, and that could only be called by having a discrepancy in our relative heights.
Yeah, this is not just, this is Rev 28. We've looked at, there are 5 real good laser tracking passes over this region, and we've looked at 3 of them, and all 3 show the same consistency of the drop there. Other interesting thing here, Procularum, Tranquillitatis, Fecunditatis, all seem to be about on the same level. Smithii, again, being a low about 4.5 kilometers. That was the same thing on Apollo 15 when we passed over it. It was some 4.5 kilometers below as mean radius here. And we're still referencing this to
a 1738, well, 0.1 radius off the CG. If you take this stuff and start fitting it to an optical center with a CG offset, that you do indeed get the 2 kilometer shift again of the CG being closer to the Earth by some 2 kilometers.
Let's say that Tranquility is about 2.5 kilometers lower than Descartes.
That's right. Yeah, here's the landing site right in here. And we had a negative gravity anomaly in here. Well, kind of according to this, maybe that's the situation, because it looks like a topographic lobe. Yeah. This is the backside. We had these are the limbs where the data was missing. These are taken from this data is taken from that thrift printout that we get in real time, and there's some gaps in the data. These will be filled in once they get the station tapes delivered. But we can see the crater Hertzsprung here very evidently with the central peak or something in it.
You don't have any data in that 120 degree region, huh?
Not now. We should have it next week or so, whenever they get the tapes here reduced. One of the things that, well, on Apollo 15, there was a definite, well, centered about 180. There was a definite big trough in here, which went down about some 4.5 kilometers. It was very jagged, but it was centered just about here. And on Apollo 16 now, we do not really see that. We see this Highland material here, which we had on 15. That started about in here and showed a marked high region in there, and this is holding on 16 also. So this is kind of consistent with 15. Here's another. This is orbit 38 on the back side. I'll just kind of lay it there to show you some of the consistency. This is 10 orbits later, and the profile is almost Smithii, and oh, here we have some data in that. So there's your data. Ken, I don't know. Were you looking for some particular feature?
I was looking for something around 105.
105.
Not particular.
Nothing
okay.
Dramatic. I do have some data on the sub-satellite from Apollo 15, but I don't know if that's the time to really show here. I think I've shown enough stuff on 16. Huh?
Yeah, well, I like to stick to 16. Any of the problems we have or any of the data that we got for the crew.
Well, I'm very happy with all the data we've gotten on 16, and the sub-satellite on 16, like Larry mentioned just before me, it's pretty grim. Although there was an OD solution just run out about an hour ago, where the last state vector was used as the position for running out the lifetime program. And the lifetime program, if we believe that 15.8 model that we had used initially back there when we injected that thing, says that this thing should come back up. Still says it's not going to crash. But
this will be a very interesting thing to watch the next couple of days, I guess.
Right.
That's all right, Bill. All the seismometers are up and ready.
Well, it's 50. I asked Kovach about that, and I don't know whether he can speak for Latham or not, but I told him it's 50 pounds, and whether they can actually see an impact of 50 pounds, I think that's all it weighs.
The central station.
Let's see, it should hit about maybe some 20 or 30 degrees west longitude and 5 or 6 degrees north. Is that right, Dick? Something like that. About 5 or 6 north latitude and about 30 west. That's what it looks like, that linear extrapolation that we've got.
Well, thank you, Bill. Thank you, gentlemen, for attending. This concludes our scientific debrief. And I'd like to thank the crew for giving their time up to come on over to give us some information and also learn some things that would happen.
Okay, let me say something for the crew. I want to commend Ken for the way that he operated the Simbay, I don't think you'll ever find a guy who's either more interested in it or more aware of what the operational problems were and who could do a better job. He really did an outstanding job, and I think he's well done. The other thing I'd like to say is, since I've been on this program, I've been continually impressed with the importance of what we're doing in our support of you guys. These experiments, they look way out right now, and they're difficult for the man in the street to relate to. But my feeling is, from some of the things I've seen here and from the thrust of science and technology in this country, that in our lifetime, and I won't want to say when, but I imagine it's going to be a damn sight sooner than anybody even here in this room can imagine, there are going to be practical applications of some of these discoveries that have been made that will affect every one of us. And I think you're to be congratulated. The other thing is that I get out of all this that I think the United States ought to be spending 2 to 3 times the amount of money that we are spending on basic research and development and applied research and development. And I think that if you really look at the big picture of our energy requirements for clean energy in the future, in order to improve the life of human beings on this planet, we ought to do that and get on with it. Thank you.
During the next couple of months, we'll probably have an opportunity to talk to a lot of people that help to have some influence or shape the pattern of our program and related programs. And I would appreciate it very much, I'm sure we all could use the data, as you find out things. We realize that you have preliminary data today, and a lot of the things are only hints and suggestions of things to come. I would personally appreciate it very much if you give us a call periodically and tell us what you found. It's too easy for us to go through here and at the end of a week or so walk off and never really know what happened and never know what kind of data came out. And I think that makes us very poor salesmen. I think you could help us do the job to kind of feedback the quality of the data that you've been getting. If you could keep us informed, and please don't ever feel like you're interfering with our operation, or don't be inhibited to call us. If we can't come to the phone and take the data or talk to you about it, the secretary will take the number. We'll be glad to call you back. And if there's any time when you have some question about the data, it doesn't matter how trivial it may seem to you. If you want to look at some data and you're curious to know whether we've ever seen a particular observation or whether the spacecraft was moving at the time your data was taken, or I don't care how far out it might seem to you, questions are pretty cheap, and not asking questions can be very expensive. And so please feel like our job isn't finished until you guys have all the information you can use. And I would like for you to feel like you can call any time. Thank you very much.
I'd like to say, give you my thanks also. I was very pleased with the way all the gear worked, especially my part on the lunar surface and the part I saw of Ken in orbit. It was just a real pleasure to have him placed all this stuff for all you people, and glad it's working so well. And thanks for the opportunity of going. If you can gin up another one, I'll be glad to go along again. Thank you.
What, do we need a mic? Everybody hear me? Oh, okay. First of all, let me say thank you from SNAD for the scientific help on Apollo 16. I personally think that you all did a very credible job in helping the science support room and pre-flighting to get all the experiments ready, to prepare the crew and the flight for Apollo 16. I think that looking back on it now, we can say we had a very successful mission, that we attained a tremendous amount of information from the flight. I know that the rock boxes back there at the curatorial facility are bursting at their seams, and the geologists are going to have a lot to do. I think also that because of the problems that arose and the necessity to change the flight plan, that you responded quite well to get the maximum science out of the time that we had available. I realize that in all of our flights, there hasn't been one flight yet that ran according to schedule, and I am very sure that Apollo 17 will be in the same boat, that we will have to change things real time to get the maximum science out of the mission. And I think the response on this flight was superb. Now today, the briefing here is in two parts and for two purposes. First of all, I'd like each principal investigator to briefly describe the results so far obtained from his work. This is to sort of educate the crew on what we obtained so far from Apollo 16 so that they might have information along that line. Also, I'd like to have him describe any anomalies that might have occurred that we do not know about now. And second, then we'd like to have the PI with the crew working with them to have the crew answer any questions that might still be puzzling him so that he might further his analysis of the data. We have a lot of people to go through today, a lot of science to cover, so we'd like to keep each briefing short, and we don't want to cover things that are that are general knowledge as of today. And we can start right out. Let's see. First one is Palmer dial, lunar surface magnetometer. After each experimenter describes his experiment, we'll have questions, Palmer, so we can ask the crew any questions after your particular talk. There's a mic right over there. You may sit, stand, anything you want to do.
I guess the main functions of both instruments went nominally. I'd like to cover both the portable and the surface, if that's acceptable. The ALSEP instrument, the surface magnetometer that you deployed first, looked like it went according to plan. The field that we measured as soon as it was turned on, I think it was turned on about 15 minutes or so after you deployed it, was 230 gamma and in a downward direction. And at that particular time, that was the highest field that we'd ever measured on the lunar surface. The calibration of the instrument went straightforward. We did do a gradient determination of the field at the site. The site survey, as we call it, functioned normally. Its thermal control subsystem is the best that we've put on the moon so far. We have a delta T from lunar day to lunar night of 51 degrees centigrade, which is a factor of 2 better than our Apollo 12 thermal subsystem. The leveling of the device was, I noticed in the photograph yesterday that the bubble level was right in the center ring. The level sensors that we have are accurate to 1/4 degree, and they show that that the instrument is level to 1 degree accuracy right now. the instrument has new sensors in it. These are more stable, and it's really the first chance we have of doing network-type measurements of the fields on the moon. We do see whole moon. We have seen simultaneous data now from 15 and 16. We see the magnetic fields due to eddy currents that are driven in the entire lunar sphere. And for the first time experimentally, we have always made that assumption that we've got an instrument that's setting on at one point on a sphere, and that we're looking at the properties of a whole sphere. And we had some experimental evidence that that was the case. Now we have unambiguously shown with this second instrument that that is indeed the case, and that the assumption is correct that we are looking at a whole spherical response of the moon.
You mean you're seeing eddy currents all the way through the moon, huh?
We're seeing eddy currents that travel around the whole sphere, but with these new sensors now and with long-term data, what we're going to try and do is look, as you say, right at the center of the moon as they go all the way through. Now that's what we're waiting for during the lunar night is a nice step function and a long-term, both before and after, so we can see these currents diffuse right through the center of the moon. The other thing that I think that is unique about this instrument that now we have a chance to look at the azimuthal variations in conductivity. We can not only look at radial dependence of the electrical conductivity and calculate a temperature, but now we can look at the azimuthal or angular variations between Apollo 15 and Apollo 16 site. And that spread is far enough so that we ought to be able to extrapolate those measurements to a great circle around the whole moon as far as azimuthal dependence. The portable magnetometer was really exciting. First of all, the field that the first field I think you measured was 180 gamma down, and in the Cayley it looked like that all the fields were in essence pointed in a downward direction, and at the Alsep side it was 230 gamma, up near Spook it was 180 gamma, and then on the other side of the limb where you parked the rover at the last station, it was 120 gamma. And at that station you put a rock on it, and it looks like we measured about 4.7 gamma from that rock. So the rock was large enough and it had a large enough moment that it looks like we did see a difference. And these measurements do have an error bar on them that is like plus or minus as much now as 5 to 10 gamma, because the solar wind and all the other inductive fields that are around that have to be subtracted out of the measurements from our from the tape and data reduction. The measurements at Station 5 were pointed upward. That was the measurements up near North Ray Crater were pointed downward at 313 gamma. I think that there are some things that we could probably say making a lot of assumptions, but it looks like if this Highland material is older than the other, it looks like that we have at least a chance of looking at the paleomagnetic history of the lunar crust from these measurements. The high fields indicate that either the perming source, the source of this field, was if it remains stable over the time period that the Maria were cooling, then the Highland material would indicate, this high field would indicate that it indeed had a time variation in its magnitude, or that the Maria, the flooding of the Maria basins, or whatever caused the Maria basins to be as they are today, demagnetized the material that had been there originally. It's, in other words, the Maria material is less magnetic, it seems, than this material. The interesting thing too is that the samples, as you know, are from the regolith, and they've really physically been modified over the years. And I think that the measurements that we've obtained over scale sizes in the order of 10 kilometers indicate that we're looking at a depth well below the regolith, and that that this is indicative of fields that were at the moon during at a time period before, in the order of 3 to 4 billion years ago. The direction, and the other thing that we can say now from measurements of the solar wind, simultaneous measurements of solar wind and magnetic fields at the Apollo 12 and 15 site, we can say that these high fields that you measured at the Apollo 16 site modifies drastically the direction and interaction of the solar wind with the moon at these places. It should channel the charged particles and either at different locations asymmetrically on the lunar surface in these areas, and in some cases one could now state that the scale sizes of the field are large enough so that you could form a shock and actually stand off the solar wind over small regions of the moon. I guess that covers both of them.
Do you have any questions you want to ask the crew concerning anything about the deployment or anything of the experiment that you don't know about?
Palmer, let me ask you, what is the effect of that rock out there by the big LSM? Did that hurt it much?
No, first, where you parked the rover the first time in the TV camera, we were extremely disturbed because the angle was such, it looked like that rock was as big as the electronics box. And it looks like that the PRAs were oriented so it was shining right into them, and all the IR radiation would really heat us up during the daytime. But then the other view showed that the rock was relatively small compared to the dimensions of the box, and it didn't affect the thermal subsystem at all. And magnetically it didn't, they really don't contain that much oriented field to do anything.
I guess one of the things I'd like to say is that this, what we intended to do was we intended to drive 100 yards away from out in front of the lunar module with a rover and do a sort of a north-south traverse looking for the best place to deploy ALSEP to get it away from all these things. We ran into problems with a UV and that it took longer to do that last measurements than anticipated, and we couldn't do that. And I'm sure that somebody looking at the photos can find a better place out in front of the lunar module to put the total package. But I like to say that package is so big and that surface is so blocky and so full of craters that under the circumstances I almost believe we had to take what we got. I hate to say that, but man, I just wouldn't believe that surface was as rough and as covered with blocks as it turned out to be.
I think I could have still been walking up there with that package if I'd have been looking for a level spot. I got up on top of the ridge and I looked over and said, well, there's a good place over there, and I ran over there, and it didn't look any better than the place I'd just been, and well, there's a good place over there, and I ran over there, and finally after about the third time I said, well, look, I'm just going to put this thing down here at best we got. But it's really blocky and a lot of fresh craters there, secondary.
Well, but I think that if you look at at least the magnetometers, I looked at each of the photos that I could find where you'd taken a picture of both the ALSEP magnetometer and the portable. You didn't put the thing next to rocks or craters on the scale size that was big enough to affect the instrument. I think that's the main criteria which was observed during that.
John, did you know the rationale for doing that unplanned portable magnetometer reading?
No, but it doesn't make any difference. I mean, we did it. You can explain it in real time. That's all right.
On the hardware, the sun shield on the LSM, the latch didn't come loose, and I kept pulling the arms up to try to get that latch loose, and I finally had to hold the arm down and get the latch loose with the other hand. And then as I tried to lock the thing, the latch didn't fall off. It tangled up into that little wire that locks into the little ball.
Yes.
And that was I almost left it like that without locking it. And in fact, Houston said, go ahead and leave it. But one more little effort, the thing finally dropped off. And I thought I was going to disturb the level, but if you seem like you're satisfied with the level, 'cause
Yeah, the only thing I worry about there is that we've got a level sensor in the thing, and if you disturb that, you can sort of see that jiggle. But the azimuth, you know, when you read that shadow graph off, that's the only measurement we get in azimuth ever.
Yeah.
And so as long as you didn't disturb the twisting of it, then it's fine.
Okay, thank you, Palmer. Next experimenter will be Dr. Gary Latham. Pass the size of the experiment.
Can I ask a question from the floor?
Yes, go ahead.
I was going to ask Palmer, what duration on the field gradients from there? You can resolve that?
Gradients from which instrument? Oh, we don't have the, we've got to take out the fluctuations and solar wind from the other instrument using Apollo 13. No, we don't have that data.
The actual photo you took of the LSM was taken though after you had deployed the sunshade, right?
The 3-footer, I think, that's correct, yes.
So there wasn't any disturbance.
And we didn't touch it after that.
If there are any questions at the floor at any time after the discussion, feel free, just raise your hand.
Our fun began, as you know, with the S4B impact on this mission. You also know we lost tracking on it prematurely, which meant that we were not able to get the coordinates and time of the impact independent of our own measurements. Nevertheless, we could locate it fairly well from the two near stations, 12 and 14, which made it a useful impact at the greater range up to station 15. And we are looking at those signals now. I think we can say that this peculiarly high velocity mantle, as we called it, that we had found in the 12 and 14 region can't be a global feature unless it is exceedingly thin, a thin slab of this high velocity stuff. The signals we got, and I must say this, that there's always the uncertainty that we really didn't see the first arrival up there because it was at 1,100 kilometers, and the first signal you see is quite weak. There's always the uncertainty as to whether or not it is the fastest traveling wave in the moon and not something else. But if it is, then this very high velocity material that we called mantle is not global or an exceedingly thin layer. Looks as though we get velocities approaching 8 kilometers per second at depths of the moon of the order of 100 kilometers, not 9 kilometers per second as we had in the 12 and 14 region. There's also very weak evidence from that signal, and I haven't convinced my colleagues of this yet, nor myself really, but the possibility of a reflection from a very deep interface, perhaps 550 kilometers deep, is there. And we're looking for ways to see whether or not that can be verified. In other words, a primitive core perhaps or some other reflector at very great depth. So this impact will, I think, provide very, very useful data despite the loss of tracking. We would have been, of course, much better off had we been able to photograph that impact area, and I understand that the curtailed time in orbit precluded that. Is that right, Drew? We did not photograph it in that S4B. Yeah. The deployment was good. I think the pictures tell the story. As far as I'm concerned, the instrument does get hot during the lunar day, as the other instruments have. This has been the case in every one. I think it's a matter of it's just not possible to keep dust off of that shroud, I think, when you have to work that close to it. And that degrades the thermal control some. It does not degrade the seismic data. It simply means the controllers have more work to do trying to maintain the thermal stability. And it's a problem we faced in every one of the missions, so it's not. In fact, I thought the deployment, the configuration of the shroud that I saw and so on looked very, very good. There's one little place where it's raised up is where the cable comes out underneath. It's turned on its edge a little bit, and that, of course, is something of a heat loss, but it's not serious at all.
Yeah, we patted that rascal down because of the 15 problems. But maybe it's before a guy leaves that ALSEP site, if he's got a problem like it. Maybe is ALSEP on 17? Probably it's not, is it?
ALSEP is on the seismic.
The seismic. Okay, well, those rascally things assume some different kind of orientation than they did before we left, and maybe you ought to go back one more time and make sure those things haven't changed. Don't ask me. I think maybe they outgas a little and then take up a different shape.
Well, it's not only your near activities. I think when we saw that TV picture degrade on Lem Ascent, it's obvious that a lot of debris is being thrown around, and you just can't avoid a good dusting down from that source. So our carefully prepared thermal surfaces act more like black bodies than anybody figured on as a result of all this. Then we saw your rover signals, which this time provided very, very interesting data in that they showed rather abrupt changes in signal level as you moved around. We're not sure yet what to make of that. We're going to work with Bill Mulberger and his crew carefully on the traverse to see whether or not we can identify specific provinces in which the signal level is quite a bit higher. I guess I would like to ask your impression as you were rolling along and along the given EBAs that you felt at given times that the rover was bouncing noticeably more than at other times that might have generated higher signal levels.
Sometimes she was off the ground, there's no doubt about that.
To the south on EVA 2, that area was a lot rougher than the traverse route to North Ray Crater. My impression of North Ray Crater traverse, once we passed Palmetto, was it was really boulder-free area, very subdued old craters. Then the rover just sped along, much like a West Texas type terrain. Whereas to the south, it was really rough. John had to maneuver.
Particularly on Survey Ridge, when we were traversing that area with all the secondaries and blocks, we managed to be up in the air quite a bit. Simply because there were so many secondaries and blocks that we had to hit some small ones to avoid the big ones.
The subjective opinion of mine also is that around, at least at stop 13, where we actually got off the rover, the regolith did not seem as loosely compacted as to the south. And in fact, at North Ray Crater, at Station 11 and 12, it was no more than a couple inches deep because we couldn't get the rake in without bending the tines of the rake. So the regolith up there was very thin. And I don't know whether that means there's just some very cobbly, densely compacted blocks under there that were thrown out or that are now that much covered, or whether we just picked some bad sites. But we tried to rake twice, and both times the only luck we had was kicking stuff into the rake. We couldn't pull the rake through the regolith.
And you couldn't stick the tongs in either.
Yeah, and the tongs wouldn't go in. And every other place you could take the tongs and stick into the ground, they'd stand up for you.
Well, you know, in general, this area, from the general character of our signals, it gives the appearance of being the thickest pile of what we might loosely call regolith of any of the sites. And I guess Bob Kovacs will talk on his results on that, and of course we await his mortar firing to give us a little more information on that. Well, we'll be looking at these rover signals and see if we can somehow pin them down to roughness of terrain or just what from the pictures that you took along the way. We now have the quiet nighttime period, and we're waiting for the first moonquake of this session, which ought to be, well, I was hoping it would be in the last 24 hours. It wasn't, but should be before May 12th, so in the next few days. And of course, with this last station, we now have completed a very nice triangular array. The other three gave us a very narrow-based thing. Now we have a thing with a 1,000-kilometer baseline, which if it lasts for as long as they appear to be lasting, will give us the tools to really do the job over the next couple of years. And of course, we'll be using that in the S4B impact from the next mission. I'd like to turn to one observation reported from orbit that has interested us a great deal, and that was the flash that was reported. I haven't seen, I understand the transcript hasn't yet been typed.
I haven't seen it yet, so that's my only hope for pinning down the time.
If
you get it to about 5 minutes with that, I think.
If you can help us pin down the time and roughly the location, and we'll certainly look at our records, and that would be an important piece of data if we recorded that. I would like to ask, was this a colored flash or a white flash?
It's white.
How does it differ from the kind of thing you get with a cosmic ray impact on your brain?
I didn't see any of those.
He didn't see any of those.
I see.
Redhead.
The one cosmic flash he saw.
Well, we're very much excited by that. As far as I know, it's the first report of a transient event of some nature that's been seen from orbit.
I just have to wait for I should have written it down, and it just didn't occur to me to write it down.
Did we get a time on it at all, Ken? Or
It's on the DSC.
it's on the DSC.
And if I ever get that, I'll...
Well, then we would correlate any information we get from the seismic interfaces.
Yeah, how about its persistence? Did it just...
No, it was just a flash, and the way I happened to notice it, I was looking at a horizon that was showing up from solar corona or zodiacal light, whatever you want to call it in that region. It was very shortly after we lost the signal from Earth, and I was watching stars pop up over the horizon, and got this flash, which was in size was about, I wasn't looking directly at it at the time it happened down in the side of my vision, but it was brighter than the brightest star that I had in the field of view at the time, and I had the feeling that it was in physical or angular size, it was equivalent to the size of the larger stars in my perceived vision. But it was just an instantaneous flash, and it took a couple of seconds for it to soak into me that it wasn't just a star popping up over the horizon, but rather it had been distinctly below the horizon.
Is there a way for me to get that transcript? I don't know if I would normally get it.
I'm glad you asked.
Oh, that's it?
And I forgot to mention this in the opening remarks, but we have about 50 copies of this technical air-to-ground voice transcription right back there, and for the PIs and the co-Is, and there's a copy for you, Gary, back.
Gary, that's not what you're after.
No.
I
It'll be
need
on there.
the
It'll
tape
be on
recorder.
there. Yeah.
Oh, the DSC.
It's on the
Yeah.
DSC. Yeah. And that hasn't been completed as far as I know.
Okay.
Now, one other thing that I'd like to mention is, from orbit, it appeared to me that there was a distinctly different unit up around North Ray and the area that I'd say a third to a half of the traverse to North Ray went across. And that may or may not fit in with your seismic deltas.
That at some point between North Ray and the LEM, they would cross a contact of some kind.
Yes.
Well, except to add my thanks for a very fine deployment, that's all I have.
Thank you.
Any questions from the floor?
I don't understand this flash was not in the vicinity of S4B impact.
Well, I don't know whether the S4B hit, but this is on the backside of the limb, so I would assume that the S4B didn't hit there. And it's well after that, like a couple of days, lunar days.
Where did the S4B impact?
Oh, it hit about 150 kilometers north of Station 12.
When you mentioned you observed a star there, do optics or through the outlook?
No, the time I was doing this, I was looking out the window, and I had
darkened the cockpit in preparation for one of the low light level photographic exercises. And that's how I happened to be noticing that there was this distinct horizon, which surprised me. And I just happened to be kind of puzzling over that at the time.
Okay. Any other questions?
No.
Not with your visors down.
Visors up?
I never looked with the visors.
Supposed to do that.
I suspect from what we saw on EVA on the way home that the inner visor alone has sufficient attenuation to block out stars.
But you could see them from the through the AOT and the lunar module, and that's, of course, that has a light shield around it. On our last alignment, even with a crescent Earth in the AOT, we could see Arknar really so good that we didn't even have to roll up the window shades in the cockpit. So with a proper, if you look through a tube, I'm sure you could see every star up there.
The only thing we saw on the lunar surface was the Earth, and you had to, it was directly overhead. That was the only thing I saw in the sky.
John, when you're looking through the sight on the camera, did you see anything besides you?
You see your helmet reflected. That's what you see. You have to raise your visor to get all that, so you can get rid of all those reflections.
Okay, next one is active seismic experiment. Dr. Kovach.
Well, we had several objectives on this experiment. I'd like to summarize these. Basic questions like how thick is the seismic regolith would be one question. What were the in situ physical properties of the lunar near surface material? And thirdly, are there any distinct seismic horizons, and how do they correlate with our estimates to geological horizons? And finally, were there any regional differences in seismic velocities, i.e. something characteristically different between the Mare and the highlands? Well, the deployment and the execution of the Thumper experiment was outstanding. I mean, the records are clearer, and the background noise was sufficiently low, and we got clean first breaks completely down the geophone line. We couldn't have asked for a better.
I'm sorry about that first one. I was so really happy when that rascal worked that I stopped walking. I started walking to the next one.
Well, the record shows that for some reason you inadvertently didn't hold it in a charged position sufficiently long enough, and that's the reason when you did it the second time it worked.
No, I thought I started walking too soon after the first one went off. The one that failed, yeah, that was pure procedure there.
Well, if you walked too soon, it didn't hurt us any. So.
Didn't bother you? Okay.
The data needs yet to be corrected for topographic effects. There's some severe undulations in the topography, and we can see this in the data, but I can give you some first impressions of our results. Number one, there's certainly no variability in the first arrival velocities across the geophone array, and the apparent velocity, or the velocity, is again very close to 100 meters per second, which is seems to be the magic number for the regolith at many different places now on the moon, i.e. out in the Mare and now up here in this, finally up in this highland site. There are no evidence of flows beneath the beneath this geophone line. I feel sufficiently confident we would have recognized that. Now, the fact that we didn't recognize any variability in the velocity, we're able to say one more thing, because we recorded the limb ascent when we turned on the geophone line, and that was positioned some 140 meters away from our first geophone. And we did get a faster apparent velocity, and it's very close to the value measured for Frau Morrow for breccias. And so with this type of a number now, i.e. 200 to 300 meters per second underlying this regolith, we can put a thickness bound on the regolith at this site, and it is indeed very thick, at least 40 meters. And I'll be able to refine that number a little bit when we get the mortars fired. We also did turn on the ASE geophone array and recorded, your rover approaching the limb during the end of EVA3, and we also got very interesting signals, and we hope to analyze these in an analogous way as Gary has suggested. And that's about all I can say for the quick look of our data at this point. We do have the concern, of course, I do have the concern about the grenade box deployment. I'm sure I've asked you that. I haven't seen any of the pictures yet, so maybe it'll be self-explained, but maybe you could reassure me that it's level.
It's level, I guarantee you. In fact, that was probably the only level place we had around there. And I was really pleased to see when we got out the end of to where we could deploy it that it would be level. It's really good. And I reported I don't remember what azimuth heading that we put it on. It was very close. It seemed like it was 330 as opposed to 333 that it should have been on. That's off the top of my head. We had to go back and look, but I reported it. And found out later that you could break that pin by pulling on the leg, but I certainly didn't know that if somebody had told me that doing the training, why it had gone right over my head. But we do have 3 good legs in there, and I'll bet you that rascal can't get out of the ground because of the way it went in. It's sort of like pushing it into quicksand. And once it gets in there, I defy anybody to get that motor box back out of there because it really grabbed a hold of it.
Well, again, I'd like to offer my thanks for an outstanding execution of the experiment. We couldn't ask for anything better.
Thank you. It was our pleasure. Boy, it really worked good. I was really pleased.
Any questions from the floor?
How do you define the regular seismic? You said, what's that? Is it the increase with a...
Well, we define the regolith, I don't know how the geologist may not agree with what you define, but we define it as material which apparently covers much of the lunar surface and has this characteristic velocity of 100 meters per second.
And what comes after that?
Underneath this particular site, yeah, something that has velocities like fraught marl, breccias.
You said something about you were sure that there was no flow material underneath this. I guess I missed the conclusion.
Well, we've done enough experiments on Earth, and I say that we've been able to recognize flows because the velocities are characteristically much higher. And if you want to argue that there may be very thin flows, i.e. thinner than our sampling wavelength, which is like 2 to 3 meters, they could be there, but we certainly, on the average, didn't see any big sequence of high velocity flows. We would have recognized.
When you say high velocity, this 200 or 300 that you're talking about from the essence stage, that's not high end.
Yes, every small crater that we looked into, with exception probably of Buster Crater, we never saw anything that looked like anything but, I mean, it just looked like more of the same. It looked like regolith. I mean, we never saw anything that looked like outcrop, and we were sure looking for it.
This 2 to 300 meter velocity you're talking about from the limb ascent, that was this breccia material that you say is underlying the regolith, is that right?
That's my first look at it.
First look.
When do you fire the mortars?
Okay. Oh, that's another good question. What's the latest word on mortars firing? Do we have any idea about when they're doing that?
Well, there's a meeting at 1 o'clock this afternoon, and I'm going to request it to fire it on May the 23rd.
Bastille Day, is that it?
And it's armed, too.
Okay, our next subject is the solar wind composition. Dr. Meister?
Unfortunately, there is not much to tell about the solar wind composition experiment. The foil was transferred to Switzerland at the end of last week, and we don't have any results yet, of course. The foil was deployed during the first EVA and retrieved at the end of the third EVA with a total exposure time of 45 hours and 5 minutes. That's some 3 hours longer than the record of the previous missions, which was about 52 hours on Apollo 15. The main difference between the foil of Apollo 16 and the ones of the previous missions is that some pieces of platinum foil have been attached to the previous design, which was composed of a pure aluminum foil. These platinum foil pieces can be cleaned by fluoridic acid, which allows to remove all the possible lunar dust contamination. This technique has been tested in the lab on bombarded foils and showed that you can remove essentially all the lunar dust contamination without losing any measurable amount of trapped rare gas ions or atoms of solar wind origin. This technique should allow us to determine the isotopic composition of the rare gas elements of solar wind origin up to the mass of possibly krypton. A first visual inspection of the foil here at MSC showed that the foil is crimpled but essentially free of lunar dust. That's of course only a visual observation. We don't know how the foil looks like under microscope. I would like to thank the crew for the proper deployment and retrieval of the foil. We are very pleased with what the foil looks like. Thank you very much.
Can't miss when it tells you where the sun is.
Yeah, point this at sun. The thing didn't roll up like I thought it was going to, and I'm sorry I had to crinkle it, but it was so big and that I had to squeeze it down to get it into the bag, and it ripped once too. I guess you saw that.
That's only a problem of aesthetics. It doesn't hurt the scientific
good.
value.
I didn't think it did.
Don?
If the local magnetic field is standing off the solar wind area, what will that look like now?
We don't know yet. That might be that we have a discrimination between the lighter and heavier elements in the solar wind. We have to check that. Maybe that there's a dependence on the height over the lunar surface of the composition between the heavier and lighter elements. But we have to check that first and see.
Stand off the lighter particles.
Lighter particles would be deflected much more than the heavier ones.
Can you see those, I don't know, this is probably a stupid question, but these cosmic these particles that cause the light flashes, I was seeing them on the lunar surface during the sleep periods.
Yeah,
do those things register on your experiment?
No, they have higher energies and they go through the foil.
That's it, yeah. Huh?
That will show up on While the gloves are bulky, could you tell any difference in the material between the time you deployed and the time you brought it back? Is there any realness or anything you might have considered?
No. No difference there. Looking at it one time out the window, I thought I saw some white streaks on it, but that might have been just the way the sun was. Or it might have been those platinum strips that I'd never noticed when I emplaced it. I really don't know. It just looked like it had a couple of randomly oriented streaks on it to me from the limb window. But when we rolled it back up again, instead of rolling straight up, it rolled out in a big long thing, and I had to redo it again, and when that happened, I ripped it and then had to crunch it down.
We don't see any difference between the foil we sent up and the foil that came down, except of some lunar dust on it. Nothing else. Can I ask the crew a question? Do you have an idea how the foil was oriented? Was it essentially vertical to the
photographs?
I mean, along the gravitational force lines, or was it reclined or inclined? It's hard to tell it from pictures.
You can't tell it from the pictures.
I think I put it in almost parallel to the gravity vector there. It's on a slope, a little slope, but if I recall, it's aligned almost vertically.
Okay. Thank you very much.
Thank you. The next subject will be the cosmic ray detector. Dr. Bob Fleischer. See here? Oh, okay. He's not here.
The PIs couldn't be here this morning. They're busily at home studying the data that they got back. I have some words from them that I'll pass along as to what they think they'll be able to see. They are very excited about the possibilities they have. Early in the mission, there was a solar particle event that occurred which will enhance their data very significantly, they think. They think they'll have the opportunity to see particles from the sun that on an ordinary mission they would have never had the opportunity to see. When they got the experiment back, panel 1 did have considerable dust on it, and this, from the best we can tell without any analysis, came from the landing itself, from the blast up from the DPS. Panel 1 was hot. In the taking the panels apart, panels 2 and 3 were cooler, and panel 4 was of the same order of temperatures as panel 2 and 3. The cosmic ray data itself in the plastics appears to be degraded somewhat because of the temperature, but they're very hopeful that a great part of the data will be retrievable. At the first look on panel 2, Dr. Fleischer says that the number of particles they see on the plastics indeed are a great deal higher than they would have nominally anticipated, indicating the effects of the solar particle event. And they really haven't in detail etched the plastics or analyzed them. They're just beginning to do that.
They think they are usable.
Yes, the plastics.
I was really surprised because we had some lengthy discussions about this pre-flight, and I could never understand how we're going to fly this rascal to the moon and get it there with these long periods of attitude hole that we're going into where it might see plus 250 all the time. And of course, I'm sure those 3 revs in lunar orbit prior to landing didn't do any good either, because we were oriented many times so that we were facing with to maintain communications. We had the sun shining on that rascal all the way around. And I really think those 140 temperatures that we saw on the panels, if you go back and look at it thermally, you're going to find out they were there. They had to be there long before we ever got the thing on the ground. And I was really concerned about that as to why we didn't put some kind of shielding over it, but it was too late, I guess, to do that sort of thing.
Well, the thermal design was such that it could sit, I believe, in direct sunlight almost indefinitely without any degradation. It's the IR heating off the lunar surface that really cooks it. That's what the thermal people say. I think, and it's hard to say, and we did see the early picture did show that the temp labels had already changed early at the beginning of the EVA.
They were black first time we looked at them.
And a guess is the 15 hours, the thermal analysis says if there's like 15% dust on the panel after 20 degrees of sun angle or so, you'll sort of exceed the 140 degrees on the frame. It appeared that there was probably 50 or 60% dust on the lower part of the panel, or maybe even higher than that, and it spent about 15 hours on the surface. So it may have just turned out to be a number of problems that are probably ones that could not be avoided under the circumstances that caused that lower panel to overheat. It was the hottest, and the next panel was about 20 degrees cooler, the best we can tell, and the third panel up was 10 degrees cooler than the second panel. So it seemed to be a dust problem, but it doesn't seem to have hurt the data too much. Panel 4 was the one which we were afraid wasn't going to be activated because of the anomaly on the red lanyard. But after they have taken the panel apart, apparently every portion of the experiment was activated to some degree or another. The neutron portion was partially deployed, and they think they will get some data from it. Is not as much data statistically as they wish they had. But every portion of panel 4 does look like it will provide some useful data, and they have a lot higher hopes now than they did when they first saw the gear. Apparently the problem, and we haven't sent the hardware back to the manufacturer for analysis, but apparently was a malfunction in the assembly of it that caused that thing to jam.
Well, we could have pulled, if I'd have known about it at the time, we could have got that pair of pliers out of there and pulled harder.
The investigator's opinion was it would have done no good.
Wouldn't
it was
help.
Very severely jammed, and he doesn't think any additional effort would have freed it. It was jammed pretty bad.
Okay.
But I think in all they're very excited about the data, and I think they're very optimistic now that they'll get a considerable amount of data from it.
Tim, it's probably worth mentioning on those plastic panels that overheated that they did have calibration plastics in there, and they'll be able to, the effect of the overheat is just to anneal the tracks and reduce the track density. But with the calibration in there, they'll be able to take out most of that effect. The other thing is that on panel 4 is that those experiments which are activated by pulling the cord are only a small fraction of the total part of panel 4. So there's a lot of panel 4 that isn't impacted at all by the jam.
That's true.
So they'll still get a lot of good data, just as good data as if the jam had never occurred.
That's for all practical purposes. That's good.
Okay, I don't think we. In fact, I'm sure you may find a fingerprint on there, but if there is, we really were careful to get it out of there, and we didn't. Once we got it loose, we gave it the usual 10 or 11 care in folding it up. So I don't think there's any crude fingerprints on the panel surfaces.
That's correct. We looked at it very carefully, and it was, except for the bottom part of panel 1 that you could see it was a spray pattern, and it was very clean, and the PIs were very pleased about that.
This solar particle event, do you have any notion when that occurred?
Yes, it started on about, I believe, Monday, which was the day after launch, and went through about Wednesday. It's about a 2 or 3 day type event. I think the peak was must have been about Tuesday. There are some satellite data available, and I don't have that on hand. It was a small event, but for this solar cycle, it was very surprising that it happened at all during the mission, and to have it during the portion when the cosmic ray was deployed or available to accept data was, the probability of that's very small, so it's a very gratifying thing to occur.
Tim, I'm curious about the dust being kicked up by the GPS. Did you guys observe any dust on the thing or any other part of the limb at that level? Because it's always been our impression that the dust is sent out in a pretty thin layer, that you don't get a billowing effect.
Yeah, I'm sure it's sent out in a thin layer, but with all those infernal blocks around there, it's a possibility some of it could come back at you, that's for sure. Yeah.
It was extremely hard to see, and when we photographed it, the lights are not similar to the sun, probably much less in intensity, but yet the photographic lights did wash out. It's a very pale kind of dust, but it's very predominant, and it came up from the corner, Dave, in a pattern that you would expect it to be blown, and there were some black streaks in there that appeared to be melted something or other on it, and I think they are going to attempt to chemically analyze the material on it and try to find out what it is.
How high above the surface are on the limb? 5 miles, roughly?
That first panel must be about chest high, is it not?
Yeah.
Any other questions?
Just one comment. That was the frame of that thing was hot. Really, it was hot. That was the only thing I felt through my gloves the whole stay. Well, it was jammed, and John tried to pull it out, and I was holding the frame, and I started feeling it through my gloves.
Did you get any feel for why it was jamming or where it was jamming? Did you give any clue of what caused it?
It's jamming at the base.
Yeah, down at the bottom.
Right at the bottom part. Yeah, it's something that broke free right at the base, and then it just came out like it had grease on it.
Maybe we spilled some orange juice on it or something.
No way. That's the only thing we didn't spill orange juice on.
It's not that you didn't try, huh?
It's a good cement, you guys. You ought to start thinking about that. Suppose that stuff to vacuum, boy.
Okay, our next experiment was the far UV camera. Dr. Page?
For the benefit of some of the geologists here, I'll recount the goals, purposes of this experiment, which were to obtain photographs in far ultraviolet of the geocorona in the upper atmosphere of the Earth. I should have said these photographs, of course, include spectra as well. and solar wind clouds, possibly, interstellar hydrogen, colors of stars in the far ultraviolet, and possibly intergalactic hydrogen. We had a lot of troubles, I guess John well knows. Before launch, the difficulty was to keep the camera dry because its optically sensitive surface would immediately run away if it got damp. And this was accomplished with a bag that caused Captain Young a little bit of trouble in practices in advance, but apparently worked all right on the lunar surface.
It's great.
The second difficulty was getting through the Van Allen belts without fogging our film, and I'll show you in a moment that we did that all right with a rather small amount of shielding around the film cassette. Then we had some difficulty with the LEM being in the way. This came about because of the delay in touchdown, high sun angle, and the necessity to keep the camera close to the LEM so that it would be in the shadow. With its gold surface, it would have heated up very rapidly if it had been out in the full sunlight. The accomplishments that I will show you in a moment on the screen include 92 photographs in Lyman alpha imagery and 53 spectra, some of them extending from 500 angstroms to 1550 angstroms. That's, I think, the farthest into the ultraviolet anybody's ever taken astronomical pictures. We may get evidence of gases in the lunar atmosphere from several of our pointings which were low across the lunar horizon. And if anything were coming out like geysers of water or whatever it is, we'll certainly pick it up. The data on these photographs are extremely numerous, and it'll take us an estimated 6 months to a year to get them all out, which will be done with the big computer here at the MSC. So Dr. George Carruthers, who is the PI and who designed the camera, happened to be free today from work on an Araby flight, and is here, and will undoubtedly make comments whenever he sees something to comment on the photographs. Do we have the first slide? I might say that I got into trouble with the American Photographers Union in making the prints of these because I'm not a member of that union, and they tried to throw me out of the dark from over here. This is probably one of the most dramatic pictures of the Earth that shows auroral belt on the dark side. You're looking at the Earth with the sun off to your right. The south pole of the Earth is down, and that funny lip-like thing sticking off to the left at the bottom is aurora, we think, around the south magnetic pole. The most striking thing is the next lip up, which on the original you can see better than on this slide, goes around the full back side of the Earth. It's called the equatorial auroral belt, and disappears back of the dark side in the upper left corner. The third lip is another belt. It looks at first as if that was just all one, but there are two separate belts there, and was quite unexpected. This photo.
What's the dimension of the Earth's actual size?
Well, you know, it's 8,000 miles across. And it is. There's some halation here, and I guess I'm not too sure, and perhaps George knows. This is a special Eastman NTB3 emulsion, very, very thin. And of course, the exposure was made with electrons, not with light. It's an electronographic camera. But the dimension works out right. You can't see it too well on this print. There's a ring or a limit to the field, which on the originals is 30 millimeters across. It's 20 degrees in the sky, and the Earth is 2 degrees, and it checks out. So the dimension you see there is 2 degrees across the full diameter of the Earth.
You say it's the equatorial auroral belt. I think what I'm trying to say is, what's the third line from the bottom? Is that the backside of your scene, or?
No, you can't see through the Earth.
That's why I asked you. Is the Earth covered?
No, that the geometry is such that that is probably inclined 30 degrees to the magnetic equator, and is an unexpected auroral belt. It'll take a little more figuring to figure this out, but.
What was the latitude of that third belt?
As I just said, my guess, looking at the picture, it hasn't been measured accurately, is 30 degrees north. Okay. You'll notice on these pictures that they're overprinted. That's because I'm not a member of the Photographers Union, and the originals have a good deal more on them. This picture was taken excluding hydrogen light, Lyman alpha. We have two filters on the camera, and this one is taken in light between the wavelengths of 1230 and 1550 angstroms. Now the next slide, yeah?
Is the whole diameter you're seeing there, is that all the Earth, or is that twice what the Earth is?
No, it's the Earth, just the Earth.
The whole thing you're seeing is the Earth.
The Earth, right.
Not twice the image.
No, it's as I said, the little halation, which makes it a little bigger than it ought to be.
It's only a few percent.
Yeah, a few percent. Now in this one, it's exactly the same view. It was taken after John so accurately pointed the camera at the Earth. The Earth is in the middle there, and if you look real hard, you can see the dark side of it off to your left. This is the geocorona. The streaks are an instrumental matter. Actually, we have a barrier membrane that George put very close in front of the film to keep visible light from getting in there, and the barrier membrane wasn't quite uniform, and that's where the streaks come from. The circular thing on the right is an overlap, another defect. The little motor that danced the film between exposures didn't pull it quite far enough for this one. And those dust specks, I guess, are my pipe tobacco on the slide.
You know, Thornton, that rascally thing was moving. At first, it wasn't moving. The wheels weren't going as far as they did toward the end.
No, we have a complete transcript of everything you said about it.
Okay.
And in looking at the film, which I've done in great detail, you can see the most serious defect in that film advance was during your short exposures on the Earth, John. Everywhere else it worked fine. And I have an idea that pushing the buttons so frequently sort of confused the motor, and it didn't turn as far as it should have. Well, in any case, you'll notice that the shape of the geocorona is as predicted by Dr. Meyer at the Naval Research Lab. It's got a dimple in the back, down sun. Sun is still to the right here. And our other photographs show that it extends at least twice as far as you see here off to the right. The print, of course, can be printed dark or light, and if I printed this one lighter, I'd have got the background all over the whole slide, and you wouldn't have been able to see as pretty a picture as this. Now the next slide shows the one further to the right. The sun is still to your right. The Earth now is off the edge of the picture to the left. This was one of the sequence taken through the night between EVAs 2 and 3. You see in star background here, and again the geocorona, those streaks which are not real, extending actually right across this frame if you print the thing lighter. Now the next slide shows the two of these combined, and I printed a lot darker, and I guess it's not as artistic an effort as I had hoped. The geocorona is hydrogen in 1216 angstroms, Lyman alpha, and the next slide shows the spectrum actually taken on that first slide. The spectrum is, dispersion is vertical, and that white band across roughly horizontally is Lyman alpha. And you see how strong it is. The Earth is in the middle of this picture, and the spectrum of the upper atmosphere is spread out on that vertical line from far ultraviolet down at the bottom to nearer ultraviolet up at the top. A bright line just above Lyman alpha is 1304, which is an oxygen line. And George, do you want to describe this in a little more detail?
We've so far only made a very crude analysis of the spectra by comparison with the laboratory spectra made in the pre-flight calibrations. However, we have tentatively identified the 584 line of helium, the 834 line of ionized oxygen, the 1026 line Lyman beta of hydrogen. These three lines are the first spectral measurements in the Earth's upper atmosphere. All previous measurements have been limited to wavelengths longward of 1100 angstroms, which we also cover, and which includes the Lyman alpha line at 1216, the 1304 and 1356 lines of atomic oxygen, and the Lyman-Burge-Hopfield bands of molecular nitrogen between 1200 and 1600 angstroms. The Lyman alpha line, of course, is by far the strongest emission that we have seen in any of our spectra, and it's the only one that we have conclusively identified in any of the spectra that do not include the Earth. However, by comparison of spectra taken with and without our lithium fluoride corrector plate, which cuts off at 1050 angstroms, we will be able to determine whether we see a general background in the 584 line of helium and the 1026 line of atomic hydrogen, as we expect, though they will be much weaker than the Lyman alpha line.
So we got that other spectrum coming. Okay. In other words, can you hold on a minute? I think the order he's got them in has the Magellanic Cloud in it, and we're probably taking too much time. Do we have the next slide? Well, that's it. Go ahead. So this is without the corrector plate. You notice that the Lyman alpha here is broader. The definition is poorer, but as George was just saying, we get lines further down in the ultraviolet on spectra taken without the corrector plate than with it. And you see here too, these other lines are not uniform. This is a spectrum that was obtained with the Earth off the edge here. So it shows that the geocorona goes right across this slide, as I said last time. By the way, that's 100,000 miles. And the other lines here show the either other materials in the geocorona or beyond the geocorona. I guess it's going to take a little while to figure out which are which. Go ahead. I didn't interrupt. Is that any more to say about it? The next two slides quickly show the, well, that's right, it's one. The Magellanic Clouds, which are, well, John was worried about what LMC meant, and this is the Large Magellanic Cloud, and that's the initial, what the initials refer to. The picture on the left is with hydrogen, with Lyman alpha, and the picture on the right is without. In this far ultraviolet region, all that you are seeing here are the very hot blue stars. And over here you see the clouds of hydrogen gas. So the difference between these two photographs is hydrogen. And we get the record of, well, Magellanic Clouds are nearby galaxies, so we have a galaxy with all of the stars and nebulae and whatnot spread out in front of us to study. Carl Henneis has made special studies of these Magellanic Clouds and is very much interested and already has copies of these photographs for study. You notice that the hydrogen is not just from the Magellanic Clouds. This stuff up here is out in the open sky, and just what caused that background, I don't know. Is there any other slide? That's the last one. Okay. We had a couple of questions for John. One was that sticking, which had us worried. You talked about the instrument may fly on Apollo 17. Rocco is very interested in it. And so, what was the sticking? Did it continue right through? You didn't mention it in EVA3.
It got worse all along. I just got the feeling there was some kind of hang-up in possibly long-term vacuum exposure or something to the operation of the way it was working in azimuth, and I never was able to. It never got better. No, it never got better. In fact, the longer it sat there, maybe the cold, it just seemed to get stickier and stickier. Toward the end there, every time I got to a new setting in azimuth, it completely destroyed the level. And we're unfortunate that we were on that slope right there. It's under the footpad of the limb, and so I had to go back and re-level it every time, and that was we really working at the limits of the levelability of the machinery, I think, there. And
you see that it didn't make much difference. For instance, that Magellanic Cloud should have been out in the middle of the
I know,
and you
and
were off by that much because.
But well, that's. If we were on a level slope, there would have been no problem in getting the bubble right in the middle every time. And if the azimuth had worked easily, it would have remained level. But I sure don't know what it was.
It couldn't have been dust that got in.
No,
we thought that was impossible.
No, I don't think we had any. In fact, I'm sure we didn't have any dust on the legs up that far.
The film cassette you brought back had very little dust on it. In fact, it looked brand new.
Well, I hope if it got dust on it, it got it inside the limb. There was plenty in there once we got into zero gravity. Although I don't know how to crawl through 2 bags.
That's why I was quite surprised there was no dust. In fact, we were disappointed because we were going to collect a little bit of dust off it.
Any questions from the floor?
Yes.
And I'm sure it got some dust on it when I removed it, though.
I got a very small amount, which I'm illegally keeping in the business.
Don't tell anybody. The FBI will be around to see you.
Did you see evidence of the magnetosheet or bow shock?
So far, we have not seen any discontinuity in the upsun geocorona, which would be indicative of that. It just sort of dribbles off as you go sunward from the Earth, and there's no sharp drop.
But we're really not out as far as the bow shock, are we?
10 Earth radii should have been in the middle of that upsun.
I get you. It's only 10?
12 or something like that.
Okay, any more questions? Okay, next subject is the lunar geology investigation. Dr. Mulberger.
For the benefit of the astrologer in the crowd, there's been very little evidence for water and none so far for geysers. Our experiment may not be as far-reaching as theirs, but on the other hand, I think we've made a large step toward understanding the history of the moon, and therefore the Earth, and therefore the solar system. And if you guys can find any more, we're out there with you. So far, we've completed the mission itself, and all major objectives for the pre-planned traverses were reached, and were sampled, and were described, and photographed. And as far as we can tell with our quick look at the photographs, all of these were done well. We've produced a so-called greenback at the end of the mission operations itself, which was a summary as of our knowledge at that time. It was based on crew observations, TV, and the pre-mission data. Included in that thing are station sample maps, which were derived from the TV in real time, and that was a very useful tool to us. A sample inventory, a film usage inventory, and a station locations, again resected from the TV pans. By the end of last week, we'd received black and white 2-time enlargements of all film. These are the typical drugstore quality prints, and sooner or later we'll get good quality, so our analysis is very brief. We've assembled all the panoramas. Sample location studies are nearing completion. The film inventory is also nearing completion. The geological analysis is still in its infancy, and I suspect should progress rapidly now that we got all this inventorying over with. You guys took so damn many pictures, it takes time to get them organized.
We've had one session with the crew and the LRL with samples, and most of our questions need samples in hand, and those I'm sure we'll be able to discuss later. And so the questions I've got relate more to surface observations that maybe we can amplify. And some of these are questions that we've asked you before, but I have a few Polaroid prints of these photos that maybe can jostle our minds and assist in refining some of the answers that we've gotten on the debriefs after the EVAs or on Trans-Earth. Our photogeologic mapping group primarily talked about rays by their whiteness. There were a few spots where they thought they were seeing dark rays. You recognize both light and dark colored rays, and particularly the South Ray picture. If I could have slide 1, please, which is the South Ray panorama, and the print I've just given to the crew, a single frame from that. There I think we can see light and dark, and the real question I'm after is what led you to say that you were on or off a ray? And secondly, were there any visible differences in the rock types as you drove by or had a chance of sampling ray material?
Is that picture upside down?
Yeah.
Turn over. It's upside down.
Sure looks that way.
The hills are at the bottom.
Yeah, I think the thumbprint goes in the upper right. Could the projectionist give that a 180, please, around the horizontal axis? That one's got the same problem. There we go. Now it's a hill instead of a hole. This is your pan from station 4.
Yeah, you see that black line coming over the. This photo really doesn't do that.
No,
scene justice.
Polaroid prints never do.
Well, I mean, you really have to see it to believe it. That white is so much whiter than the contrast that we're able to get out of the photographs. I think when I looked at it, my assessment of this, which is kind of bad place, was that it was a black ray coming out.
The right rim there on the photograph.
And it probably went right down that, as you know, that the photograph that showed the black area coming out of South Ray.
Right.
And there's a series of black blocks. There's a bunch right there.
Left edge.
Yeah, and there's also, and Charlie described this in real time, there's some more black blocks in there, and they seem to come out in ray patterns too. Don't you think, Charlie?
Yeah.
That rascally, that's one spectacular crater. That ray coming down the south right edge might have been the ray that made, or at least part of it, that made Survey Ridge, because it just ran right across those wrecked trap craters, and we could see it going all the way down.
Is that the bright ray you're talking about in the lower right?
This ray right here, Bill, came right through Stubby, right up over, and right out Survey Ridge. This one right here.
So that was the source of your terrific block field there.
Man, and just amazing how much rocks the rascal laid down. I just couldn't believe it. Trafficability in close to that thing would probably have been very interesting. Wish we'd had another EVA to find out. I'll fix the heat flow one.
The reason we called we were on a ray was really an abundance of secondary craters and an abundance of blocks. And they thinned and thickened as we, I think, traverse raised, but we never did get totally out of blocks to the south, to the traverse to the south. There were always at least 3 to 5% of the surface had cobbles, and I say cobbles, 20 centimeter blocks and larger.
And the blocks were generally asymmetrical enough to the crater, or the crater shape was elongated, or just a great spattering of craters is why you're calling them secondaries.
I think subjectively we felt they were oriented from South Ray all the time. It was really just a subjective feel as we were driving by them.
there were a lot of the blocks that were not associated with any craters. There would be a pile of a series of secondaries, but around for a couple of hundred meters there'd be more blocks. In fact, as far as you could see, there'd be blocks just scattered over the surface that were not associated with any secondaries. But the true secondaries were, we did see some that were classic, where they were, the ejector was downrange from, and it pointed right to South Ray. Station 4, for instance, was one that was...
Can I have slide 4, please?
I might add that these black rays and the black blocks that you see here were also evident at Baby Ray.
Can you rotate that one too?
And to a more, or to a lesser degree, the sampling at North Ray had an appearance of being black and white matrixed, black and white rocks also.
The North Ray rocks.
Yes.
Do these black streaks go all into the crater themselves, down vertically down into the sides of the crater?
At South Ray, yeah. That one on the left that you saw there was, you could track it over the rim and back right across the rim.
And Ken, could you see that from orbit? You can see a lot of these fresh, look like black streak craters.
This one, South Ray, does not have nearly the obvious dark streaks that run down inside and outside that many of the other craters do. There was dark material, or dark appearing material that was very obvious in the crater interior, but I never recognized it as being a ray that was thrown out with a radial dimension.
Yeah, I think looking at the photography, the feeling we got from looking at South Ray was that that black streak was just an absence of any rays. But I think it's from the blocks, it must be black ray material, dark material.
Maybe the dark matrix rocks would produce that darkening.
It petered out a lot faster than the white rays, though. I mean, you know, within a quarter of a crater diameter, it was gone.
From the bottom of the...
Those could disappear just because of their general appearance.
Could.
Like the local regolith, the white ones being so obviously different, it'd be easy to recognize. I suspect why the mappers did the same thing. Here's your pan, John, or part of it, looking up sun. And this crater you suggested was a secondary, and therefore the sampling that you were doing primarily over there to the left corner is where the rover is, would be South Ray ejecta as the principal source. Is one reason we wanted to move you on, and I think that was a good decision now that we look at your photographs and from what you had told us.
Well, we sampled this crater up on this close-in rim and down the rim a little bit, but man, if that's not a classic secondary, I never saw one.
Yeah, that's type locality, if you pardon the geological verbiage.
And you can see the debris from there. It's scattered all out in here, too. The rover's back over here.
Yes.
Downslope.
You can see it right in the left corner, just the edge of it.
Oh, yeah.
And I think you're standing there, Charlie.
Probably on my face.
Okay.
Okay, related to this are some of the craters that you called indurated and had clods around them. Could I have photo 7, please? And that'll probably need a 182.
Oh, plum.
No, number 7. Oh yeah, that's plum, okay. Now that plum's got a little bench in it. And on the pre-mission work, there were quite a lot of them that had benches and suggested that there was a indurated layer that was shallow compared to what the crater counts said that the age of that whole surface had to be. We just heard Kovacs tell us there's a very thick regolith here, which is what it should have had by the cratering stories, and yet there was always this little bench. We're wondering now whether that bench has some relationship to the ejecta from the South Ray and North Ray craters, and therefore might be what you brought up here on the rim of Plum as some of the pre-Ray indurated regolith. Do you have any thoughts that could go into that?
That wasn't what I was calling the indurated regolith, Bill.
Wasn't it?
No.
What was that?
The indurated regolith I was talking about was 2-meter size craters.
2 meter?
Yeah, 2-meter size. And there were little teeny clods, no bigger than a grapefruit, and that were symmetrically around a very shallow crater that had a Hackley black glass right in the center of these little craters. And the biggest one was no more than 2 meters in.
You see down in the plum, see that outline of rocks down in there? No, keep going down.
Right here?
No, over here.
Why don't you point to it?
Okay. See those rocks right in there? Well, I think...
near the bottom of the view.
I wouldn't be surprised, but what the most likely candidate for a rock that was from down either in the bottom of Plum or from the lower part of Flag was that rock piece of rock that we chipped off of.
It's located right in this area.
Yeah, it's
here.
just outside of the view of this picture.
And because that had been, that was well under it was a submerged rock, and I got the feeling that it was sort of local to the area. I don't see how it could have been from South Ray, or unless that was extremely soft when it plunked in there. I didn't rule out that, but that would be the most likely candidate of the ones we could get to. There's no way we could have got down in there and got those rocks.
That's true.
And gotten back.
Since they took your tether away from you, I don't imagine you want to explore those craters. Okay, the Buster crater, photo 8, please. This is your partial pan of Buster. Again, not a winner for photographic work. It's at least as good as the astrologer's pictures, though. You described that there was a southwest and northeast boulder field in here. We're looking almost down the sun. I'm wondering, I can't tell in these photographs, could you tell whether there are blocks over in there, and therefore your impression of this streak across it could not be salted because you're looking down sun?
Well, I might have been. I didn't really mean to say southeast northwest. The predominance of blocks in Buster were oriented in this direction, across out this way, which is northeast southwest.
Yeah.
And
that's what you said.
Yeah.
And you're reconfirming that.
Reconfirm that. And over in this area, there you can see some of the blocks, but not nearly as many as here. Now, we can barely see the bottom of Buster, but the bottom of Buster is covered with blocks that were up to 2 meters across and showed no orientation in any direction. My feeling over in here, due to there were blocks in this area, but they were not as numerous as this pattern in here.
And so the blocks that you're on the side you were standing would have been derived primarily from that hole and not from the impacting material. It has the appearance of a secondary from South Ray in this kind of a photograph.
Sure
and the
does.
description of it, you not go with that interpretation?
Well, if it is, it's the biggest one we saw. That is a big crater. From here to here was at least 50 meters.
At least, yeah.
And the size of those blocks and the depth of that crater, and South Ray is 6 kilometers away. That had to be one big block that pounded into there. And I don't know whether you can even excavate something that large from that distance.
Much too large to be.
I don't really think it's a secondary, personally.
So my feeling that looking at it, it was a primary, because I couldn't conceive of how you'd get one from. Of course, it could have maybe been a secondary from one of those big craters way down south. That's a possibility.
Yeah. So that's either local bedrock or some of the flap or the thrown out material from Spook that we're seeing there in the floor and the walls. Great.
Spook didn't look like that at all. This was a lot fresher crater than
I'd hate to
Spook.
oversimplify this business, because it don't tell them where that rascal came from.
Okay, I'd like to have slide 9, please. This is North Ray Crater, and there were arguments among you guys and there are arguments among ours as to whether we're seeing layering in there. And I think the layering that you were talking about, John, is over in the right part where there's a dominance of blocks. Is that
yes, sir.
A true statement?
Right there.
Yeah, that's certainly one of the best candidates for...
Yeah, it's just hard to imagine how the blocks would either all slump down there and end up at that spot or slump down there and end up there. You know, on our geology trips, we ran across a lot of contacts that was a great deal more subtle than that one right there. And that's why I picked it.
There's a better view of that as you get on further to the north, Bill. I think it shows it a little bit deeper down. But there's certainly, if there is any...
The right polarimetric pan is I should have had rather than the left.
Okay.
It was in use when I needed to make the picture.
You know, up at going up Stone Mountain, there was one other crater that we were looking into as we were driving up Stone Mountain, where we could see what looked to be more like an outcrop than anything I've seen so far. In that it was the same kind of thing, only it wasn't broken up like that. It was just one solid piece. I don't think there was any way we'd have gotten up the hill to it. And we've got some photographs of that, and it shows up on a 16mm photography as we're driving up there, and I can point it out to you. But it was about that 1/3 of the way down from the top to the floor. The same kind of.
The rover.
But that's the only two places where I'd really call out. Well, I would hazard a guess that was outcrop.
That was outcrop. Off to the left there, you can see a vertical string of blocks right in the middle,
right
the far
here.
wall, yeah. And were there any visual observations you made of that?
Well, again, I got the impression we had areas, white areas, and dark areas. Now, maybe the darkening was just because of the shadows caused by the rocks.
Now, I got the feeling those were the dark blocks like house rock, and just like Charlie does, and I got the feeling there were places where there were strings of white blocks too.
These rocks right here that are more buried and the regolith is deeper in this area, are all white matrix rocks.
Yep.
Around this way, and really right out from this little block here is house rock sits here, and that is predominantly a black matrix rock. And I counted 9 radial block trails out of that crater. 1, 2, 3, 4, 5, 6, 7, and there's a couple over in here that gave you the impression that you could track them from the floor all the way out over the rim, at least as far as we could see. Distinct zones of blocks.
Good.
As the rascally axial craters don't really exhibit the classic overturned flap that we've been looking at. They are more complicated than that when they all get shuffling around on themselves.
In here, as I said, we had the impression that the regolith was more loosely consolidated because of a footprint impression I had. Down at South Ray, down at House Rock, we already commented that we couldn't even get the tongs or the shovel or the scoop in. And around the rover, which was sitting right back out here, we had the same problem.
And you don't get the impression from here, but the slope going down to that block where we'd had to go down to get a picture of the bottom of the crater was not the kind of thing I'd want Charlie to be doing without having that 100-foot line on us, so we didn't get any pictures of the bottom of it.
Well, we'll wait till we get the pan camera stuff to look into the bottom, I guess.
No,
or Ken's words on it.
As you
wouldn't mind
see,
him going down there, but I'd like to be able to get him back.
Yeah, me too. As you can see, here, the white matrix rocks had more filleted and appeared to be more covered with regolith than the larger rocks around over here to the north where the black matrix rocks, the house rock was. It had some filleting, but it was not nearly so pronounced as this area up to the to the south.
Would the House Rock TV pan do you any things you'd want to point at? I've got that up there in the slide if you want to. It's lousy, but it's.
I don't think
can
so.
Point things. Okay.
It's a big one.
Can I just ask how deep is that layer you're looking at? What depth below the surface, roughly?
I guess it's a quarter of the way down to the bottom. Boy, it's really hard to tell. You know, that rascal is half a mile across. So some of those rocks sitting in there must be almost as big as House Rock.
Yeah,
it's really hard to say. We didn't ever see the bottom, and it's about a quarter of the way down from where we could see. Yeah. I would imagine at the bottom of North Ray looks very much like Buster, the bottom of Buster, with bigger blocks. Yeah. Hopefully the pan camera will show that, but we never.
Pre-mission photography.
We just had a feeling you didn't want to get close to that beauty, that right in this area. There was a bench down in here that you could probably have walked out on and seen a bottom, but you'd have fallen off it, would have spoiled your whole day.
Sorry that you get the flight controllers mad because you didn't get back to the limb on time.
Yeah.
last station, calling 3 Shasta again.
Okay, this is tape number 14, continuation of section 23.0 with Jack Schmidt. Okay, flight data file, CSM. Generally, I have nothing but praise for the flight data file, both vehicles. There was very, very few things that one could have asked for to improve that data file for Apollo 17 at any rate. One comment on the flight plan supplement. We had split pages for a number of the logging, medical and food logging, and that probably was a mistake. I think the idea was fairly good initially, but the pages, we tended to only use that in the book as a whole, and it was a good place to keep them. And also the pages, if you had wanted them split, were too thin to maintain the split, and they tended to fall out of the book. I would recommend either not splitting or having heavier paper if you want them split. I had an extra cue card built for panel 229. I think it was an excellent card that summarized the circuit breaker functions both on 229 and on panel 8. Because we had no systems anomalies of any significance that would relate to that card, it was not used, but I would strongly recommend its availability, if only for training, during SIMS. It's a good quick review of what you lose or retain for those two panels. In the flight plan, I added some pen and ink cues along the margins for certain observational targets that I particularly wanted to look at. These are independent of any designated experiment, and I entered them as a function of time, and that seemed to work very well for me. I think it had that kind of thing as an individual preference item. And if you have experiment, it ought to be flight planned. If you're just planning to use your spare time for specific observational targets or types of observations, then I think the pen and ink is maybe the easiest way to go, since it shouldn't concern any large number of people. Gordy Fullerton fixed up the circular orbital cue card for me with a similar designation of craters as a function of time. I did not use that, not because it wasn't a good idea, but because of familiarity with the moon, which came very quickly after a couple orbits, and you could recognize your position on the moon fairly easily as a function of each rev, either the time in the rev, approximate time since sunset, or just because you could look out the window and tell where you were. In the LEM, the same comments apply. I think all the flight data file items were excellent.
I did not use the data card book to the extent that I know it was used on 15 and maybe on 16. We logged most of our specific items such as alignment data and comparable kinds of things in the checklist at the point where they were collected rather than in the data book, and this did not seem to raise any difficulty at any time. The cuff checklist we've talked about, I think, in the surface items. I thought the cuff checklist was excellent. I think we did the things. We had the right kind of photo maps in there that were useful for reference where we were around a given station. I don't think we used them as much as I had anticipated using them, mainly because navigation was no problem and the points that we had selected pre-flight were excellent points for investigation, and there was no need to try to decide on alternative points to try to study in the vicinity of a given station. The list of items to be accomplished at each station are really they were mind joggers to read at each station. Were not as used as much as I thought they would be initially, but I think that was mainly because we both, at least I, had become so familiar with the items that each station was in itself easy to recall as a result of having created the checklist. So checklist turned out to be more of a learning item rather than a reference item for use on the surface. I wouldn't have done it any differently, however. I particularly want to compliment the Chuck Lewis on the timeline book. I really can't sing on anything, but the timeline book was very, very well done, and we had no problems with the timeline book at all. But that, of course, applies to every checklist that we had. There were just no procedural errors that I recall in any of the books that we used. Fortunately, we didn't have to use the malfunction book, or only once did I pull out the systems data book to check on a systems problem, and I right now can't remember what that was. I don't remember what it was. Well, I did use it once. Charts and maps. I thought in the CSM that I would use the orbit monitor charts, I guess that's what they're called. And I had an extra one put on so it wouldn't interfere with the planned activities of the CMP. I did not use that very much. I eventually did some sketching on it post-TEI. I think there are about 5 specific points that I labeled as areas, A, B, C, D, maybe E, and these are referenced on my crew notebook, for specific observations. But in general, I did not put that to as much use as I expected. One item is that chart should have been identical to the CMP's chart, and there were a few pen and ink changes left off of it that caused some confusion at one point. Pen and ink exposure settings for certain photo targets. The CSM lunar landmark maps that the LMP had added in the rear of that book, again, were not used. I really thought I would use those, but you became reluctant as you were observing a specific point our area target, say such as Gagarin or something like that, to take time out to sketch on the photo. I tended, for the 2 or 3 minutes that observation was possible of a given area, I tended to look and then at the first opportunity to take notes in the notebook rather than trying to sketch on the photograph. And I suspect that this was because I tended to look for generalizations about the target that I was trying to observe rather than checking out specific individual features. And there really did not seem to be any need to make notes about specific points on the pictures, and as a result I did not use them. Again, though, I think having selected them and studied them pre-flight made it worth having them around. The necessity for flying them was probably less than the necessity for having reviewed them and studied them. I think I still, if I had to do it again, I still would want to have that kind of data available in the spacecraft, even though on this particular mission it was not used. I do think, though, that the CMP used his visual target maps considerably, and I did on a couple occasions use some of the ones that he had again, but for the most part that was post-TEI, and I made some notes and sketches on some of those maps. And I think that just a function that there was a lot of time to look at the moon and make a sketch and then look back and fix it up post-TEI, where in orbit the time just did not exist. As Dick Gordon said a couple years ago, and once you start flying, the clock is relentless. Okay, general flight planning. I was not very closely involved in the flight planning. Ron sort of carried the burden of that for both Gene and myself. The flight plan was excellent. We had no problems with it at all that I'm aware of. Tommy Holloway and his people are to be complimented on that. The number of different requirements and experiments and general operational items that were required to be integrated one with the other was very, very high, and it was done in an extremely competent and usable way. And I can't think of anything that I would change in the way the flight plan was written. Okay, 23.5 pre-flight support. Pre-flight support was excellent in the flight data file area. And one specific item that I had was once the flight plan was well established, just about at the final stage, I had 2 or 3, Tex, I don't remember, 2 or 3 briefing sessions where in the portions of the lunar orbit flight plan that I was going to be during which I would be was going to be in the spacecraft, in the CSM. We went over in detail the attitudes and maneuvers and the window availability, so that I was able to plan in a very short amount of time, with minimum effort on my part, my own personal observations of the lunar surface, and which went very well as far as planning was concerned. Appreciated that. That was extra above and beyond the call of duty on the part of the flight planners, and I appreciated their taking time out to do that for me. think it was useful to have the, I think it was a day-long session where the flight controllers and the crew and the flight planners sat around in one room and went over those portions of the flight plan which were not normally simulated. It turned out that the flight plan had been so well done that I doubt if there were any specific items that came up that we needed to change or there seemed to be a lack of coordination on. This was in contrast to previous flights where I think we were still learning, all of us were learning on how to put together flight plans and integrate requirements. Apollo 17 flight plan apparently reached the peak of perfection. I was a little bit disappointed in that briefing in that some of the people who would be eventually intimately involved in the mission were not at the flight plan review. And I think this was because of conflicts with other programs which were the center was carrying out at the time. Okay, 24.0, visual sightings. Well, we've covered the countdown and launch, I think, pretty well in the previous sections. Also powered flight, Earth orbit. I think the transcript would cover the visual sightings that I made with respect to weather and a few geographic observations, and the same would go for the fairly extensive weather observations that I tried to make trans-Earth or trans-lunar. Trans-Earth, we had only a small crescent of an Earth, and it was not feasible to do any extensive weather observations. I don't know whether I've recorded yet that although we had light flashes just about continuously during the whole flight when you were dark adapted, and I may have even had one which I thought was a flash on the lunar surface during the first rev. That one period of time when we had the blindfolds on for the AlphaMet experiment, there just were no visible flashes. Although that evening, that night, before I went to sleep, I noticed I was seeing the light flashes again. So it just seemed to be that one interval either side of that interval on either side of it where the light flash phenomena was not visible to myself or to the other two crewmen. Lunar orbit, I think the transcript and my crew notebook would cover all the visual sightings that I can remember at this stage without going over it orbit by orbit and feature by feature with the photography, and I think that has to come later. Entry we've covered in the previous briefings, and I think the same goes for landing and recovery. Why don't you stop at a second text? 25.0, pre-mission planning for the LMP. It's hard to think of, once again, of anything that we didn't do right. I'm sure that might have been different had we had problems on the flight, but right, the way the flight went, the total plan, the integration of the mission requirements into that plan, although there were periods of some difficulty pre-flight, particularly in the area of medical requirements, and in some last-minute possible scientific requirements, particularly on the samples, everything seemed to get resolved satisfactorily, as near as I could tell. And I can't think of anything that was not handled very well, between the people who were levying the requirements and the flight planners in particular, and occasionally when the crew had to be involved, that was handled almost entirely by the support crew, Bob Parker in the science area and Gordy Fullerton and Bob Obermeyer in the operational areas. There were no significant spacecraft changes in the course of our training period. Ron, I guess the biggest single area that took time was one that Ron had to deal with, and that was Lunar Sounder. Most of our ALSEP changes were all taken care of prior to our training, and we had a few minor suggestions that were taken care of early in the training cycle, and we essentially had an up-to-date ALSEP to train with, and all other lunar surface gear was up to date for most of the 12-month training period, or the final 12 months of the training period. Mission rules and techniques were fairly well defined very early by Phil Schaefer and his crowd. In the techniques area and the mission rules, certainly Jerry Griffin and people working on that. No major changes, and the only changes were all, I felt, in the right direction, in that they enhanced the probability of making a landing and a successful mission. They generally were in the area of opening up possibilities for workarounds so that a mission could be completed. We really never had to exercise any of the mission rules in an abnormal way. I think the one time that mission rule tended to, let me finish this, Chuck, a mission rule tended to be fairly clearly a controlling factor was in the limitation on the work at Station 4 or Shorty Crater, where we were up against the walkback constraints, and terminated that work after only 35 minutes, where another 30 minutes there I think would have been extremely valuable, although I hope that we got enough information that the phenomena exposed at that crater can be understood. Okay, why don't you stop it? 26.0 mission control. Typically outstanding support for mission control. I think this includes the number of extracurricular hours that the LIM people and the ECOMs for the CSM in particular put in with me on Saturdays and other times, just generally talking over systems and techniques and mission rules, and that was a major factor in helping me understand and keep up to speed on those items. I think the help that they gave me in designing, and the fact is they essentially did the design of the emergency cue cards that we did for Apollo 17 for the LIM, was a major contribution. Although fortunately we did not use them, they still made it possible to understand very quickly systems problems and to solve those problems in the simulations, and had we required them, I think it would have gone very well. I particularly want to point out the help that Dick Thorson gave in organizing most of the LIM sessions, and even some of the joint CSM LIM sessions that we had. And he also, Thorson also was a major organizer of the creation of and the updating of those emergency cue cards. Human factors, 27.0. Oh, let's go back. That's one other comment on 26.0. Post-flight, it's my understanding that some of the things I had hoped could be done during the flight were not possible because of real-time discussions in the mission control. Specifically, one of those things was to have some summary of the thinking of the science backroom given to me while in flight, and that would be the thinking based on the data that we had transmitted to them verbally and in a sense visually through the television camera. I had hoped that I would have the benefit of their thinking, but apparently this was not possible to do. I would like to think that in the future we can look at ways of using the team approach to science investigations in space rather than depending solely on the observational capability and the interpretive capability of the men who are performing the job. There's no reason that I can see to not use all the brain power that's available for any given task, and part of that brain power is on the ground. Okay, 27.0. Human factors, pre-flight. The brunt of the discussions and organization from the crew point of view of the pre-flight health stabilization control program was borne by the commander, and the LMP just sort of went along with whatever was decided. I personally did not find any great difficulty in working out and adhering to the requirements of that program. I think medical care, although very limited requirement, was good. A couple sinus infections I had reacted just like they always had, and we were able over a period of 10 days or 2 weeks to get those cleared up. Time for exercise probably was less than it should have been, although I was able to get a good workout just about every other day, in addition to the workouts we got as a normal course of our EVA training. Eventually, techs started putting on the schedule time in the late afternoon for exercise, and that helped as a reminder and buffer to see that exercise was obtained. It is generally hard, at least in the lunar training program, to get exercise periods in during the day, and quite frequently the exercise was done in the Cape gym at night. I think rest and sleep is an individual thing, and I made a particular effort to always get as much as I possibly could and try never to get behind the power curve on rest, because my personal experience is that is when I tend to get colds and resulting sinus infections. Medical briefing was good. The exams seemed to go very well in my estimation. They were as expeditious as possible under the circumstances. And the I think the operational medical personnel who carried out the exams are to be complimented in their efforts to see that the exam was as painless and as efficient as possible. And this should also include the post-flight exams on the Ticonderoga. Eating habits and amount of food consumption were normal, except during those periods of time when we were on the in-flight food prior to launch. And those times there tended to be, in my case, a decrease of appetite, and certainly although the food was certainly palatable, my appetite did go down, and it certainly was not possible for me to eat the amount of food that was provided for me. This also applied to space work, but in the case of the in-flight eating, although I did not eat everything that was available to me in my food packages, I apparently needed to if I had wanted to avoid losing weight. My appetite was down, but also apparently for some reason I had a loss of weight, and at this time of this recording my weight is still down, has not gone up to pre-flight levels, which may have been a little high, by the way. Okay, 17.2, flight, appetite, and food preference. Well, I just discussed that a little bit, and the appetite in flight versus 2 weeks pre-flight was less, again, except for when we were testing the pre-flight food, when I also had a low appetite. No notable differences in the taste of food. I think the things I liked pre-flight, I liked in space, and the things I didn't like, I also didn't like. I didn't notice any differences. Change in food preferences as flight progressed. I tended to start to prefer to eat the wet packs, and would eat those in preference to any of the other solid foods. I would strongly recommend, from my personal point of view at any rate, that the wet packs be used in preference to the rehydratable. Now, I think that probably you get a different opinion from the other crewmen. The juices were good. After the first period of, one and only period of difficulty with loose bowel movements, I did cut out the potassium indicated foods, and although I can't say whether that had any effect or not, but I did not have any other bowel movements, and certainly no more loose ones before the end of the flight. The first bowel movement after flight on the Ticonderoga was normal. The second was very loose. The third was normal, and the fourth and fifth very loose. The size of food portions and the meal portions, of course, were pretty much constant in terms of availability, packaging, but my appetite was very low the first day and gradually increased over the next 2 or 3 days, and remained essentially the same after about the third day. I mentioned the most acceptable foods were the wet packs and the juices. The fruit cake I thought was good, although it was possible to eat too much or to get to a point where you didn't want any more. The chocolate was good. I think of the dry crackers or cookies, the graham crackers were probably the most tasty. And peanut butter and jelly sandwiches were quite good. Deviations from the menu and the eat periods are all recorded in the flight transcripts, I'm sure. Okay, food preparation and consumption. Rehydration went, I think, nominally, and the nominal gas was present. Food temperature tended to prefer the foods that were warm or hot, and the hot water was quite adequate for warm foods. We actually, I think, missed the warm foods considerably in the limb where that hot water was not available. I did not notice an effect of water flavor. Water was reasonably tasty. I mean, it did not. I never noticed a high chlorine taste of any kind. Although the gas content did make it a little bit uncomfortable to eat at times. Spoon bowl packages worked pretty well, although those that were finely divided, I tended to cut off the other end of the package, the water insertion end, and use them as a squeeze package. Spoons worked perfectly adequate. I tended not to use the fruit in the cans because of just the messiness of opening and those, although I think the technique that Ron worked out of opening it in your inner near your mouth is a good one. Puddings and this kind of thing were very good. It was only the fruits, the canned fruits, that I tended to avoid just because they were inconvenient to use. Food bars during the EVAs I think were good to have, although I never ate more than half of one. It wasn't because it was untasty, it's just because of a maybe a lack of interest in eating and using that time during the EVAs. I think after the EVA, before and after EVAs in the limb, ate very well. There were some things, though, we did not, we avoided. And I guess in my case, after having corn chowder once and that stimulating a major bowel movement, although not a loose one, I did not eat corn chowder. I did not eat the cocoa because I tended to feel like I got a little more gas from cocoa and an aftertaste. I did not eat the shrimp, the seafood items, shrimp and the lobster bisque and these sort of things, because of pre-flight I had noticed that they tended to have a long aftertaste. But otherwise I think all the other foods were certainly acceptable, although many times I did not eat potato-based foods because of they were very filling. An old donut. Okay, food waste stowage. I don't know how the germicidal tablet worked. The pouch was okay. Would have been nice to have a little dispenser that was easier to use than the pouch. I don't know whether that would be possible to do or not. It seems to me it would, a little tube dispenser of some kind where they came out more easily. You didn't tend to, we generally just cut the corner off a pouch and squeezed them out, but it was a little inconvenient, nothing major. We used the germicidal tablets, I did at any rate, in all the juice bags and the food spoon bowl bags and the wet packs. I did not use them in the tea and coffee. undesirable odors, really, except for the passing of gas occasionally by the other crewmen and some occasionally by myself. Undesirable odors were at a minimum. I did not find that the atmosphere was unpleasant as a general rule. I might say that I generally had a continuous, almost continuous passage of gas, most of which apparently was not with significant odor. Only occasionally that it seemed to be objectionable to the other crewmen. And I think most of that was the water gas. And the reason I think that is that upon eating, upon starting to eat, there would be an increased desire to pass gas. The increased pressure in my stomach apparently was transmitted almost immediately into the bowels. And I would, after eating, would pass gas for a couple hours to 3 hours. And just before eating the next time, the desire would have pretty well dissipated, and then it would start again immediately upon eating, before any digestion was possible, I'm sure. So I suspect water gas was the main culprit in the LMP's gas problems, which were not significant. Quantity of food eaten on the lunar surface, I think, was high, although probably no more than half of that food that was available. It's hard to say exactly, and I think that could be worked out maybe with a detailed look at the menus if that is desirable. And to estimate the quantity would be very difficult. Quantity of food discarded on the lunar surface would be difficult without looking at the detailed menus and checking off those items that I'm sure we ate, that I ate at any rate. Skylab fecal container. I don't know that we had that.
Well, she did, but
we used a blue bag.
Oh, that's right. We flew that on 14 in this one.
The blue bag is not a bad way to defecate unless the stool is loose. If it's loose, it's just about impossible to use. And I don't know what you do in zero gravity for loose stools. I don't know of any clever way to prevent that being a problem, and I'm not even sure whatever the Skylab people are using will prevent that from being a problem. The best thing you can do is to work out prevention of loose stools rather than trying to handle them after you get them. It is, a loose stool is one of the major hygiene and sanitary and operational problems that you can have on a flight. I can't emphasize that more. You can, if it happened on a regular basis, on a daily basis, you would, I think, eventually cut the efficiency of the crew member with the problem by a significant percentage, possibly as much as 30%, depending on the magnitude of the problem. I think it's important to try to understand why Apollo 17 was different than 16, and at least in the delay of a problem with loose stools until about the 11th or 12th day. And in the case of the commander, no problem with loose stools. And my personal opinion at this point, based on very little information other than observation in flight and thinking about levels of electrolyte intake, is that with the electrolyte quantity down from that imposed on Apollo 16, that we did not reach a electrolyte saturation level until the 11th or 12th day in terms of this CMP and the LMP, and in terms of the commander, because his electrolyte intake was generally less, I think, and that can be documented, he did not reach a saturation level at all. And when that saturation level was reached, however, in the case of the CMP and LMP, I suspect that the electrolytes we were eating were dumped, in a sense, or concentrated in the intestines and tended to act pretty much as a laxative, and as an Epsom salt type laxative, if you will, and concentrate water in the stool. I think it's important for Skylab that, first of all, we probably reduce the electrolyte intake so that saturation is never reached. And secondly, that if a loose stool problem develops, it appears to be an electrolyte problem rather than any other biological problem, that we decrease the intake of electrolytes. This is what I did on my own, and whether or not it worked or not is hard to say because the flight was terminated before any other stools occurred. Okay, water. Chlorination odor was not apparent to me except during chlorination. Iodentation odor is very slight, apparent in the limb water, but not of any significance to the LMP. Physical discomfort, no physical discomfort for the LMP, other than tiredness on occasion, and in the case of the EVA work, sore muscles and the bruises under the fingernails. Gas water separator didn't work very effectively, and I'm sure that's been discussed elsewhere. Intensity of thirst during emission, never really thirsty, extensively thirsty, even during the EVAs, although I did stop to take a drink of water occasionally. But I never drank all the water in the in-flight drink bag, in-suit drink bag. Work, rest, and sleep. Okay. Hey, Tex, yes. Could you try to call the trailer? Where was I? Work, rest, sleep for the LMP. The difficulty in going to sleep was variable, and when Seconal was used, generally no difficulty in going to sleep. When it was not used, I guess there was a tendency to stay awake a little bit longer, but on other occasions, the absence of Seconal did not seem to affect the rate of going to sleep. There was a tendency on several nights to go to sleep and then wake up fairly soon after going to sleep, within an hour. And then the second time took a little bit, maybe sometimes took up to an hour to go back to sleep. But I feel that the medical log reports for the LMP were generally valid, that probably an average of 5.5 to 6 hours of sleep per night was good, and I don't think, except for maybe one night somewhere in there, did I go much below that. But the sleep was rarely, probably never continuous for more than 3 hours without waking up. I feel that 6 hours is adequate sleep for the kind of work we were doing in space. However, the programming of 8 hours is necessary in order to get 6 hours because of the periods of wakefulness during sleep periods, and for just the difficulty in getting the cabin organized and everybody to bed at the program time. So maintaining an 8-hour sleep period is, I think, mandatory in order to obtain the 6 hours that is probably all that is required to perform the mission without getting tired or getting behind the power curve, as they say, with respect to sleep. Restraints, I had the feeling that, did you find anybody over there? I had the feeling that I wanted to have my head and limbs restrained in order to get a good sleep, although I did sleep at times without that restraint. If I were rebuilding the sleep restraints for my personal use, I would make them smaller with a somewhat more feeling of restraint. They're a little bit large, I would say, for use. When I slept in the couch, I tended to put a shoulder strap over my head and cinch it down very lightly so that I had that feeling of head restraint. Probably the biggest two things that made sleep difficult, when it was difficult, was the loss of sensory perception of limb position in zero gravity when they were not being moved. That perception came back immediately upon moving them. But when they were just static and in a rest position, there tended to be, for the LMP at any rate, a loss of sensory perception of the position of the limb.
You're coming through loud and clear.
Okay, I guess we got 3 mics. One for each. More mics than we need. Morning, Charles.
Hello. How are you?
Fine, how are you?
Fine.
Good.
You're fine.
Good.
Yeah, we tried to go through this, your debrief last night, the printed one, all the stuff that you guys did on tape, your tech debrief, to get those so that we try and not repeat, only amplify stuff. And so we've tried to come up, we have much time to do that, but I hope we got most of that stuff. And
okay.
If you think we're hitting some area that you think, is a conflict with that, we'll yell, tell us, and we'll
Alrighty.
change her around. And some of the things, now there were some things that you guys said yesterday, when I was in the project debrief that probably bear on some of these too.
Good morning.
Good morning, Ed. Morning, Bill. Hi.
Hey, Craig.
Are we using those mics?
I don't know. We're gonna hot them out. Hot them on the floor.
Before we, start asking questions, identify yourself so
Yeah.
people that are transcribing know our voices.
Yeah.
Say who these people
Somebody know about sources of counseling? Sources of
Sources of potassium in the diet.
Yeah, I'm gonna get that from somebody.
Yeah, I think Smith and Rapp would do that.
Yeah, I'd like to know how much they really had.
I don't know offhand.
Yeah, I don't either.
We don't have any.
But that's some stuff I'd like.
I saw a picture today. It was a lot better than the one they had yesterday.
More interesting too.
Yeah.
Sorry about that.
Yeah, we're on the door of the.
Hey,
Yeah.
I got some things that I thought requirements is the first thing.
Another one, the audit.
Yeah.
That's going to be hard to do. Watch the action. I don't know.
There isn't anything you can do. I heard what you did.
Okay, the show's all yours. What kind of a format do you have in mind today?
Okay.
Questions and answers.
Yeah. Questions and answers. I guess we ought to, for the tape, identify this Dr. Berry and for the medical debriefing, and I'll try and ask most of the questions. If people have some here, we'll try and hand them in that way. If they're not, will you identify yourself? And I think they can identify you guys' voices pretty well already on the tape, so there shouldn't be any problem with the tape thing.
Chuck, I think we're going to have to peek up those mics.
They're not loud enough?
It's a little down, yeah.
Mr. Bernhardt.
Where is he?
I'll take care of it. Probably outside, I guess.
Can you get him to turn them up some?
Well,
We can yell for a while here if it'll help, and then we can get them to turn them up some.
You just speak up loud.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
I think it's coming out of those.
Is that where it's coming from there?
Craig will get somebody in.
Something
They got Tom.
Try it again.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Test out.
Something better, slow down.
Ah.
I think the knob's wrong on this.
Mark,
You're
you
reading
just
it
about.
loud and clear back there.
Well, it's not coming in there, though. They're
not.
not getting it in there.
Okay.
We can hear them great, but they're not hearing us very well.
We're hearing both of you real fine back there. They want that mic turned on.
Yes, inside.
Inside. The speaker, not the mic.
Okay.
It's better whatever they did.
I set it on the minimum setting in here instead of the max. The max seems to be men and vice versa.
Oh, really? Hey, that's a lot better.
Okay, that did it. It's labeled wrong.
They're just screwed up in
That's
there.
too much.
Yeah. Yeah, we can hear you loud and clear now.
It's great. Okay, that's good.
Okay. Good show. Okay. I'm going to start a little bit out of order here, but one of the things that sort of pervades it all is medical requirements. And in this section 27, you had some comments about the medical requirements, and I thought we ought to just get one question with you. In explaining the medical requirements, we have one opportunity to do that with Deke, of course, at the time that we're trying to get the medical requirements document published. The only opportunity we really get to go over that with you was at the 30-day briefing prior to the flight. Now, did you guys feel that you had an understanding of what the requirements were? Because when I read this, it sounds like you did not. Is that true?
I think I read the forms, Chuck, and understood in general what you were after, at least the number of sessions we had.
I think it's a question of degree here.
Yeah.
Okay. Well, one of the things which I think is a very valid thing, like Al's comments about, you should substantiate the requirements, no question about that. They should be clear. They should be clear to you in the sense that you ought to know that what you are doing is worthwhile and the stuff is used and it isn't wasted somewhere down the line. Somebody isn't just doing it for fun.
Yeah.
And we try, that's something we try to iron out pretty hard in our own house. And one of the things I'd like to do is if you guys end up at sometime before the end of the quarantine period here and have some time, we ought to have that data together by then. And prior to the time that we end up getting you out, if you've got an hour sometime, we might be able to go over with you and show you, here's what we saw with you and with the lab data and the whole bit, and say, because it's very hard to get back together again after you get out of here to do that sort of thing. Everybody says they'd like to know what happened to them. We could do that to you in here and tell you that, and here are the samples that were used to do that, so you have some idea, understanding about how that happened. Would that be worthwhile to you?
Yeah, the comment was made not from a point of view, a specific complaint about our flight, but just, I think, a continuing understanding between the two directorates.
We agree.
Ahead of time, because it's the kind of thing, well, just like with other scientific experiments, unless the crew understands the reasons and agrees with it, the thing isn't going to be a successful experiment.
Amen.
So the comment wasn't made from a point of criticizing anything specifically about our protocol at all. Just to reiterate what everybody ought to know but doesn't always think about.
Yeah, good.
And I think, Chuck, also, probably the last few weeks before flight is not the time to try to brief the crew on the medical requirements. At that time, their thoughts are quite a bit on other things, and perhaps it needs to come earlier than that.
That's a good point.
I think each one of us is concerned with ourselves medically, as the medical effects, the physiology of flight, et cetera, et cetera. But the last few weeks, you just can't get yourself cranked up to really think about those things, except for the things that are going to happen to you so you can be mentally prepared for them.
Right.
I think I may have precipitated that comment, at least when we got to that area and started that, about And I guess it really wasn't a complaint, Chuck, as much as just a statement that it's a drag, you know, going through collecting urine for 24 hours and so forth. And,
No question.
And you know, I just wanted to toss it in that you sure hope that it's worthwhile, and I think it would be interesting to sit down and see what you're really doing with all that.
Good. I think that's really needed, because we're trying to do that right now with the Skylab crews, to tell you what we really know about what happens to man, what we know from the Russian side of the thing as to what's happened on even their longer one, put the thing together and say, here's what we don't know and why we need to know it.
Well, I think we understood, or I understood your need to work out the total body water bit, but the actual mechanics of how that fit into a 24-hour urine collection 6 times and all the blood drawing and how that all fit into the picture, the theoretical picture you were painting for us, I never understood that.
Good. Okay. Fair enough.
You know, I think everybody understands all these things. Why don't we make a specific recommendation at this point? Now, you know, all the flight crews have a training plan which is set up about the time that the flight crews are designated, and includes all kinds of things on the simulators and scientific briefings and everything else. And why wouldn't the best way to do it would actually to schedule the time for medical briefings early in the training program? Because I think if you all, conversely, if you all feel that an experiment's worthwhile doing, you want to get your protocol settled early in the game so you have all the equipment or whatever you need.
Amen.
Ready, so it will be a satisfactory test. So I would suggest that maybe sometime something be scheduled in the crew training program early in the game.
Yeah. And I should
think it becomes one of those things you've got to check off, like systems briefings and everything else.
And I should think that briefing should consist of a bit of the theoretical thing you're trying to do, followed by the mechanics and the protocol.
What that means to you.
Yeah, that's right. The mechanics of how you go about doing it, and the number of punctures, and where you're going to do it, and how many urine samples, and that sort of thing.
Great.
Just so the guys understand.
Great. Okay. Will do. Right. That's great. I'd like to go back and pick up one then on the exercise area. You mentioned this in the debrief, and you mentioned it again in the yesterday. But can you give me some idea? Now, you said you missed, as I remember the debriefing statements here, you commented that you missed one day on the way out and one day on the way back. And can you say what you did in time? What the exercise consisted of, what you did roughly in time? I know you won't know to the minute or second or anything, but as roughly as you can. And then if you have any idea, did you try and judge what you did as far as, did you try and get a heart rate increase, or did you try and judge your exercise level in any way? And this is particularly important for us in trying to separate out the effects that are different between the two of you who are on the surface versus Stu, who was in the spacecraft all the time. So we want to keep that, we want to get that straight if we can. Could you just sort of brief the exercises to the way you did it? Maybe each of you have to do it because you probably did it differently.
But what we were shooting for was about a 10-minute period per day, exclusive of the 2 days of lunar surface activity for the two of us. And Stu was going to try to get about a 10-minute period per day for including those days. The method of exercise during the 10-minute period was to use this exogym device which we have, and to operate that in such a fashion that the old, what they call the big four, where you start out with your legs and feet in 2 loops and your hands controlling the friction device from crouch position to a full stretch out, and do that several times. Then hold the fixed loops and use the legs on the movable loops, and then hold the fixed loop with the toes and use the biceps on the movable loops. That's the general pattern that we tried to follow, but we didn't make all of those time periods. We missed the first day out because of, well, we didn't have it scheduled the first day out.
Well, it was in the flight plan, but we hadn't. I don't think anybody's going to exercise the first day, anyways.
No.
Yeah. In fact, it should never have been in the flight plan to exercise the first day.
Pretty hard to get that in that first day. I don't see how you
problem
do
with
it.
the docking probe, so that puts them on.
Well, you don't really need it in that first day anyway.
Pardon?
You don't really need it in that first day.
Well, in retrospect, I think that it would probably have alleviated some of the sore back muscles that first day if we'd gone ahead and done it. In my case, anyhow.
It was kind of like one of those things where they said, okay, you want to exercise, you put it in the flight plan. I said, yeah, we got to have it in the flight plan, we won't do it. Where are we going to put it? I said, put it in before lunch every day, before the mid-meal every day, and that's how we got in there.
Okay. Now you said exergym, or is it the exergenie?
Exergym, I think.
Exergym's a trade name.
Yeah, they're both similar devices.
It's the same thing. It's the friction one. Yeah. Okay. Yeah. Okay. And so 10 minutes a day is what you had programmed for the thing. And did you have any? Do you have any? Did you feel that you really got a fair amount? Did you get up any increase in breathing rate or heart rate that you were aware of when you did it?
Yeah, we didn't do it quantitatively, but certainly.
Yeah.
I always tried to stop short of cracking a sweat. It's just not desirable to get all sweaty in the spacecraft. And I felt like I was pulling it somewhere around 10 to 15 minutes. I could feel the heart rate going up and the breathing going up, but I would never do it to the point of a sweat. And it's not a vigorous exercise, it's more of it's a tension exercise.
Right.
We put enough load on it to where it was a hard pull, but a slow pull.
Okay, Stu, did yours go about that same way then for the whole time, even when you were alone?
No, I'd like to just summarize exercise. In my case, I probably didn't exercise as much in retrospect as I would have if I were doing it again, for various and sundry reasons. One is, you don't feel a need for the exercise. You just got to say, well, I'm gonna go do this. And there were a couple of times that we got out the, it says the exercise period, so we got out the exerciser and Alan would have at it, and I'd be doing something, or I'd say, well, I'll put it over here and I'll get to it in a minute. And then I know on one occasion, several hours later, I finally got around to getting it and doing some exercise on it. I'd say probably 5 to 10 minutes was the length of time. I would strain pretty hard. I didn't work up a sweat, but you use this thing, you can use it about any way you want. You can drag them through the ropes. It's really designed to where you hold and do an isometric first, and then go right from the isometric into the isotonic, and you get the whole smear. So I'd hold pressure on the thing and strain against it, and you can strain as little or as hard as you want, but I'd strain reasonably hard and then relax the tension and pull it up. But I'm trying to think. I'm sure that I missed one exercise period on the way out completely that Alan had got in. I did no exercise at all in lunar orbit. Thinking of the exergym was never even crossed my mind for those 2 days. And then in preparation for entry, I said, boy, I'm really going to hit that on the way home. As it turned out, I barely got in the one exercise a day that we did on the way home. So I would say overall, I'm sure I didn't hit the exergym as much as I probably should have.
Okay.
I don't know how, from my point of view at least, how you, in a case like this, where you're trying to correlate the relationship of the exercise that Ed and I did, for example, and its benefits or lack thereof with respect to the lunar surface period, which was over 30 hours. I just think the basic workload there alone is enough different to put that exercise thing down the noise level.
That's
its contribution down the noise level as far as the two of us are concerned.
I think that's probably very right now, and I think the thing we want to know is was Stu trying to make up for it in some way with exercise in the spacecraft? Because he obviously, I mean, there's no way he could make up for what you were doing on the lunar surface.
He was trying to, but he had a real busy flight plan.
Yeah. I don't think he could do it. And this is what I wanted to find out. Was he trying to do a lot more or something during that time? So.
No, I wasn't. I think that'd be a difficult thing to try to do, really. I don't know. You're going to, maybe with the longer period in lunar orbit, CMP may not be quite as busy, or maybe. I suspect he probably will be. I think it's going to be difficult to get in much exercise there. But no, I wasn't.
It's going to vary between individuals.
Yeah.
So it was obvious that Stu's greater interests were in running the spacecraft, and for example, the B-23s took a lot of time, which you might otherwise have allowed. That was this is the kind of thing I'm talking about. That if you're going to get individuals to try to exercise and respond to exercise, then you're going to have to get through really to explain the benefits for the crew as a result of that.
Right.
Because it really is an individual thing.
That's right. And we haven't tried to set any numbers of times that you do anything or anything like that. And so I think we need to really carefully look at that as an area. Okay, Ed, while I add one that came up yesterday when you guys were talking about Myrtle, reminded me of the problems that you had in flight with the urine, kinking of the urine hose and so forth. How much time did you make a conscious effort in your own particular case, because it's important trying to chase down your status post-flight here, of the time that you had the in-suit urine device on? Did you have it?
Me? Well,
yeah.
It wasn't my hose, it was kinked,
Right. It was Al's.
Yeah.
I get her twice Al's was, is that right?
Yeah.
Apparently all the time.
All the time, huh?
We,
oh yeah.
We had it on, I guess we have to look back on the transcript or look back over the flight plan to know when we took it off the first time. We all unsuited at the same time, which was about 6 hours, 7 hours into the flight, all right? Somewhere in there. And we put the UCTAs on PDI morning, and we took them off only when we got back to the spacecraft after docking. And it was on for those 2 periods only. And I never experienced any discomfort. I never had any problems whatsoever that we discussed pre-flight. No symptoms, no of any sort.
Great. Well, it looks like, we haven't had any, and you did well. How did you feel, that's another one we might just get out of the way. On fluid intake, it sounds like you all thought the water was great, and so you were drinking well. Were you trying to force fluids? Were you trying to consciously force fluids?
Yeah, I think
you and Al.
In my case, anyhow, I tried to take a drink out of the water gun about every time I went by it. I did find that I preferred the juices to water, and surprisingly enough, as much as I did not care for the juices pre-flight, particularly, I didn't crave them or anything, we were drinking a couple of juices per meal a large portion of the time. I was. And in addition, taking a shot from the water gun about every time I'd go by it.
I forced myself to drink the water, not that it tasted bad or anything, but just to keep the fluid intake up. And so I would drink water, like Ed says, every time you pass the water gun, you say, well, I think I'll try some of that, and one person would take a drink of water and pass it around and would put it back up.
As I understand, though, you stated in the debriefing you felt you drank about half as many juices as they did.
I'd say that's probably a good average. I'd say probably a third less.
A third less.
Yeah,
in juices.
Mm-hmm.
Okay. Yeah, you drank 2 juices at some point.
Yeah, I drank 2 occasionally. Toward the end, I was drinking 2 more than I was, because a lot of times you drink a cocoa and a juice, and I'd bypass the cocoa, and I'd just drink a juice. So I'd say probably, and this is a wag, but I'd say a third less juice than they did.
Okay.
Well, I think I kind of decided I was going to try to do everything I could to end up in as good shape as I could at the end of the mission, which included keeping the fluid intake and the food intake up, as well as the exercise. And that's generally what we try to do.
You did a great job of it, I might
We
add.
had to try to get 2 juices per meal most of the time.
Okay, there was a question here about for you particularly. So did you eat more, do you feel, while they were with you, Al and Ed were with you in the spacecraft, than when you were alone? Eat and drink better? I saw in your food thing.
Well, I'd say, excuse me, go ahead.
I saw in your food comments there that you had difficulty, the food preparation thing you'd have preferred if you'd have had some canned things you could have opened quickly and gotten to when you were alone that way, and I can surely understand that. I think it's something we ought to look at. But
Well, that's the way I did eat.
Yeah.
Because we had them there. I guess it didn't come out right because that's the way I did eat in lunar orbit. I would say, I'd say the answer to your question would be yes. That I ate more when they were in there, but the idea of people being together is nothing in that. It's a time factor.
Yeah.
During the coast phase, you have more time to worry about eating. During that lunar orbit phase, I didn't have any time at all, and any extra time, and particularly with the troubleshooting the Hicon and so forth. So I didn't have the inclination nor want to go to the trouble of trying to mix up a meal as such, and I didn't much like going to all that trouble anyway. So I opened up, a can of that chicken salad, I think it was, and I had that for breakfast, and then a wet pack, and that's the type of food that you can really get to in a hurry and eat.
Right.
So I wouldn't say overall that I probably ended up eating too much less, but it was a little different rather than sitting down and mixing up a rehydratable pack and so forth.
So the total amount you don't think was any different because you're there, but it was just different kinds of food then?
It may have been a little less, but
do you personally feel, now the weight loss is involved here, yours, that they you got 1 pound each here, and you got a 10-pound one, and I heard your comment about the scale yesterday too. But do you have any personal reason why you think there's that much difference in the weight loss? I mean, is there anything that that you personally tried to account for it other than food intake, water intake, or anything of that sort?
no, I'm not sure that there's anything magic about the 0G or the flight. I would suspect I'd probably lost several pounds if I'd eaten that same menu and sat right here. I probably think that I was 3 or 4 pounds overweight when I went into the flight. As a matter of fact, I'm not a big eater, and during most of the time you come up on training, I drink a can of Sago and a can of V8 juice for breakfast, and then I eat a sandwich for lunch, and maybe drink 2 or 3 cans of beer and eat a sandwich in the evening. And yeah. I can go for days on a menu like that, and I don't know how many calories all that adds up to, but it's not really a high calorie diet, and I would say that pretty much was my diet for 3 months prior to going into quarantine. Was just about what I stated there. And then when we got into quarantine, well, then I started eating more for breakfast and eating a bigger meal in the evening. And so I think I probably was 3 or 4 pounds heavy going into the flight. And so I think the weight loss may be overplayed a little bit, because I think I had a few extra pounds, and then plus I don't think that maybe we picked the right weight up on the rolling scales. But that's neither here nor there,
Well, we can probably show you something about that from when we get your lab material pulled together, I think we'd be able to give you a better handle on that as to whether, you know, it really was something that had to do with the zero-G state or not. We hope we'll be able to do that. So we'll try.
Well, if I could just add a general comment, which I think reflects the consensus here, the three of us, that with respect to the food in general, the type of food, the method by which it was packaged and so on, and the degree to which we liked or disliked it was primarily a function of the level of activity in the flight plan. That the business of going into the pantry and taking time to select foods and drinks and so on is fine during the quiet periods of coast. That things like spoon packages are good if the level of activity is not too high, but certainly if the level of activity is high. The wet packs and the cans, and that's about all you want to take time to fool with. I think this is a general comment that really reflects our consensus.
It was a time-consuming part of the day to prepare meals, get them out of the food box, get them all laid out, cut all the tops off of them, get all the water into them, get them massaged, and go about eating.
Get the pill back in there when you're through. You know, it took a lot of time. It's an effort.
You're right.
And you know, it's a lot easier to open up a can in a wet pack, and then you think it's a lot of trouble to even mix up the juice. But you know, in that way you got your meal and you're through and you're on your way.
Right. Okay. The cooking problem, quotes, is still a problem. Which has been fairly common, I guess.
Yeah, I think if you got plenty of time, you don't mind spending an hour or so.
As a matter of fact, it's a very pleasant hour.
Yeah.
It gets rid of that time very effectively.
But I would say in my case that watching these guys eat, you know, they went right down the menu, and so I thought, you know, I really should do that, but I just didn't have an inclination to eat that much. You know, even though you know in your own mind, you know, hey, you ought to do this, you know, and you ought to keep yourself, you know, eat just as much as you possibly can. I just couldn't get around to doing it. In fact, several times I'd mix the food up. And then by the time I'd eat a couple of packages, you know, I just couldn't get to the third package, and so I'd put it back in the pantry.
Well, Stu, one of the things that's going to come out of that is somebody, you know, reading the debriefing itself. The obvious question comes up: okay, was your lack of appetite itself, was it just plain lack of appetite, or did you really have any discomfort in your, as far as the gut was concerned at all? Anything that you felt was pathological in your loss of appetite due to the environment or anything?
No, I don't think there's anything of that. Like I say, I think it boils down to a lot of just too much food. You know, if you bundle up one of those meals and there's just too much there to eat.
Were any of you ever thirsty in flight? Did you feel thirst?
Yeah, you were dry quite a bit. You know, you'd have the sensation of dryness, and you'd want, and water, you know, juice would make you
want some water.
Yeah.
Did you, while we're at it, we might just wipe out the water thing. Did you guys drink the water in your suits? EVA?
I did.
Yeah, drank all of his. I just drank about a third of mine.
About a third.
On the first one, I don't know how much of mine I drank. I thought I emptied the bag, but apparently the walls of the bag got around the drink tube, and I didn't get it all out because it drained down around my neck during the sleep period.
Okay.
I had a leaky one also, which I took out between EVAs.
Okay, did you fill them up again then when you went out second EVA? And you drank about, you think you drank about a third of yours both times?
I'd say, yeah, I didn't really stop to drink too much.
Yeah. Okay.
And I drank on mine the second EVA, and I can't remember whether I drank it all or not. If I didn't, there may be some still in it.
Okay. All right.
Hey, one other comment on while we're on there eating, before I forget. We ran completely out of these bite-sized packages, you know, and to me that was the best thing we had. These little, you know, turkey sandwiches, cheese sandwiches, and that sort of thing, because that was a no-sweat operation. You just clip that off in a can of juice, and you could go at it. So I really liked those, and I eat all those generally that I could get my hands on, and we ran out of those.
Well, we ran out of most everything else too. I mean, just about everything.
No, not really. I had all kinds of food.
If I may make a comment, if you don't mind, about about his eating and drinking habits. This flight plan is really something that he worked on and developed for the flight. It's a busy flight plan. It's a full one. And it was my impression that he was more interested in being sure that the flight plan was done properly than eating.
Oh, yeah.
I think that affected it to a great degree. Which again gets back to the level of activity versus the... If you guys can get a little, for example, in those drink bags, get a little diaphragm on the end. Just stick over a needle and pump the water in that way. And shake it up, pull the plug out, and drink it out of the same deal. That would be a lot easier for those drinks.
I mean, for the juices and things, you mean?
All the cutting.
Yeah, so that you don't end up having to sort of feel you got to drink the whole damn thing once you get it done.
You see, you get a drink bag and you get a little gnarled thing that's all sucked in, the plastic is all folded down. Unless you got it exactly right, first of all, you can't get it in the nozzle without having it leak. And you get it all done, then you got to go cut the other end. And I was just thinking maybe it might be an easier way to put a diaphragm fitting on there that you could stick over a hypodermic type of thing and get the water in that way. Might be a little bit quicker way to do it.
Okay.
Anything you can do to make it easier is going to help increase the consumption.
Right.
Particularly during busy time periods.
Okay. But could we get you, now this is going to involve just really Al and Ed. We'd like to have you describe as well as you can the things that you did with your bioinstrumentation harnesses because it's very hard for us to be sure exactly what happened. We don't have that stuff back yet. We're going to set up, we've got to develop a plan to troubleshoot it. And as the thing that happened with yours, Al, just from our point...
You want the actions, not the words, huh?
Pardon?
You want the actions, not the words.
The actions, not the words, yeah. Okay. Well, you said some of the words, too. But from our point of view, what happened with your particular harness is everything was fine when everybody left the MSOB, okay? When you got into the spacecraft, right after you got, apparently when you were getting cinched down somehow, because we had about 3 minutes or so after you were in the couch of good data on you. Then we began to get erratic data. It began to wander, the baseline began to wander all over the place. That continued to get worse and worse, and pretty soon it was going just full scale, which was totally unreadable. So the question was, okay, it was a question about hatch closure at that point in time. We decided right then. I said, well, hell, we're going to go without that because sure it's a sensor, and the only way to get at it anyway, we asked you then to try and press on those things. If that wouldn't do it, if that wouldn't reseat it, then the first opportunity would be when we got you actually in flight. Now, we don't know why, but it came back. It was gone still when you went over Australia. As you came back up on the States, magically, there we had data. And we went back to the MSOB from the firing room to catch that pass, and there you were, whap. That was beautiful, just as if nothing had ever happened. And you hadn't done a damn thing, because then we asked them, had you done anything? Now, as we understand, when you looked at that sensor then, that you did have some material had leaked out from underneath it, and we understand that you replaced that sensor, you cleaned up and replaced that sensor. Is that right?
We didn't replace the sensor, no.
Okay, just to
cleaned it off, refilled it, put a new sticky back on it, and put it back on.
Yeah, okay.
That was the second day into the flight, though.
Yeah, this was
Yeah.
like the second day.
Right, yeah. That was the first time that we really, and that we asked you to do that then because we thought we'd get it out of the way before you got into the, okay. Now then you had another.
I also changed the adapter, the CWG adapter, because at one time on the flight they said my comm wasn't very good.
Yeah, your comm was terrible, right.
We had a spare adapter, and so it changed that. Exactly when that was, I don't know. But
that was pretty early, too.
I think it was the first day, perhaps.
Yeah, I think it was the first day.
Al, that was the Lord's.
That wouldn't have anything to do with the launch problem, because of course we're
No.
using a different...
No. And we had a respiration on you. You can see respiration, but we didn't have the...
That's good.
Yeah, but we didn't have an ECG.
That's very reassuring to me.
That's right, good.
Hey, Al, can you correlate the reappearance of your EKG signal with any flight plan activity that you might have been doing?
I sure can. I'm just as mystified about that as you are. I tried to press it through the suit and everything.
It happened.
You can't feel anything through the suit.
Well, you were free then, though. You had your helmet and gloves off.
It was 1 hour and 30 minutes GETM. I don't know if that rings any bells to you.
Helmets and gloves are on at that time, and we were moving around with the post-insertion checklist, and there's some movement in the couch, so I dive in and get some things and pull them out, unstill that sort of stuff.
It's just got to be that you were probably it was in the cinching down in the couch that it probably loosened that edge of that sensor somehow a little bit, and I don't know why.
Or put a crimp in a lead, or brought it into contact with something else.
Yeah, because it sure came back fine after that. Okay, then the second time, what else then did you have with yours, Al, from your point? What else did you do to the thing then on it?
The only other thing I noticed was about the next to the last day that the thread coupling between the sensor line, sensor harness, and the belt, the little transducer in the belt.
Yeah, on top of the signal conditioner.
Yeah, it stripped the threads. I could get it to hold a little bit, and apparently the signal was fine, then it would slip off.
It came back beautifully when you tightened it.
But then when I unsuited it at the end, I noticed that was loose, so the threads apparently stripped on that. Apparently I got it cranked down too hard.
Did you routinely disconnect that connector at the signal conditioner for sleep or for bowel movements
Not
or
for
anything
sleep,
like that?
for bowel movements and for swabbing down, cleaning out process. Yeah.
Anytime you pulled your clothes off, to either change clothes or put on the LCG or use the blue bags, what have you, we all have been doing that.
Okay. And then you didn't replace anything. You didn't have to reseat any sensor after that. That was the only other thing you had was the
That was
signal.
the only time I took a sensor off.
Was that first
And
time?
that call was correct because when you took it off, you could see the seepage of the electrolyte.
Right.
Same with the.
Okay. How about yours then, Ed?
The only thing I replaced was that one sensor.
Which one was it?
And it was
Did you
the
replace
same.
the whole sensor?
I don't mean replace the sensor. We pulled it off, cleaned it out, refilled it with electrolyte, put it back on. It was the same.
Just the same outlet.
Put a new donut, new sticky donut.
Okay, you did not take the harness out of the kit and replace the whole harness. Okay, because we thought you had done that, and
Well, you called and asked me that, but there wasn't time to do it, so we
I'm
took.
glad you couldn't hear what we said when you guys said that.
We took the chance that the real problem was simply the sensor and the electrolyte, and that's what it was.
That's exactly what it
We
was.
couldn't have picked the worst time from the standpoint of timeline.
Is that right?
We were just getting ready to go into the lab, you know, and boy, everybody's all asses and elbows and suits and underwear and gear and books and everything all over the place.
And I was sitting there half dressed. I didn't want to go any further till we got a go on it. We couldn't get the high bit rate up for you guys to look at it.
Right.
And so
I remember
there just
that.
wasn't any time left, so we changed that when I went ahead and dressed.
Hey Ed, you know when you came up there though, the data, you gave us about 2 minutes when the high gain did lock on, and we got 2 minutes of data, and it still showed the loose sensor. Now, what did you do the second time? You came up, asked us how the data looked, and we said it looked poor yet, and we gave you no go on the suiting to change out the harness.
I don't recall exactly the sequence of events. When I called and asked for you to check it, as far as I know, we did nothing after that except make sure everything was cinched down and went ahead and dressed.
Didn't you do something with the fluid in there?
Yeah, but I had already done it at that point. We did I changed the electrolyte. When I called and asked you guys to check it, I did nothing after that except just make sure everything was secure.
Yeah, because you see, the first time you called, the data was poor, and that was the basis for the call to change out the whole harness, because we said, well, it wasn't that sensor, and we didn't have time to talk to you because LOS was coming up, so we said, go ahead and change out the whole thing. But whatever you did, they subsequently corrected it because it came back beautifully, so we assumed you would just change out the whole harness.
Sprinkle a little holy water on it.
Yeah.
Ziggy, now that you mention it, you know, I just can't remember precisely when we changed it, but I'm thinking that it was already changed at that point.
Okay. Now, Ed, was this the lower sternal?
It was the lower sternal.
Same as Al.
Same as Al's?
It never did change. It was electrolyte that was replaced.
Yeah, what I'm doing is taking it off by taking it off and cleaning it and putting the lid.
Putting it back, just sticking it back. Okay.
And you think you did that before LOS?
Yeah.
He probably did. What we're thinking now happened. Probably took a while for it to seat properly, and when he came around, it was good again. Good.
Well, his stayed good then, and then we were having trouble with yours going in. You began to get this wandery baseline on yours again before after we got into the limit. So there was a question in our minds about it. Is there any way we could do to get that better? To make that better. And we were trying to figure some way. Could you reach around when you were in the suit? Is there any way you could get at that thing if you took, like, after the EVA, if you ended up taking the helmet off? Could you get down into the suit here?
You really have to have the upper torso garment, the upper part of the torso garment clear of the body in order to be able to feel that.
In order to feel
There's no way you can definitely tell, even if the other guy goes through the back zipper and around in front.
We tried that on the ground to see if you could do that, and that's pretty hard to do, we found out.
The most you can do is press.
And after all that time quarantine, that's pretty dangerous too.
Yeah. Depends on where his hands is up.
Yeah.
Okay. All right.
Forget the EVA. Just keep fooling with my sensor.
You've got 2 hours to stop that.
Okay. The thing we got from the sleep, and which I think is fairly well covered. If you have anything to add to that, we'd like you to. But what we got out of it is that all of you pretty well never really had a solid long sleep period. That it was broken, and it was things like a couple of hours at a time or something. And I gather that the reasons for that varied. You had some difficulty with wanting to feel some pressure. In Ed's case, I know, and Al mentioned this too, and Stu didn't like the couch, and then you ended up in the limb. The thing was being in the suits all the time, and then the tilt of the limb too. Both those things probably had a lot to do with sleep activity. Is there anything else that you think you can add? Did you feel that you were rested enough to do the task even with the sleep that you had?
Yeah, but I think we were working on reserves.
Yeah, I do too.
Well, there were 2 days that we felt sloppy. One was the second day out after the excitement of the launch and all that activity and becoming acclimated to the new environment. So we felt like we weren't really clicking along too well on the second day out. And then the day after TEI, although we all apparently slept better after TEI that night, I guess was probably in terms of continuous sleep was probably the best night that we had. Still, the next day we felt like we were not really organized. We got things done, but the little things were not being handled as neatly as we would like to see them. So these are the only 2 days we felt that we were on top of the flight plan.
I think, Chuck, I feel that for no longer than we worked for 9 days, that you can get along on a fairly small amount of sleep, and just your reserves and your discipline and everything else makes you do the job properly. But in my case, I felt very strongly that I was on reserves, that physically I was going downhill, and it was of some concern to me that I wasn't getting enough sleep. I knew I wasn't getting enough sleep, and yet I felt fairly wide awake and alert on most of the days, except the 2 days Al was talking about. But sleeping to me was a very insecure experience.
Now, how do you mean insecure? You mean because of this wanting something?
Yeah, wanting to feel like you, the best I can say, feel like you were in a bed.
Yeah.
Wanting to feel some pressure or to be lying on something. It was a pleasant.
Could you turn the tape recorder on?
I knew we'd get back to that. It was really a pleasant experience to be in 0G during the daytime, I thought. It wasn't quite so pleasant an experience at night.
Well, did you feel, that brings up this thing, did you feel, I gather from Al's comments in particular, this business of using your legs and your feet to try and hang on to something, which has been described by other guys too at some length. Did you have a feeling that was the cause of this muscle business in your back more than, because that's been described and they've never been able to really put a handle on why they felt they had that. They've had this sort of a feeling that if they could just stretch that real good, it'd be great. You think it is due to the fact that you were trying to lock onto something?
Yeah, Yeah, as soon as, that's what I analyzed it after the first couple of days. I think we discussed it, as a matter of fact. And so we started exercising and then deliberately take time out to relax, not only during the sleep period, but also try to adapt ourselves to a relaxed state during the awake periods in the seats or on the optics or in the tunnel or something. And after the second day, it kind of went away.
Yeah, that small of the back problem was gone after a couple of days.
Yeah.
And in fact, I was kind of surprised at that. Woke up that first morning, and my back had bothered me during the night. And I didn't realize that Al and Ed's back was bothering them at that time too, you know. And I said, you know, I really didn't get that much sleep, but this sounds crazy as all hell, because I can lay on that big fine king-size bed at the house, and if I get a lot of sleep, you know, if I lay there for say 10 or 11 hours, why the small of my back bothers me.
Sure.
And I said to these guys, I said, hey, this is crazy. I didn't sleep that much last night, but my back feels just like I'd got about 11 hours sleep. And they said, well, mine does too. And then, you know, then we got to talking about it. And but it was there, and it was very conscious to me that first night. In fact, I thought probably my back kept me from going to sleep as much as the new environment. Yeah. Rather than the 0G, because I was always conscious of my back bothering me.
Did you ever think about taking aspirin or anything to do anything with that? Did you?
I never take aspirin at all.
For the 8 thing?
I think until the time we discussed it, I was convinced that the reason I was feeling bad in the back was just not urinating for so damn long during that hole.
I wondered if you wouldn't think that. Yeah.
I did think that.
Yeah.
And then after we started discussing it, I said, well, that may not be the problem, or if so, that's just part of the problem.
Everybody's got it.
Everybody's got it.
Yeah.
And I agree with Al that it has something to do with the way you try to use your feet to stabilize yourself. And I believe, although I couldn't see myself, I believe that when I was relaxing in the spacecraft in 0G, I was in a curved position. And it felt good to throw the shoulders back and straighten out, or to take the exergem and get some tension on those back muscles.
Well, you tend to assume it's sort of like a fetal position. If you just totally relax, your legs will tend to float up and come up in a sort of a semi-seated position, and your hands would tend to float out about like this, and your back tends to bend some, so it tends to assume that kind of a position. If you just let all your muscles go, so you don't have any muscle pulled on.
Oh, I tell you that one of the good things for that back too is just exactly that position. Just get yourself up like this.
That's right.
And I know that first night when my back was bothering me, I tried to sleep a good bit. I'd reach down and grab a hold of my booties, and I would lay there like that with pulling some pressure on my legs, and it would really help that small of your back.
I found both things, either straighten it out to put some tension on the back muscles, or as Stu says, double on up and pull the other way.
How about when you got back onto the carrier now, and you got into a bed then for the first time back in a 1G environment? Did you have any feeling? Did you have the feeling that you were real heavy, that you were sinking into the bed? Did you have that when you were on a table or anything, on the X-ray table or anything of that sort? None of you experienced that. How about weight of clothes? Did you have a feeling that your pants were too heavy, or they were falling, or anything like that when you first got back?
Only thing I can remember about laying down on the bunk was it was a good relief to be able to lay on your stomach. You know, I generally, I don't know which way I sleep most, back or stomach or what, but you know, you always had the impression, no matter in what position you are in the spacecraft, you're on your back. And so I remember thinking of that. The first thing I laid down in the bunk was I stretched out on my back, and I thought, gee, I've been this way for 9 days. I think I'll turn over. So I rolled over on my stomach. It felt pretty good.
Okay, did any of you have any dreams at all? Did you ever dream in flight at all?
I did, but I couldn't for the life of me recall.
Well, that doesn't matter.
Yeah, I had dreams.
But you did have dream activity, at least, in the
yeah.
Surgery's thing. Good. Okay.
Yeah, I think of that heavy feeling, Chuck. The only time I noticed it was after we had landed. We were still in the spacecraft. We unstrapped, and the spacecraft was bobbing around a little bit, but not too much. Got down the LEB right away, and the first couple of steps, combination of the rocking the spacecraft and being in 1G again, for perhaps, I don't know, 30 seconds. No more than that, certainly.
That was my experience too.
And I started doing some deep bends right away for, maybe 10, 12 of those babies. And I was right back at home again and continued to feel that way. No muscle soreness, no feeling of heaviness or anything from there on out.
Did you, this feeling that you experienced when you first went down the LAB, was that all over, or was that just heaviness in the legs, or did you just feel heavy all over for a few seconds?
Heavy all over.
Just all over. How about when you first got some G on reentry? Did you have a sensation that you had a lot more G than you're really registering? Did you go through that?
I don't remember anything over 2G. Was I supposed to?
Of course, these two guys were.
You don't, huh?
He's like that.
No,
everybody else is done.
No, I think you become very sensitive to G, like even ullage on in the spacecraft, or well, that'd be just the only time you'd really feel a G would be the ullage, as well as the SPS engine, of course, But on entry, certainly, as you're going through 1G, it certainly doesn't seem like 1G. You're sensitive to the G.
Since I wasn't quite as busy during that initial period as they were, I didn't have tracking tasks to keep me occupied. I probably felt it more, or was conscious of it more than they were, and it felt to me like one hell of a load. In particular, my one task was to be watching the time, and I couldn't get my arm up to see the watch it until after peak G let off. And then about 4 or 5G, I pulled my arm up and take a look at it. And I had the same sensation that Al did. Right after I got out of the couch, I felt very, very heavy. And then with just a little bit of motion, it seemed to go away. And I'd say it kind of described a very sharp rise. The return to normal was a very sharp rise, and then an asymptotic to 1G, because I still stumbled a couple of times getting out of the helicopter. But I felt fine, except I just didn't have the sureness of footing that I would like to have.
But that didn't last as far as footing. That's an interesting thing that the Russians had after their 18-day flight. They had some real marked mobility problems that lasted for days, and you didn't have. We've never had anything of that degree. We've always had some initial footing problem. Just getting used to being back in the 1G environment, and then you're on a ship too, which is moving around, and this didn't last for any of you for longer than a few minutes. Really getting out of the
I
helicopter.
never felt lightheaded at all.
No, neither did I lightheaded.
How about putting your feet in the right place? Did you feel like when you were walking that you were walking normally that your steps were normal and everything? That you didn't have to worry about where your feet were?
No, I think that up to the point we got in the MQF, I felt that I took a little care to make sure my foot was going where it was supposed to be going. But it wasn't out of the ordinary, really severe or anything.
No.
It seemed to be improving very rapidly from a very heavy state for the first 30 to 45 seconds after I got out of the couch to within an hour or so after I was in the MQF, the footing was very sure. But I do remember stumbling once going into the MQF from the helicopter, and I didn't see anything to stumble over. I stumbled.
I think you do that right now, though. If you're going to walk out of that door with a television camera on you, and you're going to walk up to the front steps, you'd be more conscious of your footing.
Exactly what I was thinking.
You'd be more conscious of your footing, whether or not you'd been in 0G or not.
Sure, if you're carrying a load, you're going to look very carefully where you're sitting. You don't want to not get knocked down.
Yeah, and you in particular know that you've just come back from a flight, and people are going to be watching how you're walking and all of this stuff. So it's in your mind, and you've got to walk this 30 feet to the MQF. So just naturally, you're more conscious of where you're going to put your.
Well, I may have psyched myself into stumbling for that reason, but nevertheless I did stumble. In spite of the fact that I was conscious of the fact that TV cameras were on.
Okay. Did you notice any distortion of your facial features at all? When you look at the TV, the in-flight TV, as we watched you, when inside the spacecraft, you get the impression that your faces are not like they are now, that they're much rounder, that's a thing that you see on the TV. Is that true? Did you feel that when you were looking at each other?
No, but I observed that when I saw a picture of us taken from that TV, and I didn't think anything about it until you mentioned it.
You look quite round. You look much different than you do now. It's very rounded, but you weren't aware of that looking at each other.
You know, Al Bean has made a comment of that in the 12 report, that after he got into orbit, he looked around and everybody looked 20 pounds heavier, and I remembered that, and I looked at these guys, you know, they look just as bad then as they do now. I had remembered that comment from Al Bean's report, and I really didn't notice it.
Yeah, the 12 crew, I guess, been the one that was the most impressed with that of anybody, and they noted that they felt even that they had redness of the face for several hours after they first achieved orbit.
Well, there's a general feeling of fullness, I think.
Yeah.
But I mean, just to look at a person and see his face puffed up, I didn't notice that at all. Maybe it was just lack of observation, but
or maybe for the first 5 hours we were too busy doing other things. Observe that.
Did you have any sensation that in the first 24 hours in flight that you urinated more than you normally would, than you did the rest of the flight time?
I don't know.
That's a hard thing to remember, but do you have any idea that you did that at all?
I went 7 hours without it all. I never used my UCTA.
That first one was a whopper, I know that.
Of course, you got a lot of excitement to make it a whopper anyway, so it's hard to... No real...
No feeling one way or the other on that.
Okay. Can you comment on the work that you did EVA out on the lunar surface as far as what you felt based versus your ground training? Did you think it was harder, easier, or about the same? And secondly, as a second question to that, did either of you feel really physically tired to the point that you knew that you were really tired during the EVAs, even going up Cone?
I felt, of course, it was an order of magnitude easier than 1G training. Just no comparison at all, as we expected it to be. And as far as being tired, I think I had already made up my mind that I did not want to sweat on the moon. That I was going to keep the water up and I was going to keep rested enough so that I didn't sweat for consumables and for fatigue purposes. So I never really felt tired. I did feel occasionally that I was approaching the point where I'd have to have more cooling or take a break. But it wasn't because of a tired feeling, it was the desire to program and plan consumables the way we wanted to.
And not be high. Okay.
So I felt in my mind that I was stopping short of the point of fatigue as a direct plan of not wanting to use up consumables.
How about you, Al?
Well, it's kind of hard to equate the pre-flight stuff with flight stuff. First place, you're not using the LCG in the pre-flight stuff, and you're lifting essentially 1G pieces of equipment around and so on. So it's pretty hard to equate the two in my mind as to whether it was harder or easier in flight from the standpoint of the total work output. But certainly, standpoint of ease of mobility and so on, as Ed says, it's a lot easier to get around. I think you travel a lot faster, easier on the lunar surface as a general comment to start off. EVA 1, I did not feel uncomfortable at any time at all. EVA 2, I think the fact that I was aware of the workload was manifested primarily in the respiration rate as opposed to anything else. I didn't feel as though the body heat was going up too much. The deep body heat was going up too much. I think this is primarily because of the circulating fluid in the LCG. And I was not aware of any profuse sweating, just a little faint tinge of sweating, a blush, whatever you want to call it. It was when I went to the medium flow on the water. So I think, and of course, you're not really aware of increase in heart rate either, unless you specifically stop and measure it somehow.
Right.
So I think to me, the thing that was most obvious about the increased workload was the respiration rate. And at times I think we suggested climbing the steepest grade of the crater that Không, that we stop and take a rest. I think you all suggest that
Right.
as well.
Right.
But from the standpoint of being tired to the degree where we didn't want to press on after a short rest period, no, I didn't feel that at any time until after the 2 days was over, when we were back on the command module. I really felt like I was behind the power curve as far as the total workload was concerned.
Well, we'll try and give you some firm feeling for what happened with your EVAs when we do this later. You know, we can show you actually what you know. You did have some times where you both got heart rates that were up in the 150 area. You and this is why we felt, and your respiratory rates were very audible. And we didn't have a respiration trace on you at that time, as you know, but you did have very audible respiratory rates, and it was obvious that you were increasing those. And Al, I think you began to store. I think the thing is you kept yours on men for a long time, and then when you did turn up to medium flow, you just left it there a short period of time, and it didn't kick your rate down as much because you still were maintaining some of that heat in there. Now, it wasn't enough to make you sweat up here. And then when you started doing that, turning it on a little bit longer, each time it just settled right back down. You didn't have any trouble with it at all like that. But both of you came down very well. When you would rest, your rates dropped down. And that's contrary to what happened on 12, where they didn't drop down when they rested. And yours did very well. They just dropped. They come right on down as soon as you stop doing the activity. So that do you have a feeling that you could have, you have a feeling, any recommendations about extending EVAs now? I mean, do you feel that it would be possible with proper consumables, of course, that you could, that it's physically possible to do that?
I sure do. The thing that bothered me was the worrying about consumables. Knowing that we were getting a higher metabolic load, a higher heart rate, more oxygen consumption going up Cone Crater, and that I was spending more time on between minimum and intermediate cooling because we were deliberately rushing to try to make up time. I started worrying about consumables, and especially in the water and the oxygen. And I felt that was a limiting factor. I didn't feel that I was the limiting factor.
Yeah.
Just the oxygen and the water I was consuming were bothering me.
Well, we tried to give you the word that, you know, that you were pretty fat on consumables really at the time. We thought you were trying to save consumables, obviously.
Yeah, we were.
Yeah, and understandably so. And so we wanted you to know that you had enough and you could go to medium flow without really getting yourself in a hole was the thing we wanted you to know.
And after you did that, I spent considerably more time on between minimum and intermediate.
Yeah, we did. Yeah, right. So did Al. Yeah, you both did.
Incidentally,
I think that the comment is, would like to comment about total workload with respect to the 2-day period. I wouldn't want to see a crew ever plan to do any more than we did in those 2 days.
Oh, amen.
As far as I'm concerned, that's about as heavy a workload as anybody ought to do. And certainly, if you're going to go out for longer periods of EVA, you ought to allow longer periods of resting.
Amen.
And make sure somehow that they get the rest.
Yeah.
Just allowing the time doesn't necessarily assure rest.
Well, tell me, if you had, you know, in the limb, I gather one of the things that you think would help, of course, would be getting out of a suit. That certainly would help if you could get out of a suit in the limb. No question about that. If you had something for sleep, would you take it? Would you guys have taken it in the limb if you had something for sleep? Do you think?
I don't think so, because I don't know about Ed, but I certainly don't take that kind of medication here in the ground.
It's an individual thing, quite obviously, and it just depends on.
Try to do things as closely in space as you can to the ground environment is probably the way everybody would.
Right.
So if you have people that do that in the ground, probably would help them.
I prefer to see us using more natural means of getting to sleep as opposed to an artificial means.
You'd like to have something to sleep on, what you say.
Back to that again.
I think the suit's a big thing, as far as I was concerned.
Yeah.
It keeps coming up.
Couldn't roll around. You couldn't roll around in a hammock and the damn neck ring was in the back of the neck.
Yeah.
There was one thing, Chuck, about fatigue. The only thing that I felt fatigue, any muscle that I felt fatigue, was a darn hand muscle in the right hand because of that glove.
Because you were fighting that glove.
Yeah. And working the core tubes unscrewing the core tubes. One of them I couldn't get by myself. Getting the caps off of them, that was very fatiguing, and that arm gave out.
How about when you're carrying the barbell out there and you're getting this thing? You said you had to do it like
Well, that was tiring, just because it's so cumbersome and it was flopping all around. But I eventually put it across my arms like that, and just aside from the workload of carrying it out, it was no problem. It was heavy.
Was the weight seem different? Because you commented at the time, and it looked like you were having trouble getting out there with that thing. Was it the weight of it, or was it just the fact that it was vibrating, that it was sort of like a fishing rod?
It was mostly the vibration of it, just the flopping of it.
Flopping up and down.
However, I think that it was heavier than I expected from the 1.6G mock-up. But we had never carried it that far in training, and I think we've made that recommendation that at least once the guys ought to carry it
the whole way.
The whole way. But it was primarily the flopping of those weights on the end that were giving me trouble.
Okay. Let's get I gather that on this bowel movement thing that the preps and so forth, you had a good comment in there that went fairly well. You all did the same thing we knew pre-flight anyway. How did it work out though? And the thing, do you remember? Can you just tell us each one how you went? I gather Ed went almost to the end without having one, according to a comment. Where did you go? When did
he didn't.
I went to the morning of the 8th day.
To the morning of the 8th day was the first one.
Okay.
And that's the only one, I assume.
Yeah. I didn't plan it that way. What I wanted to do was to have one bowel movement before we went to the surface.
Yeah, I remember.
So that would take care of that period of time. And I went around with a bag on my fanny for about 12 hours, hoping I could do something, and never did. And at one point, I even wished that we had a laxative aboard to help me do that. I'm not sure whether that's a good idea or not, but it sure seemed like it at the time. And I was really concerned that I need to have a bowel movement while we're on the surface. And I got through that period, figured, well, we got it made. Be good to get back to the command module and use the bag, and I still couldn't. And it was still the 8th day, and that was a whopper.
Did you ever get any cramps or anything with it?
No
you
cramps.
Never had any gut
Nothing.
Disturbance at all with it? Fine. Okay.
I wasn't uncomfortable. I didn't even have a feeling of fullness.
Yeah, good. How about you, Al? How did your cycle go?
Well, I had 1.5 bags on the 3rd day, I believe it was. And then another bag on about the 7th day. Sorry.
And no problems. I mean, there were normal consistency and sort of as far as.
But that's really uncivilized.
That I agree with you.
We gotta find a better method.
The total hygiene thing in this thing is so archaic. It's unbelievable. I mean, we just got to do better than that if we're going to keep people in space. That's
really
all.
the only time you didn't feel civilized. You know?
Yeah.
You really felt uncivilized during that whole process.
The whole mess. Yeah, as a big mess.
And the ability to clean up afterwards. And the fact is, the ability to maintain personal hygiene throughout the flight.
Totally.
We need better equipment.
Stu, how about you?
I went to 80 hours was the first one. I remember distinctly because I said between 80 and 81 hours approaching LOI while I'm going to do it. And
you did.
Which pleasantly surprised me too while we're on the gory subject, because pre-flight I anticipated that I might have to use the bag more than that, because in my normal course of events it's very common for me to hit the head at least twice a day. And but so I was pleasantly surprised that I got to 80 hours. And then I had one other one, and it was after TEI. I guess the next day after TEI, and I don't remember what time frame it was. Or was it? Yeah, I guess it was. It was the day after TEI, and. Okay, I don't remember the GET or anything, and I can't even associate it with anything except these guys in their gas masks. I don't know what else was going on at that time.
Yeah, these guys. when did you first start to use the nose drops? How far into the, do you remember what day?
Third day, wasn't it?
3, I think.
Third day.
And do you feel that that was a, I'm a little bit confused about you're describing this fullness, and still, do you feel that this was a thing that was associated with this fullness that was due to the weightlessness, or do you think it was an oxygen effect, just due to the drying and so forth? And
I never felt that dry. And at the time I thought it could have been either or both. And so I just treated it symptomatically with about 1 drop in each nostril, and it was completely effective for the next 10, 12 hours.
well, you could hear it. This is fairly routine. You hear this in the guys' voices, and you know they're doing it. You know, you hear this full feeling that they have. Sometimes they get a little bit of hoarse sensation with it too, and it comes and goes. And you described it, I thought, very well yesterday. You know, sometimes in the mornings you'd wake up and it'd be better in the morning.
You know,
well,
Chuck,
I don't know. This is kind of a subjective feeling. Kind of felt that maybe the whole full head sensation was related to a readjustment of the whole cardiovascular system, and therefore,
It is.
if you could relax a little bit in the evening, it ought to help it. This is my theory.
Yeah.
Maybe you kind of wished it that way. It's just a general feeling. Nothing to substantiate quantitatively. And I think as far as the nose drops are concerned, it helped with the mucus, but it didn't help the overall fullness sensation.
Did they work all right? I know we got a special one with Stu here, but did they work all right? I mean, did the
Just like
drop?
it should have.
Yeah,
Like
so
I
it clear out
expected
the, made it clear out the mucus temporarily a few hours.
Yeah. Okay. And Stu, what about now? Did you just give yourself too big a slug? Is that what happened to it, or?
I think I probably did, Chuck. I'm sure that's what happened. You know, I said, well, I hadn't used any up to land, but on entry, you know, and I thought, well, I think I'll just use some of these beauties. And I think I gave me too big a dose in the right nostril here, because boy, my eyes started watering, and I could feel it in my sinuses and everything else. And but it lasted maybe an hour, and by the time, I guess I probably did that a couple, 3 hours prior to entry, and an hour later, you know, I think most of the symptoms have gone away. Either that or you're getting closer to entry and you stop worrying about it. But yeah, I did. I think I overdid it. And I just, you know, I hardly ever take any nose drops or anything, and maybe I just got too much in there. It's probably pretty powerful stuff.
it is powerful. I know in 1G or here, if I take more than a couple of drops of Afrin, if I use drops instead of spray, I get the same effect as Stu does.
Yeah. No, that's not
It's a burning and a real drying sensation.
And it wasn't a lack of briefing or not trying it before flight or anything like that. I think I was just a little overzealous in the application.
Well, you know,
2 drops are good. Give it 4.
Yeah, you know, what the hell.
Did you feel that you got any? Did you get a tachycardia with that? Did you get a real increase in heart rate with that?
Oh, I don't have the foggiest idea.
You didn't feel it anyway.
Yeah.
Gee,
Y'all had the.
He pumped a little more adrenaline. He got mad at us for suggesting that we usually use the gun.
Yeah, I was teed off at the suggestion.
Did any? You all had some evidence in your ears on the first exam when Bill saw you of having some bubbles in there. And did you have any sensation during re-entry that you were having trouble clearing your ears? Any of you? No sensation.
It's surprising to me. I was looking for it. And surprisingly, I had no problems at all.
Not a bit.
I could feel the pressure change, but I could hear them pop. But you know, I did that too on my suit integrity check. I could feel the pressure.
Yeah.
You know, and you just sort of pop it. And I'd like to make a comment before I forget about this voice sounding full. You know, I noticed that you'll do that a lot if you. I think maybe it's because the atmosphere is dry, but if you're doing a lot of talking, and then you come on, and I would notice myself sounding full, and I say, gee, I'm sounding like that, and my head wasn't consciously full at all, but I could tell in my voice that I was sounding.
Hear it in your voice.
If you've been doing a lot of talking.
Right. Well, that's true. If you do, you know, like if you end up just talking all the time, like if you end up here like in a session yesterday where you talked a lot during the DV, you may even have that kind of thing. If you just talk a lot during the day, you can have it.
We don't have too much else to do in here, Charles.
Yeah, I know.
Now we're back to that.
Hey, Chuck, comment on those
We're looking for somebody to cut a glove. Who is it? Maybe that's going to happen, Bill.
comment on the aspirin bottle. They, the pressure gets to them and they separate into a jillion bubbles. And that emulsion is very bubbly and filled with air. As soon as you take the cap off, it comes out, starts leaking.
It's a little knowledge in the bottle.
Yeah.
Okay.
And it's kind of difficult to control that stuff when you use it.
That was the first time you opened the bottle or after?
Always, always.
Every time you open it. Okay, Francis, what technique did you use for applying the nose drops? How did you put them in?
Very gentle squeeze, trying to get just one drop at a time out.
Just put the dropper up.
Put it in there and hosed it.
Just like we told him to.
Yeah.
Good boy, Red.
What did you tape those PRDs down in your suits?
Tape them?
You'll never believe it, Charles. We had zipper pockets.
You're kidding!
It's unbelievable.
They were there.
We pulled out those coveralls and there were zippers on them.
First time we'd seen zippers in the whole training cycle.
I'll be
Well, so they're not on the training suits. They're just on the flight suits.
Just on
Is that
flight.
it? Okay.
Well, how about that? Okay. What do you know?
We had requested it way back and forgotten about that we'd made the official request and it was already in the mail and nobody knew about it. And none of the training devices were that way, but lo and behold, out of the package they came and there it was.
There they were. Well, that's great.
They were great too. Really nice.
Okay. Well, I don't understand where that is.
Well, when you remove your PGAs, Al, is there a point in the checklist where we should include the removal of the PRDs back into your flight coveralls, or is that not there?
It already says take all the items out of here.
Oh, it does? Okay.
Yeah, if that happens to be one that's by itself,
I see.
and if you forget that extra pocket's there, you forget it.
Well, now it's listed in there when we take the suits off the first day. I guess, and then when you bring the suits back over from the limb, a pretty rushed timeline, that it wouldn't, I don't know whether it'd be any good to put that in your timeline book or not, because at that time your main purpose is just get the suits and get them stowed.
Yeah, you said you jerked them down and got them zipped up in those bags pretty fast.
Right into the bag.
Okay.
Probably wouldn't hurt, I guess, when we list the items to take out of the suits. When we come back to the limb, we can just add PRDs in there as another item. We list sunglasses and pencils and all the rest of that.
That's what.
Sunglasses remind me. When you said you used sunglasses, you're the only one who did use some sunglasses.
Corrective lenses.
Is that right?
I used prescription lenses.
Corrective lenses.
Oh, okay. When did you use the corrective lens?
A couple times when I had to read small print in the flight plan thing.
In the command module deal.
Yeah, with the helmet off all the time. I didn't use them all the time.
No, I didn't.
I'd use it from time to time in the simulators, particularly in the LMS. The only time when I can't adapt is in low light levels.
Yeah. Did you have any feeling about that on the lunar surface, Al, that the light levels were bothersome to you because of that? Because that is a very typical thing. That's an interesting
The
point.
light levels were generally higher in the lunar module. The thing that you don't simulate on the LMS is the difference between day and night on the sun and moon.
How about out
The
on the
LMS
surface?
is dark all the time for all practical purposes.
How about out on the surface, when you were actually out on the surface and had your visor down?
Yeah.
Did those light levels bother you at all? I mean, did you feel that you were having any difficulties in
The only problems I have is with reading small print at close distances when the light level is low. And I had the problem in the LMS. A couple times in the CMS and the LMS, I don't know how many times I broke them out, but I don't know, perhaps 6 or 8 times.
Try to read that damn card. about the only time I've ever seen you use them.
Yeah, but on the surface, Chuck, it's either stark white, dazzling white, or it's absolutely black.
Or it's black.
I don't think eyesight has a great deal to do with it at that point.
Yeah, that's right.
I think you've covered most of that stuff about the vision on the surface and so forth pretty well in there. I think you've done that very well in the thing, so I don't think we need to, if we have something that comes back up for that, well, we'll get the word to you, but as far as I can tell from getting through all that so far, I think we've got most of that covered pretty well.
I might point out to you, if you want to pursue the visibility further for any sort of medical things, if you look at the photographs, in my opinion, they're exactly what we saw.
Is that right?
If you look cross sun, the visibility is great. If you look up sun, everything's glared out by the sun. If you look down sun, all of the gentle, subtle rolling and subdued craters, they just disappear on you.
Yeah.
But cross sun visibility is great. The photographs show it the same way.
You know, just real briefly on that same subject, it's kind of hard to tell when you're looking at just negatives of these 70 millimeters, but I was looking at some of the zero phase pictures last night and how the targets would disappear at zero phase. It does it on the films also. And
same way.
As it turned out, I'll have to get, see what the prints look like. But my first impression is that I didn't see much more than what the camera did at zero phase, which is going to surprise me because I would have thought different.
Yeah.
But I don't take that as any sort of data until I've had a chance to really see a blown up print. I'm just looking at some negatives in here. But that's my first impression.
We've always said that the eyeball can see more than the film can, but with our particular film, I think they're pretty good correspondence.
Probably going to be about the same. That's great.
You're insinuating we have bad eyeballs.
No, we just have good film.
That's a preliminary opinion.
Hey, on the sunglasses, I guess you got it. As far as I know, nobody even broke their sunglasses out.
Right. And you didn't feel you needed them?
No.
Right.
Well, I think the only time we needed them was when there was sun shafting in, but in PTC, just wait a couple of minutes, it'll be gone.
It goes away. Okay. Ed, there was a time at 196 hours where we lost your respiratory, so your CPN. Did you notice whether was the signal conditioner disconnected then, or was there a sensor loose or anything?
No, there was nothing different. It just quit apparently.
It just quit. You couldn't see anything obvious as to why.
No, I went down and went over the whole system. We checked the sensors, checked the belt, checked the connection, and we were getting too close to entry to really do a great deal of troubleshooting. So.
There was no point to do it then. Okay, fine. Well, we're going to check those things. We never had a signal conditioner as such fail, and that's one of the things that's sort of interesting. If it wasn't a sensor problem, we want to be sure and check those signal conditioners out. Okay, I think we've got most of this mobility thing done in there.
While we're talking about that biomed belt, let me just say that I think my urine bag problem, the UCTA problem, is kind of related to that belt in that, the UCTA is held by that elastic strap.
Right.
And I think the problem in getting that hose length correct has to do with the fact that the UCTA doesn't always end up in the same place. You try to get it below the belt so that it doesn't get on top of it and increase the dimension any more than you've already done. And I think in doing that, I probably wore it a little more, wore the gun down the hip more maybe.
Yeah.
In retrospect, if there's some way that thing could be fixed, just
in place,
fixed, then it wouldn't move up and down, and therefore you can adjust the hose length a little better.
I wore mine differently. I wore mine over the bio belt. That may be the difference.
Yeah. Well, I think it's a question of fixing the vertical height of that thing, so you can get the right length of the hose. Because mine was up and down. I think when you reached in, you probably found it was sagging down as a result of being full of fluid on the one hand, but also because I used to wear it below the belt on the other.
Yeah.
But his hose had a definite kink in it. It came out of the fitting and just made a sharp kink, and it was bent, just like you see the hose.
Yeah. Very good. Did you feel any real dryness of skin as such, or dryness of your lips or your nose at all? Did you ever have any sensation that way?
Not exceptionally for me.
I actually didn't have any obvious sensation of dryness.
I don't know whether Stu did, I noticed his lips were cracking about the 4th or 5th day after we got back from TEI. But I don't know if you done it or not.
No, I didn't feel dry. In fact, I noticed it cracking in here too. But no, I didn't feel any dryness particularly at all.
Okay. I think we got these all covered. Did they talk to you about the Phil Chapman wanted to tack on the light flash thing on the end of this thing here? Yeah. So once you tell them to come on in and let them get that out of the way then.
Hey Chuck, just real fast I know you've got to take the data and you're looking ahead to the longer flights, and I'm not trying to downplay it, but this weight loss, I think in my case, I don't want it to be misconstrued. I was just sitting here thinking, I weighed less after our field trip to Iceland than I did after this flight too. A weight loss of me of 5 pounds is no, just comes and goes with no problem at all.
Well, that's why the body water things are going to be pretty important. To know is that really it? Is it really a total body water loss kind of thing? That'll be a real important plug to hang on there. That's why we'll go over that with you so that it is clear.
Mm-hmm. We won't have total body water or extracellular fluid space until after quarantine. That will be done in beta. Those are beta emitters. We're just doing the gamma counting in here.
Why can't we get it out? We'll argue that with you.
We're just not equipped.
Let's get it out. I'll talk with you later. There's a scientist. Let's go. Where's Bill? Yeah, there he is. Bill, go out.
Hey, y'all want any coffee? I got a big pot right here.
Yeah, I'm coming over to get some right now.
Dick suggested that we should tack on a few questions about light flashes at the end of this briefing. That's what we're about to do. What we'd like to do is to clarify some of the subjective impressions that you got of what you saw in the way of light flashes, and also to clarify the conditions under which you saw them.
Excuse me, could you stand back from the mic just a little bit? That's a boom mic.
Bill,
and that's
why don't you sit right here? It'll pick it up.
Okay. Really blast us out.
Let's go. You need to get reasonably close to the mic. You should be right from the mic.
Is there a way that the room could be darkened?
That the room could be darkened?
Yeah.
In a while.
You know what? Okay.
The first question we got is the streaks that you saw. Were they a very sharp phenomenon, or were they rather diffuse, like fuzzy?
Ones I saw were very sharp. There was no mistaking what it was. It was a streak so long, instantaneously disappeared.
Yeah, I think that's correct. Both the single streak and the double shot appeared to be very clear to me.
They were quite clear, and I think I made the comment over the loop that most of my streaks appeared to be on the periphery. And for the first several days, I got the impression that this direction was predominant. Later on, it appeared that I don't think I could get that good a pattern, but that was my first impression for the first couple of days.
The next question is, was there any apparent direction of propagation? And could you tell it was coming from one side to the other, or was it just a flash?
Several times you did say from the left to the right or something like that.
Tried to correlate it, but in my case, I couldn't really correlate a pattern out of it.
Yeah, I would think that the time period in which we tried to report them streak by streak, flash by flash, was representative. And it was my feeling that it was generally random during that time period, and therefore generally random throughout the times that we were noticing them.
No, I meant, could you detect that it was moving from one side to the other in general? It was moving in a
specific
flash. A specific flash, yes.
But you could see it as a travel from one side to the other? You really
I think we tried to report it that way, didn't we?
Yes, you did report it.
That's the way
That's
the
what's
question-
puzzling us because it happens. It has to be very fast, you know.
Isn't that question kind of redundant then?
I don't believe you.
Was there some character to these flashes that had some aspect of direction? I mean, were they all the same rod shaped, or did they have a tail on them?
Well, what I saw, what I reported as a streak was simply that. Now, maybe the way we determined the direction subconsciously was that it was a ball of light moving in a direction, leaving a tail. But I can't say that for sure. All I reported was a streak, and I had the impression of it moving from one direction to the other. And I reported that direction, and I can't clarify it much more than that.
Maybe while you're asking a question, if we just douse the lights, I think they can see this in the dark room. Let's just try it. The idea is to try to see whether this is what you saw or similar to it.
I think you need the lights out there.
Well, can you see anything?
Yeah, except that's what it looked like, except it was traveling. In other words, it started out and it definitely progressed across the field of view.
Direction of motion per individual.
Was it that bright?
Yeah, except you're not traveling. It was traveling.
You saw it as a point that made the street.
I never did see two simultaneously either.
Neither did I.
Now, you have two streaks on that. I never saw that.
At one time you said you saw a semicolon shaped thing.
Saw what?
A semicolon.
We're picking up at 12-0 liftoff rendezvous and docking. And again, where things went nominal, as per the checklist, we're going to get the lunar surface checklist, Jay.
Absolutely.
Okay, we're going to say so. 11 power up. And launch prep went well. We did not do the P-22. And everything else just went as advertised on the limb. She came up and powered up beautifully. Anything in there that's worth going through? Okay, the liftoff was went normal. We got obviously all our pyros, and we lost no changeover Parker valves or anything. The only thing that I would like to mention, let the LNP pick it up here, is that very soon after liftoff, we had apparent loss of comm, a lot of noise in the S-band. It turned out that we were downlinking, but there was something wrong with the uplink. So the CDR watched most of the guidance and could call out in the blind altitudes and goes and what have you as we pitched over and pressed on up. But for about the first 2 or 3 minutes, I think the lunar module pilot had to concern himself with trying to get comm back. Yeah, and again, it was apparently Goddard or Goldstone dropped the uplink, and then when they were getting it back, I was switching on these, and for a while there, it was just completely out of phase. And but they were kind of had a continuous downlink. It was a very inopportune time, I might say, because it happened just right after ignition. I think that's something though that the INCOs are going to be able to clarify, because we certainly can't give you the details. It just there was essentially no comm on all the antennas. We got into they briefed us on a trajectory. We flew into a trajectory that appeared to be nominal. The ag showed us slide out of plane, I believe, and as a result, our tweak at 9 foot per second. It was -4, -9, and +1. We burned out X, Z, Y in that order, and it looked like the ag's out of plane indication was good.
About 7 feet per second, a little over 7 feet.
And it looked like we might have had somewhat a G-sensitive drift in our in our Y accelerometer and the pings, but the tweak, as it turned out, was an excellent tweak because our rendezvous resulted in just as nominal a rendezvous and a nominal trajectory and profile as I guess I've ever been involved with. The drift in that accelerometer did not bother us anywhere else in the tracking or in the rendezvous at all. Rendezvous navigation was followed the checklist. We got radar performed very well. We had auto updates into the AGs. The only thing I might mention here is when it came to making a TPI burn, the residuals in the TPI burn were greater than what I had expected them, and we did not record them because I wanted to get them nulled out just as soon as possible, but they were, and I don't know the tenths, but they were -7 in X, and then they were 4 and 4, and I'm not sure whether they were plus or minus in Y and Z, but they were. The point I'm making is they were larger than I had expected. They were -7 and a 4 point something and a 4 point something. We reduced those to less than 0.2 of a foot per second, and from there on continued to plot right through the mid-courses, right up the pike on a nominal trajectory. Communications after that first lash up, you got any comment about that?
No, the comment was good. A couple comments about the AGs. After about 5 or 10 minutes, well, early in insertion, I always check the accelerometers or the after insertion, and they looked real good, except about 5 or 10 minutes later, and I can't remember exactly. I looked, and I had accumulated a foot or two per foot, maybe a foot and a half per feet per second at X. So Gene went free, and I did a gyro cal, and after that there was no significant accumulation in X. That went very well. I did that without talking to the ground, but I felt I had an understanding with him that was something that we could do without fear. Let me just also mention on the TPI solutions, the AGs had essentially within 2 or 3 feet per second a good TPI solution after 6 marks. The insertion solution was not very good. It was off by a number of feet per second in X and even more in Z. This was your first one, 17 marks, and this was your final.
Didn't change much.
No.
The pings recycle and pings final were
very close, within a couple feet per second in X, they were right.
Yeah. And a pings recycle had, I don't remember exactly the cost for 15 marks. I think I had 17.
And there's more data in the data card book about various ag at certain times marks with the ag solutions.
Okay, the mid-course solutions. First mid-course agreed effectively all systems except AGs out of plane was a little bit high, and the decision was made to burn the onboard ping solution out of the LEM, which was -1.2, +0.4, and +0.3. We continued to track right up the pike. Mid-course 2 came up, and we again compared all the solutions. The AGs out of plane was still a little bit high, and in actually the opposite direction from the pings. We had a slight variation in the CSM solution in Z. I don't know why. It came up with +5.4 feet per second in Z. So we really didn't get a very good correlation between the CSM and the LEM on the second mid-course. But the pings was still performing, the radar was still performing, and based upon our trajectory plot and based upon our following the nominal inertial line of sight rates, we decided to burn the pings, onboard ping solution in the LEM,
and it was minus 0.4, minus 0.7, and minus 1.6, and from there on out we just continued to follow the inertial line of sight angles, and very little tweaking in either in Y or Z, and we just sort of floated right through the braking gates at 1 mile. I think we took about 6 or 7 feet per second off to hit 30. We met all the gates as prescribed, and just came moving very slowly into final station keeping. Went into a formation flight around the CSM, got a good inspection of the spacecraft in the sim bay, the report of which is in a transcript. Everything looked good to us. We eventually maneuvered, the command module maneuvered to the docking attitude. The LEM just took his position, his docking attitude, did his pitch and yaw maneuver, and or gave station keeping control to the command module to pitch and yaw maneuver, and stood by for docking.
Okay, command module pilot, proceeding on with the docking. I think one of the more noticeable differences between this docking and the docking with the S4B is the fact that the ascent stage deadbands a lot more than the S4B did. S4B is steady as a rock, but you could tell we just watched the LEM deadband because it would change attitude, and then you'd try to follow it. And looking on the first attempt coming in, I must have had less than 1/10 of a foot per second, just barely closing on the thing, just taking it nice and easy. Made contact and did not get captured. Okay, as soon as it didn't get captured, when it's obviously you're closing too slow, so backed off, a couple of 3 feet, I guess, something like that. Renulled the rates and initiated the closing rate, and got captured. As soon as we went to capture, both vehicles went to CMC free, and you look around and check the barber poles and whatever, and look back out, and here I had some rates in the CSM, and I'm sure now that the LEM had rates also. You must have had. Right.
Well, we did when as soon as you went free. See, as soon as capture, the LEM went free,
yeah.
And then the CSM trying to null the rates ended up perturbating the LEM and giving us rates.
Mm-hmm. So we finally gave up on that mode. Had the LEM go to attitude hold, and then once you go to attitude hold, then the CSM could null the rates, and we got lined up and attempted the hard docking. No problem. Probe retract came back. This time it didn't sound like it was as much of a ripple fire. It was more of a, and it was a quicker docking, or a quicker hard dock than it was the previous time.
You got any more tape? Okay.
Yeah, we're still going.
Okay, I want to say something about visual sightings during a rendezvous. I was able to, from the LEM, I was able to see the command module when it was sunlit at somewhere around 100 miles, and definitely define that was a command module. After the command module went into darkness, I could not pick up his tracking light until we were well within about 40 miles. I think this transcript have got more an accurate time, but could not pick up the docking light, the rendezvous light, rather from the command module until we were well within 40 miles, and then just a initially very dim, faint flash. I was able to verify on board that the LEM tracking light was working, and I finally figured out how. It was reflecting off the underside of the EVA handrail on the left forward side of the LEM. So I could see the LEM tracking light flashing. And also, when there were some particles we took with us that stayed with the spacecraft, and you could see the sequential flash off of those particles that was a result of our LEM tracking light.
Okay, this is the command module pilot. I've already mentioned in section 11.0 about the visibility of the lunar module through the optics.
I got down here. Let's see.
Anything else to add about
photography and television? A photography on a limb. We'll just have to wait and see how it turned out. I took a lot of footage. Because we put it on not only the Ascent mag, but we put it on another mag. We had part of the mag built. So, and that includes a sim bay. Right along, we did have a Hasselblad on board, so we have a lot of Hasselblad photography, the rendezvous, and some lunar surface stuff in the process of it.
Okay, post-docking check, like we're going to 13.0, lunar module jettison through TEI. Post-docking check and pressurization. Well, first of all, I guess you said you had every latch made this time, right?
Every latch worked on all 12 docking latches worked.
Okay.
That sounds like there's something to do with the mass of the other vehicle involved here.
The general comment I want to make about the post-docking operations is that throughout the rendezvous, both pilots in the LEM kept their helmets on for dust, keep the dust out primarily. The commander took off his gloves almost immediately after insertion and flew the entire rendezvous that way. You took yours off sometime later, didn't you?
I kept mine on after we'd done a lot of transfer. I can't remember exactly.
Kept your gloves on too? You kept your gloves?
Okay. After insertion, I did most of my pre-insertion work with the gloves on because I didn't want to take the time. I want to get that initial ag solution, and I could get that fairly rapidly with the gloves. And I didn't take the gloves off until maybe 10 or 15 minutes after insertion. But I kept the helmet on all the way through most of the transfer, just to avoid breathing the dust because I'd had the irritation, sinus irritation on the surface.
And the commander kept the helmet on throughout the rendezvous and docking. I took my gloves off after insertion and left them off. Now, when we started getting prepared, as soon as we were hard docked, the commander took off his helmet. And as I look back at that, because of the dust debris in the LEM spacecraft, I'm sorry I did it. I could have left the helmet on, and I would have had a lot less, not troublesome, but it was just eye and mouth type of irritation. You knew you were in a very heavily infiltrated atmosphere in the LEM because of the lunar dust. Although I don't know how much lunar dust previous flights had, but I think we saved a great deal of grief by taping up, by sweeping all the dust we could find on the floor into the holes and putting our tape covers over those holes. I think that had to help a great deal because there was an awful lot of dust on the floor that we didn't see. So I had, commander had his helmets and gloves off throughout the entire transfer. Basically, the way we handled the transfer was the way we had planned. I think the LEM pilot did most of the preparation of the gear in the LEM, and the commander stayed in the tunnel and passed things on, and the inventory was going on the command module side and on the LEM side both. We vacuumed each other's suits the best we could, and everything else that got supposedly transferred unbagged or uncovered.
This is the LMP, and in spite of the CMP's comments to the contrary, I think we got things remarkably clean, and there wasn't an awful lot of dirt in the command module coming back.
Really was.
Oh, that's true. I didn't want to lose that impression. Okay.
Contrast, he may have thought it was dirty, but I was surprised we were able to keep the level of, pardon the expression, contamination of the command module down.
That atmosphere that the commander was referring to in a LEM after he took his helmet off, I could go halfway through the tunnel and stick my head up into the command module, and it was a totally refreshed, unpolluted atmosphere up there that never did get polluted.
I think having that vacuum cleaner running in the LEM had a lot to do with keeping the flow in the other direction and filtering out the air.
Oh, I did too. We never did vacuum in the command module because it just wasn't necessary. It wasn't necessary to vacuum in the command module at all.
And the suits were noticeably cleaned by the vacuum cleaner. You could could tell you were pulling stuff off of them, although they were still dirty, and every other subsequent time we handled them, we got our hands dirty. But I think most of the tree dust was taken care of.
We effectively stayed on a transfer list. I say effectively throughout that transfer. However, some things got transferred out of order and got temporarily stowed in the command module, but we effectively used the transfer list as not as a cookbook, follow recipe type of thing, but as an inventory list. And we inventoried it several times from both ends and found out that we were satisfied we had everything transferred, and then pressed on with the LEM closeout. LEM closeout went nominal. We got back into the LEM, or into the command module, and the commander closed out the LMP closed out the LEM, and for convenience, the commander effectively went back and closed out the LEM hatch, put in a command module hatch. Because of the slow tunnel vent, or the long duration of tunnel vent, the commander stayed in the tunnel, the LMP in his seat and the CMP in the left seat. We suited up and got prepared for our integrity check, and as soon as the LEM tunnel vent was complete and we were satisfied with the integrity of the hatch, we went into the suit integrity checks.
Yeah, this is CMP. Let me make another comment on the tunnel vent time. I'll bet it must take, and I'm not sure this is correct, but I bet at least 3 or 4 times longer than the simulator is for the tunnel vent move.
And I think that's going to be applicable to Skylab because of their docking. They're going to have to vent before they undock. It took quite a while. But tunnel closeout was easy. We had no drogue and no probe, which were stowed in the LEM for LEM jet. Going through the rest of these mine triggers under lunar modules and through TEI, we just followed the checklist, and it all seemed to happen just as advertised.
Well, we got a little bit intrigued with the LEM jettison. You know, this time it was great, and it just sailed out there nice and pretty, and we got a lot of good pictures of it where we should have been maneuvering, and we ended up getting into P41 for the set burn a little bit late, but that's no problem either because we just trimmed the residuals in P41 and got a good set burn.
I want to make a comment that I think cleaning control in a command module was excellent, considering all the dust and all the dirt that just seemed to adhere to everything in the LEM. When we got back in a command module, with the exception of the suits and with the exception of the LMP and the CDR, everything was clean. And that, for the most part, is because everything was bagged before we brought it over, bagged and zipped. And we never did open anything once we got it zipped up. So the command module stayed, and I think that suit fan filter is probably going to be very, very clean, stayed exceptionally clean throughout the remainder of the flight.
Let me add in the bagging, the decontamination bags, I made a special effort as per request pre-launch to pull those zippers as tight as I could, and they should be pretty tight sealed.
Okay, orbital navigation, high gain, why don't you pick that up?
Okay, I've already, from set to TEI, I have no comments. High gain always worked good. Omnis and S-band were good. Photography went as advertised. We have a lot of targets of opportunity. Sim-Bay operations have been mentioned before.
Let me just make one gross comment about the way we handle it as a 3-man crew at Sim-Bay operations, which after...
Didn't we get that yesterday?
Did we?
Yeah.
Okay, it's covered.
I think it's covered.
I think I did say so.
Yeah, you did.
Okay, the TEI updates, nominal. Section and star checks were good for TEI.
Got the commander's master allowance, every one of them, all through the flight, which made me feel very good.
Yeah, but you kept trying to get it.
I made sure
Yeah,
I got
sure you got it.
I made sure I got it on those last few. I wasn't going to change any mode of operation. I'll tell you that last one. Well, reentry was the last one, but I made sure I got it on TEI. Just make you guys feel at home. I figured you'd think I didn't do it right if I didn't get the master allowance.
The TEI half G, or whatever we were pulling there, seemed like more than that.
Quite noticeable.
Yeah, it sure did. It seemed like it was really pushing you back in the seat. Yeah. Ron and I both, I think, started out holding our heads up and eventually relaxed them back on the couch.
I guess we must have had the spacecraft pretty well stowed or tied down, because as I briefed the CFP and LMP, and as I recall those kind of burns back on Apollo 10, lots of things start moving through the spacecraft and find their due on the aft end of the spacecraft because of the G load. And much to my surprise, all we had was initial thud as we moved away from the station, and we didn't have any gear coming from anywhere flying through the spacecraft. So we must have cleaned it up pretty well.
I caught a white tagged wet wipe.
A white tagged wet wipe. But other than maybe one or two of those things, in looking back, I would have expected more gear to come from somewhere, but we prepared for those burns pretty well.
Well, that brings up another point that reminds me, though, is that there is always water condensing on the ECU unit, the pipes and what have you back in there when you get back to clean the suit circuit return valve. And when we put our suits on for the EVA the next day, your suits were noticeably wet. Mm-hmm. And also, when I pulled the PGA bag up, it was damp down underneath the PGA bag. So I think as a nominal procedure, we should have, either after the burn, probably before the burn, made sure we wipe with the water in the LAB somehow to do that.
I wasn't really aware. Our suits were damp when we put them out, but I was not aware. I could look down there, and I could not find any real water down there. But on ECS.
Yeah, on ECS, there's always water down there in ECS, and I just assumed that's where all that came from. But
funny, it was all over.
It's not a puddle of water, like you say. It was just damp.
It's almost as if it was colder down in the LOB and water was condensing on all over the suit. It wasn't as if they were in a puddle.
Yeah. Okay, I think that covers right on through TEI.
Let's see. Yeah, the one thing I want to mention on TEI is that again, the simulator is set up such that in the roll deadband, it goes over to one side of the roll deadband and just kind of stays there. And during the TEI burn, it was bouncing back and forth from one side of the deadband, throw over to the other side of the deadband. And when it's bouncing back and forth, the roll rate is up around 4/10 of a degree per second, arcing back and forth across the roll deadband.
Okay, 14.0 Trans-Earth Coast, and the thing that I just realized we've neglected to say anywhere about systems, I'd like to mention chlorination at this point in time. I think without fail, did you ever talk about it?
No.
I think without fail, almost every chlorination leaked. Sometimes larger quantities of water, other times just small quantities of water, and I'll tell you where it leaked.
Water or chlorine?
Well,
or both. It's a combination.
Chlorine, and you're chlorinating, and buffer or water when you withdrew the buffer sample. But where it leaked appeared to me to leak within the ampule itself around the bag, because it was the chlorine, the cylindrical chlorine dispenser that was continually wet. It was not where the dispenser fit into the needle, or where the needle adapter fit into the spacecraft. It was within the barrel chlorine dispenser itself, and we continually, chlorination was a case of always cleaning your hands with chlorine, because you always had it available down there within that dispenser, and in some cases you had larger quantities of water that had to be wiped up with a tissue. That plagued us throughout the whole mission. It turned out not to be a serious problem because we learned how to handle it, but that was one system anomaly that never had really been brought out.
Okay, let's see, CMP, let me amplify that a little bit. In 2 cases, I'm almost positive that when you put the thing on in the bayonet fitting and crank it on there, it did not puncture the ampule itself. And the reason I believe that's correct is that when you start to crank the outside of the cassette down to push the chlorine into the water system, it was very hard to turn. And if you tried to force it, you could force it on down there, and I'm sure that's a good way to break an ampule on the thing. And if you take it, I just, in 2 cases, took the bayonet fitting loose again and put it back on there, and in both cases, then you just try to squeeze the chlorine out of the ampule into the system, and it would turn easier. But it's still hard
awfully hard to
crank that thing down.
But we did not, we got the chlorination done. We didn't miss any injections of chlorine, and we didn't miss any of the buffer samples. So I guess we got the job done. It was just a little bit messy. And chlorine was evident, and because the CDR eventually peeled all the outer skin off his right hand, and I'm convinced it was due to the chlorine and had nothing to do with the EVA.
Boy, you lost a little flesh, a little skin on the
Trans-Earth coast, systems, navigation. Let's press on and see what we can say about that.
Do you want to have lunch today?
Okay, well, let me see how much Trans-Earth coast we're going to do. Let's go through up to the CSM EVA anyway.
Okay.
Okay, Trans-Earth coast, the first thing I want to mention is passive thermal control was at what I would call unusual latitudes because of the UV and IR requirements. Now, these unusual latitudes did 2 things. They required us to remaneuver the spacecraft several times and enter and exit PTC several times, which in itself was not a problem. It was just additional coordination. Coincidentally, most of these particular PTC attitudes were within 30, certainly 45 degrees of gimbal lock most of the time. So we were looking at the red apple good portion of the trip home. But they also, some of those attitudes where you actually were not in, we were in attitudes and or PTC at these relatively unusual positions, change the equilibrium heat load on the spacecraft. You could see it in RCS, quad temperatures were all right, but you could see it in helium package temperatures. And most notably, you could see it on the change in condensation from the tunnel hatch to the forward hatch. The tunnel hatch eventually, for most of the way home, ended up to be very dry. And about the second day out on the way home, the center hatch got soaking wet to the point that I even took a dry rag and wiped off some of the latch components and some of the gearbox components externally. Not that it did any good, but there was just that much water on it. I think this is all due to the PTC attitudes required for the Simba experiments on the way home.
It was colder in the spacecraft, too.
Oh, yes, it was colder in the spacecraft.
Not as cold as the commander thought it was.
That's right. Cold enough to warm up.
On the commander's orders.
And I just mentioned we warmed it up with the ground suggestion of an extra inverter and going to manual on the temp in. I think we discussed that yesterday.
Ron, all your rough map changes, your torquing, platform torquings, all those went very well, I thought.
They went great, really well.
And all the way back home, it was just changing attitudes, with the exception of the EVA day, which we'll cover here shortly.
CSM EVA. Okay, on EVA prep, I think the only anomaly we came across was the CMP's, well, let's see, on EVA prep, but we really didn't have any. We didn't know anything at that point. On the, I was going to say on the CMP's compare. But the EVA prep went right down the line, essentially. It was all well laid out within the experiments checklist, and we checked things off as we went, and stayed pretty much on the timeline. We started about a half hour early and stayed a half hour early.
We started. We were half hour early throughout the whole thing, and we lost that half hour and opened the hatch just about. And turned TV on exactly on time, and I can't remember a small little something we were chasing down. Comp carrier change. We lost that half hour during a comp carrier change on a tone. Ron, I'd like to add that post EVA, that I think one thing that helped us immensely on what ended up to be, I think, a very fine entry stowage was that we sort of backed off after the EVA and took a good long list at the long-range stowage as well as the post-EVA stowage, and really effectively started housekeeping, cleaning up the cabin, and effectively stowing some of the articles that were not going to be used any further in the mission for entry at that time.
At that point in time, yes, we
So our
did.
entry stowage really started with the post-EVA time frame period, and I think that really helped us out in the long run.
Okay, I think we should mention how we got out of the suits on the thing. To me, that was a pretty important way to get things done. And
the only change to the prep and or post was the order in which we doffed and donned suits, because it was very evident that there were certain convenient ways, because of the way the student suits were stowed and the way people fit into the checklist, that we, when we donned the suits, the commander got donned.
You got him first, and I did.
Then the LMP and the CMP got donned last, and it worked out very fine that way. Plus, the CMP had less work to do in his suit, which also aided him in the long run. When we doffed,
I went first.
the LMP
Yeah, because I was stuffing
went first,
Okay, then you.
then the CDR, and then the CMP. And that wasn't exactly the way it was called for, but that's the way it worked out.
That's the way it worked out the best.
And we stowed our suits in the L-shaped bag prior to putting the center couch back in, which was another good decision, I believe, in helping us get the suit stowed back in that L-shaped bag.
Go ahead. Okay, let's go on down cabin depress. No problems. A normal depress. Hatch opening. Even though the hatch was completely, or the cabin was completely depressed, I think we're reading zero pressure on the thing. As soon as I opened the hatch, there was enough residual pressure or something inside the spacecraft that it actually tended to pull the hatch out of my hand.
Your suit is bleeding into the cabin all the time, so you never truly get zero.
That's right, you never truly get zero on the thing, but the dump valve was still open. And if I had not been hanging onto the hatch, it would have blown it all the way open.
Well, Ron, to give you an idea, that's not unexpected, because it's exactly what we had on the lunar surface. We completely dumped the lamp and I'd still have to break that hatch loose and hold it open about 6 or 8 inches until things just vented, and then I could leave go of the hatch and open it all the way. If I didn't, it would slam back closed.
So we had an inward.
Oh, yeah.
Different type of.
So it was basically the same thing. You got to open it and really let things get down to zero.
Okay, well, when I opened the hatch, then all of the excuse me, all the little ice crystals and everything started flowing out. A pin went floating by, and something else went floating by. Wasn't quite sure what it was. But there's all kinds of little particles and pieces start coming out through the hatch.
But I sure didn't see. I looked specifically for the scissors. I didn't see any scissors go out that hatch. I hate to say it.
None of them went by my watch.
I didn't. None of them went by me. Ron, I'd like to say that they went out the hatch, but I sure didn't see them go. Sure, you didn't see them go by?
I caught the one thing and started to go by me, and we put it in your pocket. You got it. Push straight. Okay, once all the particles and junk was out of the way, then you just push the hatch open. We had disconnected the counterbalance with the tool B there, so that we locked the hatch in the open position. So I just shoved it open, and it went beyond the center position and locked in the open position with no problem. Egress. I had a tendency, I guess, just like any other thing, it seems like you want to float up. And I had a tendency to float up against the MDC and had to consciously duck and get my face as close as I could to the bottom of the hatch in order to get the OPS past the MDC and get on out. TV and DAC installation worked fine. I could hang on with the right hand on the hatch, the great big D handle on the hatch, and with the TV pole in my left hand, and it worked out real fine. Just stick it in there and then line it up with the mark and make sure it was locked in or clamped in. And then climbed on up the pole to turn the TV on, or turn the DAC on. And it was, you couldn't see the light. I couldn't see the light on the thing, but you could feel the camera running once you turn it on. You could just touch it and you could feel it vibrating a little bit. The lunar sounder cassette retrieval, I think that should be on the onboard or on the air-to-ground tapes. As I was describing most everything that was going on, there's no problem. The pan camera cassettes were next. No problem on the pan camera cassettes. In the pan camera, it's obviously a bigger mass, and it's quite apparent when you try to move that big mass around that it is heavier. It weighs more than the other things. It's easy to move, but it just takes a little more effort to get it started. And you know that if you ever get it started in one direction, it's going to keep on going. You have to stop it. So I just moved everything real slow, tried to keep it under control. Mapping camera cassette had the same problem I had in the Simbay C² S², getting the thermal cover off. It's stuck underneath the mapping camera laser altimeter door. But there was no real problem. I had the feet in the shoes, just give it a big jerk, and then it finally came off. Simbay inspection, that's all covered in the onboard, the air-to-ground tapes. TV and DAC removal, again, was real simple. Just had to squeeze the lever, and TV came out, and it was easy to hang on with one hand and maneuver the TV around and point it toward the moon, because I didn't have to worry about shining it into the sun. When I tried to, again, hang on with one hand and point the TV around toward the Earth, the Earth was, well, maybe 10 or 15 degrees, probably 15 degrees from the sun. And I tried to be a little more accurate on the thing, and when I did that, then I lost
kind of effectively really lost control of my body position because I was trying to I think, maneuver the camera. And you need both hands to maintain your body control again. So rather than try to flash the camera through the center or something like that, I gave up on trying to point the camera out the air. Comm during EVA was loud and clear for me throughout the EVA. There was a lot of background noise, the hissing of the airflow, and I'm sure that was probably coming over the Vox circuit. But
I don't think anyone didn't appear to me that anyone had any trouble on the ground reading.
I think one of the big advantages there around the LMP, that one thing we did, because it was bothering him at first, I turned your Vox sensitivity down about 2 notches. And apparently that really improved the comm form, is the impression I had.
I had that impression from the ground. I don't know if it made any difference or not, but I got the impression that did help.
Comm into the cabin was excellent. I never had any trouble understanding you. I had the hissing in the background, but we...
yeah, I thought it sounded much better than I remembered other flights sounding. On the air to ground.
Well, our CMP made more noise than us.
I guess I used the wrong word better. It was clearer.
Clearer. Ingress seemed to me like it was easier than the egress.
Yeah.
For some reason. Hatch closing was harder than I anticipated. And I guess maybe this is the same reason is that I must have been exhausting into the cabin all the time. And just that the hatch would come closed to within about an inch of closing on the outer edge, and then it took an effort to pull the hatch closed so that you could activate the latching handle, so that you could get the latches over center. Of course, once you got the first stroke on the latching handle and got the latches over center, then it's real easy. Just a couple more cranks on the hatch closing. Cabin repress was nominal.
Let me add my comments here. This is LMP. All I did was work in the hatch area, and I want to emphasize, I think what everybody has always said is that you do your best work when you take things slow and easy and just let yourself move yourself in small increments to where you want to go. You can turn and dip and raise yourself up. And I think it's also useful for any cabin hatch or port operations to have somebody else available to push you out on your tether as far as you want to go or pull you in. It just eases the operation. Gene was doing this occasionally for me. With the struts and everything available there was never any feeling that I didn't have a way to control my body position. Sometimes it took a few seconds to get it where I wanted it, but it was clear. The one thing, invariably, every time I went back inside, I had this 90-degree disorientation feeling for a few seconds until I got the perspective of the cabin again and said, okay, that's right. And I get back in, and then I'd go back outside, and I come back in again, and then once again it seemed as if the cabin had rotated 90 degrees to my perspective. And it's just something that's no problem. It's just a change of perspective for some reason that I experienced several times. I guess the biggest problem working in that angle for me, sun angle, or attitude, was I had the sun full face.
You had the sun in your eyes most of the time.
And so it made it hard to look in detail and see what you were doing. You were clear image, you were there, and I could see every major operation doing it, but if I had to specifically see details, it was...
I know one point I wanted to make also was that I had no awareness whatsoever that I had an umbilical on my back. I never got the feeling that the umbilical was tugging on me, restricting my movements, or anything. I didn't even know it was there. And did you observe at any time, did the umbilical ever get tangled around my feet?
The umbilical was easy to tend, and I frankly don't remember a single time when I had to clear it. There may have been one.
I mean, I have a vague impression that one time I asked you to hold up, or maybe I didn't say anything, I just moved it away from a handhold or something, but the umbilical was very, didn't tend to snake around, and it was, you seemed to have everything you needed on it.
It worked out real
Not a problem at
good.
all.
I didn't even know it was there. I guess that's the point I was making, is that really being tied to the umbilical does not restrict your movement or give you a feeling that it is restricting your movement at all. Suit doffing and storage, I think we've already discussed that. This is continuing on the EVA part of it, but no, this is a different section here, suit doffing and storage. We've already mentioned the suit doffing and storage. The light flash phenomena, three of us were blindfolded for an hour and never saw a light flash.
That was the second round.
The second round, on the way back, and Trans-Earth. Eating, resting, exercise, and comfort.
Let me add to the light flash, this LP, that the next, that evening, I guess it was, I did see them again, falling asleep. So.
I did too.
So there was just that period, apparently, during the actual experiment that for some reason they weren't visible.
I think we've discussed the eating, resting, exercise, and comfort already. Cabin atmosphere. The one thing that I don't think we've ever mentioned yet, and I think should be noted, is that we never really utilized the waste storage vent to get rid of any odors out of that waste storage compartment. And if you kind of drifted over in that area, it was always apparent you were in that area if you got real close to it. I thought it was.
I never noticed.
I never noticed.
I think
I guess maybe I did when you opened the door. That's when you really noticed it.
The cabin generally turned over the atmosphere in pretty good style. It got saturated sometimes with gas, and it took a few minutes. But once the source of that gas was plugged up, the cabin did a good job of recirculating and cleaning out the.
I think it did. I think real good.
Flight plan updates were super. The flight plan was excellent, and they were held to a minimum, and we really didn't change any part of the entire flight except a few dates and times and what have you here and there. Attitudes. But other than that, it was really at a minimum. Let's say the entry preparations really began after EVA and continued all through the next day. And we had very little final stowage to do on entry morning. Just those things that we had to leave unstowed until we got out of our sleep restraints. So we basically just had to tie the big bags down on A1 and 2 and 7 and 8. And final entry preparations went by the checklist. And if anything, we stayed about 5 minutes ahead throughout the entire checklist, including separation and activation of the command module RCS, and picked that 5 minutes up, of course, right at 05G, which came on time. The communications, I thought, were very good through that period of time. We were through Araya the last couple minutes prior to our RT. And I understand now the ground heard everything we said right on through blackout, into blackout. And then and as soon as we came out of blackout, they still had Araya, and they could read us, and we could have read them, but they never transmitted anything.
Oh, that was it. Okay.
Yeah.
I'm running out of tape here.
No, I can't think of anything else.
Well, on the corridor check, so we got Horizon and Moonset, right?
Yeah.
Without any, with problem of looking, but.
But we had them all, and they all were within seconds of the actual time.
They were all within seconds, and you know, in the CMS, I'd always look for the 2G when the corridor light would go out, though. I didn't even notice it in the flight. So I was either watching something else, I must have been checking the EMS or the
most of my streaks appeared to be on the periphery. And for the first several days, I got the impression that this direction was predominant. Later on, it appeared that I don't think I could get that good a pattern, but that was my first impression for the first couple of days.
The next question is, was there any apparent direction of propagation? And could you tell it was coming from one side to the other, or was it just a flash?
Several times you did say from the left to the right or something like that.
Tried to correlate it, but in my case, I couldn't really correlate a pattern out of it.
Yeah, I would think that the time period in which we tried to report them streak by streak, flash by flash, was representative. And it was my feeling that it was generally random during that time period, and therefore generally random throughout the times that we were noticing them.
No, I meant, could you detect that it was moving from one side to the other in general?
Yes.
It was moving in
a specific
Oh,
flash.
in a specific flash, yes.
But you could see it as a travel from one side to the other.
Yes.
You really
I think we tried to report it that way, didn't we?
Yes, you
Yeah,
did report it.
that's the way it was.
Puzzling is because it happens. It has to be very fast, you know.
Isn't that question kind of redundant then?
I don't believe you.
Was there some character to these flashes that had some aspect of direction? I mean, were they all the same rod shaped, or did they have a tail on them?
Well, what I saw, what I reported as a streak was simply that. Now, maybe the way we determined the direction subconsciously was that it was a ball of light moving in a direction, leaving a tail. But I can't say that for sure. All I reported was a streak, and I had the impression of it moving from one direction to the other. And I reported that direction, and I can't clarify it much more than that.
Maybe while you're asking a question, we just douse the lights. I think they can see this in the darker room, but just try. The idea is to try to see whether this is what you saw or similar to it.
I think you need the lights out there.
Well, can you see anything?
Yeah, except that's what it looked like, except it was traveling. In other words, it started out and it definitely progressed across the field of view.
Direction of motion per individual.
Was it that bright?
Yeah, except you're not traveling. It was traveling.
You saw it as a point that made the street.
I never did see two simultaneously either.
Neither did I.
Now you have two streaks on that. I never saw that.
At one time you said you saw a semicolon-shaped thing.
Saw what?
A semicolon-shaped object. This was in the first report. Before the.
I never did.
If I reported it, that's what I saw, but I don't remember it.
Did you see anything that looked like this?
All I can say is whatever was reported is what I saw.
No, we discussed the various shapes prior to flight, and I concentrated pretty hard on trying to see the shapes, and I think as I reported, it was either a streak and just a rather simple streak, or it was a flash and rather a simple flash, nothing too exotic about it, and on a more rare one would be maybe just a pinpoint of light for an instant, rather than get the idea of a flash. So it would just be a pinpoint for a second and it would be gone. But that was more rare than the other two.
By a flash, you mean a distributed sort of thing?
Yeah, I meant like watching an explosion. Just a ball versus just a steady dot. Yes.
Was it like this at all? Can you see that?
No.
Can you see this one?
Can't see it.
We're not getting any light.
I don't think it's lighting.
Oh, there was something just as you turned it there.
Okay, I can see that.
I mean, multiple.
Well, this one.
Okay, that to me would be the pinpoint that I'm describing. The eruption, or the nova as we call them, would be more of an explosion.
Yeah.
How about this?
Yeah.
Were there more dots than that?
Well, you've got a very, very bright center and a diffused edge, I would say that the impression I had was you would have an area like that indicating a blow up, but the center wasn't predominantly that bright. But that's getting closer to what we would call, or what I would refer to as a nova or a flash.
That's not as bright as what I call a nova, yeah.
Ed, was your nova an explosion like this or a discrete bright flash?
No, it was, what I called a nova was more of a blob that seemed to start with that and kind of expand.
More diffused.
Yeah, and more diffused as the time went on.
But brighter than that?
Brighter than that, yes. That's about what I'd call a flash or a star.
Here again, you've got too much contrast between the center and the diffused area there, though.
That's some light.
Also, your time frame that you're flashing, that's too long. It was faster than that.
But am I right, Ed, from what you just said, that when you said flash, you really meant a star and not what you just described?
I think I almost tended to use flash and star interchangeably.
That's not true for you.
No, when I flash, nova to me were essentially the same thing. The only distinction I make is the pinpoint versus an explosion.
Okay, I think what Stu was calling a pinpoint was about what I'd call a star or a flash. And a nova, to me, was a much bigger, brighter thing.
Okay, a couple of quick ones. First of all, the cabin lighting. Exactly, was it completely dark, or were there some instrument lights still on?
Absolutely dark.
Absolutely dark. Okay.
Wait a minute.
Well, yeah, there is.
You're talking about the time period that we ran this quantitative report, right?
Right.
So, completely dark.
Okay. And did you have your eyes closed most of the time, or were they open in the dark cabin?
Mine was
we had
closed.
both.
Yeah,
I had both.
Even though we had the window shades on, when we roll around so the sun would hit some of the windows, there'd be some light seepage around, and we were aware of that ahead of time. So that during that time period, at least I made an attempt to keep my eyes closed, open otherwise, and of course we closed our eyes when Ed flipped his flashlight on. But generally speaking, eyes were open.
No, mine was almost closed all the time. I was floating down the corner of the LEB, but I kept my eyes closed because I didn't know when we might roll into the sun, and I didn't want to pick up any light at all.
Okay, the next question on the flashlight was when you shined it in your eyes, what was the approximate duration in each eye? About how many seconds?
Well, I just kind of moved it across for 5 seconds or so. 5 or 6 seconds. It hurt. It was very bright.
And next question on still your orientation in the LEB. You said you were looking toward plus X. Were you across?
I was generally, you know how you have the 3 couches, and plus X is I was oriented this way with my head looking face up down in this corner.
So your head was in the same direction as it would be if you were on the couch, just rotated 90
Yes,
degrees.
that's it.
And next question is, in almost every case, you did report that it was in one eye or the other. I believe there's one incident where you had both eyes. And my question is, it may be somewhat redundant, but were you absolutely certain that you could distinguish that it was one eye as opposed to...
Yeah, I felt I was getting more in the left than the right for some reason.
Well, in fact, you're all heavily biased towards the right on your reports.
Really?
Very heavily, like 3 or 4 to 1.
I would have sworn that I was biased to the left.
You had 12 right and 6 left, and Al, you had 10 right, 4 left, and of the ones you reported, Stu, you had 6 right and 2 left, and the rest were either no reports or both eyes. It was all very heavily biased to the right eye.
That's very surprising.
No, well,
While we're talking about that, it seems to me that I would get a flash or a streak or whatever the phenomenon, whatever the shape was, simultaneous with somebody else reporting it.
that's exactly the next question. We there were 3, from listening to the tapes, 3 events, and it occurred in cases where different pairs were involved, which were coincidences. Where I think in one case, Ed, you said flash, and then Al, you said simultaneous with him. I had a flash in the whole right eye. Now, my question would be, when it was simultaneous, was it after he began speaking, or was it in fact, was his words good enough for you to have been a mark on your flash?
Well, certainly within a fraction of a second, I think it was simultaneous.
Yeah, the couple of times it happened to me, it was his mark or whoever's mark it was good enough.
Okay.
Same here.
And then the next question is, earlier, before the session, and when you were describing some of the subjective observation, you mentioned the halos that you'd seen. That you'd see a flash followed by...
and we finally got Stu to take his halo off and put it away. Excuse me, I'm sorry.
Well, okay. Now the after effects, were they present most of the time? Did you have cognizance of a spike and then a sort of a glow afterwards?
Only on what I call the nova or the supernova.
Is that true for you too, Stu?
I didn't really notice a halo effect myself.
I guess I'm not sure what we're calling the halo effect. You mean a diffused brightness?
More like an afterglow. Halo.
Did I call any of those? I sure don't remember it.
No, Ed described it.
Yeah, I don't think I saw any of those.
Okay. And the other question we had was, do you remember making any observations in lunar orbit? It's not, I know there were no formal periods, but
You know, I thought about that on the way back, and I was so tired that night that I really don't remember seeing any flashes, but I didn't look for any either. So I guess the question would be, I consciously did not see any, but I wouldn't take that as a data point.
Okay, that's fine. And then the final question that I have is, after our formal session, that was at about 191 GET. You then had a sleep period later on. Do you remember whether you saw any during that sleep period closer in?
It's significant whether you're inside the magnetopole or not.
I don't consciously recall, but I don't really recall that there was any night, except on the lunar surface, that I didn't, at some time or another, see some.
You didn't see any on the lunar surface?
I don't remember about the lunar surface. There was precious little sleep that night anyhow. So.
Okay, well, that's all the questions I had.
We douse the light for a minute.
While you're dousing light, I have one additional question. Did you get the impression that light flashes could have been within the cabin or definitely within your eye?
Definitely within the eye.
Okay. I want to get some idea about orientation and length of the streets. Did you ever see anything that looked like that?
No, I never did.
You use the terminology of 6 o'clock or hours of the clock. Does that mean to you, when you say 6 o'clock to the center, about how long a street is that? That's a hard question to answer. If you were visualizing something about about the arm's length away from you, how long would you say your longest streak was? That long? You see my fingers? I'll show it on the...
Let me describe it a different way. It appeared to me that the things, I would say, were 3 or 4 inches away from my plane, whatever that means, and were a couple of inches long.
Tell us what it means.
That makes sense. A couple inches long, 3 or 4 inches in front of you. It looked like this.
Too long for me.
There were 2 of them, I guess. See that one up above?
The one up above looks better.
Okay. How about this?
Probably fairly close.
Yeah, I'd say it's probably about as close as the longest one.
See, I'm not sure what our scale is here. I'd rather say that if I'd consider whatever it may be, but the field of view of, say, my right eye, and take a radius of that I'd put a streak at of about a half the radius would be the average streak.
Half or a little longer.
Okay. You think, is there any way that you can associate this length of streak to what you said, Stu? Was it longer or shorter, or can you say?
Well, it would depend on how big a circle I want to draw from my field of view. Yeah, I saw streaks that long because with my eyes closed, I imagine a rather big field of view here in my eye. So yeah, I'd see streaks that long.
One time you said you saw streaks oriented in a certain direction. Do you remember that? Which
Yes,
direction?
the way you had it. Bring it on up that way.
And Ed, what about you?
Well, I think I had them from several directions, and I reported them as moving from one direction to the other at that time. There were several of them, though.
How about Al? Any particular direction, up and down, left and right?
I didn't notice any preferred orientation, and here again, I think that try to express the length of the arc of the flash in terms of the peripheral field. And if you're talking about a horizontal peripheral field as being somewhere in the vicinity of 150 to 160 degrees, then in some cases the light flashes would go across as much as 50 or 60 degrees of that.
Yeah, that's interesting.
Were the light flashes broken in the center?
In some cases they were. In some cases I had the feeling it was two dots, one immediately following the other, giving the impression of right to left, or top to bottom, or bottom to top, or left to right.
The point is, you see that the retina is so curved that if you draw a straight line, you can't get too long. You shouldn't be able to get too long a streak without breaking out of the retina again. You know, in the plane of the retina, it's shaped like that.
But it has some depth, does it not?
If it had been any longer than that, if it just is on the retina.
Can't hear that.
Through a couple of portions.
Can't hear you.
It should not have been any longer than what I showed you if it just went through the retina as one track, but if it went through a couple of eyes, then you'd have the impression of a long streak. That's why we're interested in the character. I have one more about the cloud that you saw. This is a new phenomenon which we hadn't expected. Can you describe this lightning behind the cloud?
I think it occurred, I reported it a couple of times, and it appeared, as I recall, to be down low on one eye or the other, and it was just a diffuse lighting.
Any color?
White, silver.
If you were out in the country and looking at the horizon and there was lightning behind a cloud, was it like that?
Except generally if you do that, you can see a streak behind the cloud. There was no streak, it was just a diffuse lighting.
Simulator, something like that. We have a little gizmo that will simulate that sort of phosphene. When you get out of quarantine, maybe have a look at it.
One last attempt to try to do the cloud here. You douse the lights a minute. Good job. Hey, still wet. Was it anything like that?
I didn't see it.
It's pretty dim cloud, right?
Maybe I'm not dark at that, but I still don't see it.
I haven't seen anything on it yet.
Okay.
Okay.
But what you're trying to describe is just what we used to call heat lightning as a kid.
Yeah, this is a general diffuse light.
Yeah.
You didn't see the relief of the cloud, did you?
No, not necessarily. No. It's just a blob of light.
The one final question. We did voice up to your question about whether you noticed any other sensations besides flashes, which was the reason for asking that was that if it was, did you feel any tingling or find yourself twitching or hear anything? The reason for that is that if it is an interaction back in the brain, then your other senses are just about as sensitive as your visual sense, and maybe you should feel something, but you never noticed anything.
Didn't notice it.
Didn't notice any sensation.
There's two things to think about. Did you notice your thumb itching or your lips twitching?
Ridiculous.
No. Never look for it either.
Well, it's, these are suggestive questions, and the fact that you say no is significant.
You can press on with different parts of the anatomy, you might get a yes, but it has nothing to do with
Well, those are the two biggest cross sections for.
If there's something significant about your thumbs or your lips, maybe you should warn people to look for that, because I don't know, unless it's going to be so obvious that you would.
Are you saying itch all over?
Well, sometimes you might think you should be. Feel very comfortable.
Okay, thanks very much.
So,
I think I said to Ed yesterday that you really did provide an enormously improved amount of data on this phenomenon that we've had in any previous flights. That's great.
Well, I would add this, that I think that's the way you really have to go, is to take a definite period, set it aside to do it, because otherwise it's so random and so many other things going through your mind that it's the only way you get anything quantitative out of it.
However, you did a remarkable job of concentrating on that length of time. Do you feel that was being unreasonable to ask you to do that without you going to sleep or something like that? It's a pretty boring thing to do, just sitting there lying watching them. Do you think we should be in planning for doing this sort of thing on future missions, that we shouldn't try and do much more than we try to get you to do, because it's just too much just to sit there lying there trying to concentrate that length of time?
Well, if you can find a time period during the flight when the crews don't have anything else to do, I think it's reasonable to suggest that, yeah.
I don't think I would do it before a sleep period or when they're tired or they'll go to sleep on you.
Yeah, and I think along that line, Phil, by the time if you talk a little bit pre-flight like we did, and then the phenomena is there, because your first sleep period, or the first time you get the spacecraft dark and close your eyes, you're going to see flashes, and so then that sort of sparks your curiosity a little more, and then when they say let's settle down and count them, well, I think you're agreeable to it.
Fine. Okay.
Hey, one other comment on that, and I'm not even sure that it's related, but I really think that this is just a general impression, that if I would look at say the glove of the wristwatch or something like that, and then close my eyes again, I'd almost always see a flash. And I tried then to correlate looking at say a crack through the window shade, or looking at my watch or something, and then closing my eyes, and I really came to the impression that the two may have been correlated, but I never really looked at it enough to say that for sure. But I think there was a correlation between seeing a light of something like this and then closing your eyes, and pretty soon you'd pick up that flash.
That's an important observation. If the action is directly in the bipolar or the retina cells, the outer segment, you might expect it to behave the way electrical phosphates do, rather than just from light, which takes dark adaptation. What do you think about that, Ed?
I'm not quite sure what your point is. I was going to make the comment that with respect to the flashes, putting the flashlight in my eyes did not seem to destroy my dark adaptation. Now, what that means, I don't know.
Did you do like that?
Yep.
That slow? Or that fast?
Yep, for some time.
You certainly wiped out some of the nerves.
I wiped out something.
Wiped it all out.
I'm not sure that's true, Chuck.
How long did you do it?
You should wipe it all out.
A couple of minutes, minute.
A minute, back and forth like this. About 5 seconds per track?
Something like that.
Yeah. Hey, now I know
what you're saying, though, is that the reason you think you didn't knock it all out is because you could still see the flashes? Is that what you're saying?
Well, the cockpit looked different. Remember, I was doing this eyes open. And it seemed like, with just what I consider dark adaptation, that I was more dark adapted, that I dark adapted much sooner after doing that than I did when we started the experiment.
You would. Oh,
Yeah. Sure.
Yeah, that you would do.
Because you wipe out the cones less with that, just with the flashlight you do with the tungsten light or
Hey, I'd like to make sure that on this dark adaptation. Now, I know during the formal hour or 40 minutes, whatever it was, that Ed was shining the light. But I don't know whether you picked it up on air to ground or not. But I had done that prior to that during one of the sleep periods, and there's just, you do not have to be dark adapted to see these beauties.
Yeah, I think that's a conclusion drawn from what Ed's saying.
That's a very significant data point, because it almost certainly proves that it's not a real light in your eye, generated in your eye. It's actually an interaction itself.
Yeah, but why did it take us so long when we started the experiment before we saw anything? It was quite a while, and yet when I wiped the light across my eyes, within 30 or 40 seconds, there they were again.
17 minutes.
Pardon?
17 minutes. No response from you.
Yeah, But when I did it with the flashlight, within 30 or 40 seconds, they were right there again.
You said that they were fainter. They seemed fainter than they had on previous times that you observed them, and there definitely is a threshold effect of some sort, because you saw twice as many during that period as the other two did. And I think maybe it's just, my guess was when you didn't see them and then you started to see them regularly, was that it was just that they were fainter. They seemed fainter than you expected, and so it took you a while to sort of get your attention down to fainter ones than what you were looking for.
Well, that may be the case, except they did indeed appear fainter in the beginning, and it wasn't a matter of looking for fainter objects. They were brighter after a while.
And for you, Al?
And they didn't diminish in brightness when I did the flashlight across my eyes. They were still just as bright 30 seconds later as they had been before I used the flashlight. And that's why I'm questioning the dark adaptation bit. Either I didn't wipe the dark adaptation out, or there is something related to dark adaptation that influences the phenomenon. I don't understand it. It doesn't make sense.
That doggone time period that we did it, and the few flashes we saw was very surprising to me. And we talked about this and we commented on it at the time. Boy, it seemed like, you'd wake up during a sleep period and...
They were all over the place.
Now, here again, maybe I'd lose track of time. You're laying there in the dark cabin, and maybe it was longer than what I thought, but it just seemed like that, there's abundance of flashes. And I was amazed when it took 17 minutes to see a flash. I thought any time that you wanted to close your eyes, you were going to, and concentrate on it, you were going to see these things.
That's why I suggest that you really ought to set a time period aside, because it is such a random function as far as I'm concerned. That to try to do it on a non-quantitative basis is awfully tough.
Yeah.
Plus the fact that I think that each individual is going to report at different levels of activity too. I had the feeling there was maybe some little faint things that I would sort of see that I didn't want to talk about because I couldn't define them as a flash.
Yeah, I had those too.
So
I think also it's a good idea to do it this way, because your subjective impression is not necessarily right. Like you felt that you saw more from your left eye than your right, and that wasn't true.
It was wrong.
So we need to get the data real time.
When you go to sleep at night, do you see any of these things? Most people do see something as they're going to sleep in a darkened room. They can't get to sleep right away. Down here.
I think everybody does.
Certainly, I don't know.
Yeah, you got lights blinking around, in your eyes if you get in a real dark room occasionally. But maybe it's because we've never really concentrated on looking for this particular type of phenomenon.
These phenomena that you saw were different from the ones that you see once in a while.
Oh, definitely.
Certainly a lot more frequent.
Yeah.
No question about that.
How about in brightness?
About what?
Brightness. It's hard to say.
Yeah.
I guess I'll make a note to see if I see any of those, from here on. But I certainly haven't since we've been back. But here again, and Ed mentioned this, and I agree with him, but it's another subjective thing, that the flashes you see when you wake up in the middle of the night as a whole appear to be brighter than the flashes as a whole during that experiment that we did during the day. And I'm like Al, I was a little reluctant to call anything except a very positive flash during that time frame. I wanted to make really sure that was indeed a mark at the time that I called it. But those that you saw during the middle of the night appeared to be brighter, and like I say, appeared to be more of them. But here again, you may lay there for an hour and you think it's 5-10 minutes or something. I don't know. Maybe you lose track of the time, but it's a subjective thing.
Ed saw one blue flash. Did anyone else see color?
No.
Wait a minute. No, that wasn't blue. It was a silver, a blue-white sort
Like
of
a
thing.
blue diamond, you said.
Like a blue diamond. Yeah.
Was that the brightest that you saw?
I don't recall it was the brightest. No.
Has anybody been hit in the head and seen stars?
Yeah.
You have?
Yeah.
Were these anything like that?
I think think I'm more concentrating on the pain.
When you go to bed tonight, if you in a dark room, if you just knuckle your eyeballs, you should see flashes, and it might be worth trying that to see whether they look like the same sort of.
Yeah, we cry a lot in here.
Okay.
No, I'll say, you know, if you can get the next cruise interested, Phil, you know, it makes a great topic of conversation, and, you know, during the flight you got nothing else to talk about, you can talk about light flashes. So, you know, I think you get the crew's curiosity aroused, right, it's a good deal.
Well, I think the interest, the pressure on the subject, which is built up, is such that there will be some formal experiment on 15 is probably the way to go. Okay.
Thanks very much.
Thank you.
Now we'll keep back in touch with you and let you know what we're going to do with this other thing and what we're going to do, how things are coming time-wise for the end of the business too.
For the what, Chuck? For
the totally. You know what the date is. You know what the time is now. 07:31 on Saturday.
The release time, you mean?
Yeah.
Work on springing us early, Chuck.
Somebody said that the 21 days ended up on Saturday morning,
Yeah.
We've been led to believe otherwise, Chuck.
In the debriefing plan, it says 0800 the 26th on Friday.
Deke says we get out Friday morning.
Yeah, he called me yesterday. Yeah, he called me last night. He says, "How the hell did we ever get this number here?" I said, "I don't know where you got that number."
Well, the radiation people are here. We're talking about release and all that kind of business. Can we get a hack on when they're going to get total body counts?